Welcome to my Ultimate Git Mastery course. Over the next 5 hours, you're going to learn everything you need to know to use Git like a pro and work effectively with others. We're going to start off by talking about the fundamental concepts like what is Git, how to install and configure it, and then in each section, we're going to explore a different set of Git tools. We'll cover creating snapshots of your code, browsing your project history, branching and merging, collaborating with others using GitHub, and rewriting history. I'm Mosh Hamadani, and I'm super excited to be your instructor. Now let's jump in and get started. All right, before we get started, let me tell you something super important real quick. If you want to get the most out of this Git course and become a Git expert, you should watch every lesson in order. Don't skip any lessons, even if you think you know the basics. Trust me, there are a lot of bad information and misconceptions about Git out there. A lot of people don't know how Git really works, and that's why they constantly screw things up and jump on Stack Overflow for help. I don't want you to be one of them. So I've put tremendous effort into creating this course to make sure you really understand how Git works and how you can use it like a pro. But that would only happen if you watch every single lesson in order. This course is short and sweet. It's only 5 hours long, but teaches you a ton. You know me, I'm not going to waste your time with BS. With that, now let's move on to the next lesson. So what is Git and why is it so popular? Git is the most popular version control system in the world. A version control system records the changes made to our code over time in a special database called repository. We can look at our project history and see who has made what changes, when, and why. And if it screws something up, we can easily revert our project back to an earlier state. Without a version control system, we'll have to constantly store copies of the entire project in various folders. This is very slow and doesn't scale at all, especially if multiple people have to work on the same project. We will have to constantly toss around the latest code via email or some other mechanisms and then manually merge the changes. So in a nutshell, with a version control system, we can track our project history and work together. Now, version control systems fall into two categories: centralized and distributed. In a centralized system, all team members connect to a central server to get the latest copy of the code and to share their changes with others. Subversion and Microsoft Team Foundation Server are examples of centralized version control systems. The problem with the centralized architecture is the single point of failure. If the server goes offline, we cannot collaborate or save snapshots of our project. So we have to wait until the server comes back online. In distributed systems, we don't have these problems. Every team member has a copy of the project with its history on their machine. So we can save snapshots of our project locally on our machine. If the central server is offline, we can synchronize our work directly with others. Git and Mercurial are examples of distributed version control systems. Out of all these, Git is the most popular version control system in the world because it's free, open source, super fast, and scalable. Operations like branching and merging are slow and painful in other version control systems like Subversion or TFS, but they're very fast in Git. We'll talk about this later. So Git is almost everywhere. More than 90% of software projects in the world use Git. That's why almost every job description for a software developer mentions Git. So if you're looking for a job as a software developer, Git is one of the skills you must have on your resume. You should know it inside out, you should know how it works and how to use it to track your project history and collaborate with others effectively. And that's exactly what you're going to learn in this course. Let's talk about various ways to use Git. We can use Git on the command line, so we open a terminal or command prompt window to execute Git commands. This is the fastest and sometimes the easiest way to get the job done. That's why a lot of people use the command line. Now, if you don't like the command line, well, you're in luck, because most modern code editors and IDEs have built-in support for basic Git features. For example, in VS Code, we have this source control panel, which gives us the essential Git features. There are also extensions available for bringing additional Git features. For VS Code, the most popular extension is GitLens. It brings a ton of Git features in VS Code. There are also graphical user interfaces specifically made for using Git. Here on the Git website, you can find the complete list of these tools for different platforms. We have tools for Windows, Mac, Linux, Android, and iOS. Out of all these, the two most popular tools are GitKraken and SourceTree. GitKraken is my personal favorite GUI tool for Git. It's beautifully designed, it works across different platforms, and it integrates with other GitKraken products such as GitKraken boards for issue tracking and GitKraken timelines for project management. It's free for open source projects, but for commercial projects, you have to pay an annual fee. Just to let you know, I'm not an affiliate of GitKraken, I'm just a fan. The other option is SourceTree. It's completely free, but it's only available for Windows and Mac. So if you're a Linux user, you have to use GitKraken or another GUI tool. In this course, we'll be spending most of our time on the command line for a couple of reasons. The first reason is that pretty much all of these GUI tools have some limitations. They support the Git commands that people use most of the time. So even if you want to use a GUI tool, there are times you would have to roll up your sleeves and get back to the command line to get the job done. The other reason is that the command line is always available, but there are situations where a GUI tool may not be available to you. You might connect to a server remotely, and you may not have permission to install a GUI tool. If you don't know how to use the command line, then you're stuck. In practice, a lot of people, including myself, use both the command line and a GUI tool, and that's what I'm going to show you in this course. There are times that it really makes sense to use a GUI tool and not the command line, but there are other times that using the command line is faster and easier, so we'll use the command line. At the end of the day, you should use the right tool for the job. Don't be like this guy. You probably know him. Our popular superstar developer called John Smith. He thinks he's better than everyone else because he does everything in the command line. He never uses a GUI tool and he looks down at people who do. Well, let him think whatever he wants if that's what makes him happy. Who cares? So we'll be spending most of our time on the command line, but when it makes sense to use a GUI tool, I'll be showing you examples in VS Code and GitKraken because those are the most popular tools. Now, if you have never worked with a command line before, don't worry, I'm going to hold your hands and teach you everything step by step. It's a lot easier than you think. So next, we're going to install Git. All right, let's see if you have Git on your machine or not. And if yes, what version you have installed. To do this, you have to open a terminal or a command prompt window. If you're on Mac, press Command and space and then type terminal. If you're on Windows, click the search icon on the bottom navigation bar and type CMD. So here's my terminal or console window. Your terminal window might look different. It doesn't matter. This is where we're going to execute Git commands. So let's look at the version of Git on this machine. We type git -- version. So on this machine, I'm using Git version 2.19.2, but the latest version at the time of recording this video is 2.27.0. So I highly encourage you to download and install the latest version. Just head over to git-scm.com/downloads. Over here, you can find instructions for installing Git on different operating systems. It's really easy. You're not going to have any problems. Now, if you're on Windows, once you install Git, you're going to get this application called Git Bash, which is short for Born Again Shell. This is basically a command prompt window, like this one over here, but it emulates Unix or Linux environments. So throughout this course, I encourage you to use Git Bash instead of the built-in command prompt window. So what you see on the screen looks closer to what I'm going to show you in this course. So go ahead and install Git. In the next lesson, I'm going to show you how to customize our Git environment. The first time we use Git, we have to specify a few configuration settings. We have to specify our name, email, default editor, and how Git should handle line endings. We can specify these configuration settings at 3 different levels. At the very top, we have the system level. The settings that we have here apply to all users of the current computer. Below this level, we have the global level. The settings here apply to all repositories of the current user. And below this level, we have the local level. The settings here apply to the current repository or the repository in the current folder. So we can have different settings for different repositories or different projects. So here in the terminal window, we type git config, then we type -- global to specify the level at which we are defining these settings. Next, we should specify the setting we want to configure. So user.name. Here we type double quotes and type our name. Now, the reason we're adding double quotes is because we have a space in this value, okay? So that was the first setting. Once again, git config -- global. This time we're going to set user.email. Now, because we don't have a space in emails, here we don't need double quotes. So let's add our email. All right. Next, we need to specify our default editor. If we don't set this, On Mac, by default, Git is going to use Vim, which is a scary editor. A lot of people are freaked out by it. In this course, I'm going to use Visual Studio Code or VS Code. You can use any editor that you prefer. But if you want to follow along with me, I highly encourage you to download the latest version of Visual Studio Code from code.visualstudio.com. Now, on this machine, I've added Visual Studio Code to my path, so I can open it from any folder on my machine without specifying the full path. So if I type code, here's VS Code. If this doesn't work on your machine, you have to troubleshoot the issue yourself. Depending on your operating system, there are different instructions for adding VS Code to your path. So back to the terminal, let's set the default editor. Git config -- global. The setting we want to configure is core.editor. Once again, we need double quotes because here we're going to have a space. The value for this setting is code space -- wait. With the wait flag, we tell the terminal window to wait until we close the new VS Code instance. Okay, so let's go ahead. Now, all these configuration settings are stored in a text file. We can edit that file using our default editor, in this case, VS Code. So we can type git config -- global -e. This will open our default editor to edit all the global settings. Let me show you. So, all right, here's our configuration file. You can see the full path to this file on the top. The name of this file is git config. Now in this file, we have different sections. So we have the user section with 2 settings, name and email. We have the core section with these 2 settings and so on. Now back in the terminal window, you can see the terminal is waiting for us to close VS Code. So let's close this window. Now we are back in the terminal and we can execute the next command. Next, we're going to configure how Git should handle end of lines. This is a very important setting that a lot of people miss. So on Windows, end of lines are marked with 2 special characters, carriage return and line feed. On Mac and Linux systems, end of lines are indicated with line feed. So that means if we don't handle end of lines properly, we're going to run into some weird issues down the road. To prevent this, we have to configure a property called core.autocrlf, which is short for carriage return line feed. So let me walk you through a real scenario. Let's say we have 2 people here, John and Julie, working with the same repository. John uses a Windows machine, Julie uses a Mac. As I told you, on Windows, end of lines are marked with carriage return and line feed. So when John wants to check in his code into the repository, Git should remove the carriage return character from end of lines. Similarly, when he checks out his code from the repository, Git should update end of lines and add the carriage return character. To achieve this behavior, we should set this property to true. On the other hand, when Julie checks out the code, she doesn't want the carriage return character. So Git shouldn't touch end of lines. However, if carriage return is accidentally added to end of lines, perhaps because of the editor that Julie is using, Git should remove it when storing the code in the repository. To achieve this behavior, we should set this property to input, which means Git should only modify end of lines when storing code in the repository. So back in the terminal, we type git config -- global core.autocrlf. If you're on Windows, you should set this to true. If you're on Mac or Linux, you should set this to input. Let me show you a few different ways to get help about Git commands. Let's say you want to learn more about the config command. You can simply Google git config. On this page, you can see the full documentation of this command. You can see various options and how they work. We can also access the same page on the terminal window. We simply type git config -- help. This is exactly the same information you saw a second ago. Now here we can press space to go to the next page and Q to exit. Now, if you don't need a full-blown help, you just need a quick refresher, you can type git config -h. This gives us a short summary of this command and its options. So we're done with the introductory stuff. Starting from the next section, we're going to cover a lot of Git commands. Now, below this video, you can download a PDF of all the commands we're going to cover in this course. If you're starting out, don't worry too much about memorizing these commands. Instead, try to understand how they work. As you practice Git in the real world, all these commands are going to become second nature to you. Trust me. So download the cheat sheet below this video, and then I will see you in the next section. The first thing you need to know to use Git effectively is how to take snapshots of your project, which is what we're going to talk about in this section. We'll be talking about the fundamental concepts in Git that are often misunderstood. So make sure to watch every lesson in this section, even if you think you know the basics. A lot of people use the basic Git commands without having a proper understanding of how Git works, and that's why they constantly get stuck. So watch every lesson in this section. Now let's jump in and get started. All right, the first thing we're going to do is create a directory for our project. You can call this directory anything and put it anywhere on your machine. It doesn't matter. I'm currently in the projects directory. So let's create a directory called Moon and then go into this directory. So let's imagine this is our project directory. And here we can have tens or hundreds of files. The first time we want to add these files to a Git repository, we have to initialize a new empty repository. So we type git init. Look at this message. Initialized empty Git repository in, and here's the full path. So we have the Moon directory, and inside this directory, we have a subdirectory called .git. By default, this subdirectory is hidden because you're not supposed to touch it. So if we type ls to list all the files and directories here, we don't see anything. But if we type ls-a, which is short for all, we can see the Git subdirectory. If you're on Mac, you can open this with Finder. And if you're on Windows, you can open it with Windows Explorer or File Explorer. I'm not sure what it's called these days. So let's open .git. Take a look. So here's our Git directory or Git repository. This is where Git stores information about our project history. So we have directories like branches, hooks, info, objects, and references. Now, as someone using Git, you don't really need to understand this structure. This is purely implementation detail. It's how Git stores information. It's none of our business. That's why this directory is hidden, so you don't touch it. If you corrupt or remove this directory, you're going to lose your project history. Let me show you. So back in the terminal, look at this green marker. It says Git. That means we have a Git repository in this directory. Now, if you want to have a pretty colorful terminal window like this, on Mac, you need to install ZSH or Z-Shell, and on Windows, you need to install PoshGit. But don't worry about it now. These tools are completely optional to use Git. It's just for making things pretty. So here we have a Git repository. Now, if I remove the Git subdirectory, we're going to lose this repository. So rm-rf.git. Look, the green marker is gone. We don't have a Git repository here anymore. So don't touch this directory. Now, once again, let's initialize a Git repository. Beautiful. So now that we have a repository, next we're going to talk about the basic Git workflow. Now that we have a Git repository, let's talk about the basic Git workflow, what we do on a daily basis when using Git. So here's our project directory, and here's our Git repository, which is actually a hidden subdirectory in our project directory. Now, every day, as part of working on various tasks, we modify one or more files. When our project reaches a state we want to record, we commit those changes into our repository. Creating a commit is like taking a snapshot of our project. Now in Git, we have a special area or a special intermediate step that doesn't exist in most other version control systems. It's called the staging area or the index. It's essentially what we're proposing for the next commit or the next snapshot. So when we're done making changes, we add the modified files to the staging area or index, review our changes, and if everything is good, then we'll make a commit. The proposed snapshot will get permanently stored in our repository. So the staging area allows us to review our work before recording a snapshot. If some of the changes shouldn't be recorded as part of the next snapshot, we can unstage them and commit them as part of another snapshot. That's the basic Git workflow. Now let me walk you through a real example. This example is crucial, so pay close attention all the way to the end, even if you think you know the basics. Our project directory is currently empty, so we add a couple of files here. Now we are ready to record this state. So we use the add command to add these files to the staging area. Now these files are in the staging area. This is the state we're proposing for the next commit. We review these files, everything is good, so we use the commit command to permanently store this snapshot in the repository. As part of this, we supply a meaningful message to indicate what this snapshot represents. This is essential for having a useful history. So as we fix bugs, implement new features and refactor our code, we make commits, and each commit clearly explains the state of the project at that point in time. So now we have one commit in our repository. Now, a common misconception about Git is that once we commit the changes, the staging area becomes empty. This is not correct, and I think this is why a lot of people find Git confusing. So what we currently have in the staging area is the same snapshot that we stored in the repository. So this staging area is actually very similar to a staging environment we use when releasing software to production. It's either a reflection of what we currently have in production or the next version that's going to go in production. So let's continue with our example. Let's say as part of fixing a bug, we make some changes to file 1. Note that what we currently have in the staging area is the old version of file 1 because we haven't staged the changes yet. So once again, we use the add command to stage the changes. Now what we have in the staging area is the same content we have in our working directory. So let's make a commit to record this state. Now we have 2 commits in our repository. Also look at the commit message. It's describing the bug that we just fixed. Now let's say we realize that we no longer need file 2. It contains unused code. So we delete it from our working directory. But this file is still in the staging area. So once again, we should use the add command to stage this change. In this case, the deletion. This is the interesting part. Even though we're saying add file 2, Git knows that file 2 is actually deleted. So it will delete this file from the staging area or the next snapshot. Again, we make a commit to permanently record this state. Now we have 3 commits in our repository. Each commit contains a unique identifier that gets generated by Git. It's like a revision number. Each commit also contains information about what was changed, by who, when, as well as a complete snapshot of our project at the time it was created. So unlike many other version control systems, Git doesn't store the deltas or what was changed. It stores the full content. With this, it can quickly restore the project to an earlier snapshot without having to compute the changes. Now you might ask, but hey Mosh, wouldn't storing the full content in every snapshot waste a lot of space? No, because Git is very efficient in data storage. It compresses file contents and doesn't store duplicate content. Now, as someone using Git, you don't really need to know how Git stores data. That's implementation detail and may even change in the future. What you need to know is that each commit contains a complete snapshot of our project, and this allows us to quickly get back to a previous state. So that's the basic idea. Over the next few lessons, you're going to see this workflow in action. Let's start by adding a couple of files to our project. To do that, we're going to use the echo command. This is not a Git command, it's just a standard Unix or Linux command for writing content to a file. So here we're going to write hello to file1.txt. So here I'm working with a text file because I don't want this course to be specific to people who know a particular programming language like Python or JavaScript. What I'm going to show you in terms of the workflow applies to any programming languages, okay? So we write hello to file1.txt. Good. Now let's execute this command one more time and change file1 to file2. So now we have 2 files in our project. Now look at this question mark here. That means we have new files here that are not tracked by Git. Because the first time you initialize a Git repository in a directory, Git is not going to automatically track your files. So if you have 1,000 files in your project, you have to instruct Git to track them, okay? So here we're going to run git status to see the status of the working directory and the staging area. Take a look. So we don't have any commits yet. We have untracked files, which are file1 and file2. They're indicated by red because they're not in the staging area yet. To add these files to the staging area, we use the git add command. Here we can list a single file, like file1.txt, or multiple files separated by a space. We can also use patterns. So star.txt. That means all the files with the txt extension. We also have period, which adds the entire directory recursively. Now you have to be a little bit careful with this because sometimes there are files you don't want to add to your repository, perhaps large files like large binary files or log files. You don't want to add these files to your repository because they increase the size of your repository. I will show you how to ignore these files later in this section. So just remember, add period adds the entire directory recursively. In this demo, I'm going to go with this command because we only have 2 files in this directory, okay? Now our green indicator changed to yellow, which means we have stuff in the staging area that are ready to be committed. So if we run git status again, look, we have 2 new files and they're indicated by green, which means they're in the staging area. Now let me show you something interesting. I'm going to modify file 1. So once again, we're going to use the echo command to echo world. But here, instead of 1 greater than sign, I'm going to use 2 greater than signs, which means append. So we're going to append world to file1.txt. Now let's run git status again. Look what happened. We have 2 files in the staging area because they're indicated by green, but we also have 1 modified file in our working directory. So you might be asking, but hey Mosh, didn't we already add file 1 to staging area? Yes, we did, but when we ran the add command, Git took a snapshot of file 1 and added that snapshot to the staging area. So here's the current situation. In the staging area, we have the first version of file 1. We changed this file after we added it to the staging area. So what we currently have in our working directory is the second version of this file. It has some changes that are not staged yet. So back to the terminal, we run git add period or git add file1.txt one more time. Now look at the status of our working directory. Both these files are in the staging area and we don't have any unstaged changes. So next I'm going to show you how to commit this snapshot to permanently store it in our Git repository. Now we have a snapshot in the staging area ready to be permanently stored in our repository. So we type git commit -m for message. And here in double quotes, we type a short description that identifies what this snapshot represents. So here I'm going to say initial commit. Now there are times that a short one-liner description is not sufficient. You want to explain some details to give context. For example, if you worked on a bug and there were some constraints at the time you committed your code, you may want to explain those constraints. This is very valuable to both you and your coworkers. So in situations like this, we drop the message. We just type git commit. Now when we press enter, this opens our default editor, in this case VS Code, because at the beginning of the course, I configured my default editor to be VS Code, okay? So here we're trying to edit this file, commit _edit message, which is stored in our git subdirectory. So on the top, we can type a short description. Ideally, this should be less than 80 characters. Then we add a line break, and after that, we can type a long description. Now, these lines that start with a £sign are comments. They're going to get ignored. So we type whatever we want here. In this case, I'm going to say initial commit. And this is our first commit. Of course, this is repetitive. We don't want to have commit messages like this. But for this demo, I'm going to go with this message. So we save the changes. Then we close this window. Back in the terminal, our snapshot is committed. And here we have basic statistics about what was changed. So 2 files were changed, which are file 1 and file 2. And we have 3 insertions. 3 lines were inserted. In file 1, we inserted 2 lines, hello world. And in file 2, we inserted 1 line. Now look at this indicator. It turned green because our working directory is now clean. It doesn't have any new changes. So what we have in our working directory is exactly the same content we have in our staging area, which is exactly the same content we have in the last commit. Let's talk about the best practices for committing code. First of all, your commits shouldn't be too big or too small. We don't want to make a commit every time we update a file. That's just useless because we'll end up with commits like update file 1, update file 2, update file 3. It's just useless. On the other hand, we don't want our commits to be too big. We don't want to wait and implement a feature end to end before committing it. We don't want to code for 3 days and then make a commit because the whole point of committing is to record checkpoints as we go. So if you screw up, we can always go back and recover our code. So try to commit often. In the real world, you might commit 5 to 10 times a day or even more, depending on the kind of work you are doing. But this is just a basic guideline. Don't take it as a rule. Don't try to aim for 5 or 10 commits a day. So as you're coding, as you reach a state you want to record, then make a commit. Also, each commit should represent a logically separate change set. So don't mix things up. For example, if you're fixing a bug and then you accidentally find a typo in your app, you shouldn't commit both these changes in one commit. You should have 2 separate commits. One commit for the typo, another one for the bug fix. Now, if you accidentally stage both these changes, you can easily unstage them. I will show you how to do this later in this section. Next, you should give yourself the habit of creating meaningful commit messages because all of these messages are going to show up in history. So if your messages are cryptic, they're not going to be helpful to you or other team members. Now, if you followed my previous advice, if your commit represents a single unit of work, it would be easier to come up with a message for your commit. If you're doing too many things in one commit, you're not going to come up with a good message, okay? Now, in terms of the wording, most people prefer to use the present tense in their commit messages. So instead of fix the bug, you should say fix the bug. If you don't like this convention, that's totally fine, but whatever convention you use, make sure that you and other team members stick to it. So always take these best practices in mind when committing code. One of the common questions a lot of beginners have is, do we always have to stage our changes before committing them? Well, the answer is no. And in this video, I'm going to show you how to skip the staging area. But do this only if you know what you're doing. If you're 100% sure that your code, your changes don't need to be reviewed, because that's the whole point of having a staging area. So let's modify file 1 and then commit it in one step. We're going to say echo test to file1.txt. Once again, we're appending this line to file1.txt, okay? All right. Now we have a yellow indicator because our working directory is dirty. So instead of running git add and then committing it in 2 steps, we're going to commit. Here we're going to supply the option -a, which means all. That means all modified files. And then, just like before, we supply a message, or we can combine these 2 options. So let's supply a message. Fix the bug that prevented the users from signing up. Let's go. Our code is committed. 1 file was changed, and we have 1 insertion. So this is how we can skip the staging area. But once again, do this only if you know what you're doing. 99% of the time, you should always stage your code before committing it to the repository. Let's say that we just discovered that we no longer need file 2 in our project because it contains unused code. So to remove this file, we type rm file2.txt. Again, this is not a git command because it doesn't start with git. It's just a standard Unix command, okay? So let's go with this. Now we have a yellow indicator, which means our working directory is dirty. So let's run git status. We have 1 change that is not staged for commit. So we remove file 2 from our working directory, but it still exists in the staging area. Let me prove it to you. So we type git ls-files. These are the files in our staging area. So file 2 is still here, even though we removed it from our working directory. So as I told you before, every time we make changes, we have to stage those changes using the add command. So here we type git add file2.txt to stage this change or this deletion more accurately. Now let's run git ls-files one more time. So file 2 is no longer in the staging area. Beautiful. Let's run git status. We have 1 change that is ready to be committed. And as you can see, it's indicated by green, which means it's in the staging area. So let's commit this change. And here we're going to say remove unused code. So to remove a file, we have to remove it from both our working directory as well as the staging area. Because this is a very common operation, Git gives us a command that does both of these steps in one go. Let me show you. So we type git rm. So instead of using the standard rm command in Unix, we use git rm. Here we list a file name, like file2.txt. We can also specify multiple files. We can also use patterns, like all text files. When we execute this command, Git removes this file from both the working directory as well as the staging area. Now let's talk about renaming or moving files. So currently we have a single file in our working directory, and that is file1.txt. Let's rename this to main.js. So we use the move command in Unix to rename file1.txt to main.js. So with this command, we can rename or move files and directories, okay? Now our working directory is dirty, so let's run git status. We have 2 changes, and both these changes are unstaged because they're indicated by red. We have a delete operation. We deleted file1.txt, and under untracked files, we have a new file. So as you saw at the beginning of this section, Git doesn't automatically track all your new files. Every time you have a new file in your project, you have to add it to the staging area, so Git starts tracking it. So once again, we have to use the add command to stage both these changes. Git add file1.txt. This is for staging the deletion. And now let's add the new untracked file, main.js. Now let's run git status one more time. Look, Git recognized that we renamed file1.txt to main.js. And this item is indicated by green, which means this is in the staging area. So renaming or moving files is a two-step operation. First, we have to modify our working directory, and then we have to stage two types of changes, an addition and a deletion. So similar to removing files, Git gives us a special command for renaming or moving files. That is git move. So instead of using the standard move command in Unix, we're going to use git move. Now let's rename main.js to file1.js. And then run git status one more time. So we have a rename operation for renaming file1.txt to file1.js. So when we use the move command, the changes are applied to both the working directory and the staging area. Now, let's commit the changes. For the message, I'm going to say refactor code. Now look at the statistics. One file was changed. We have 0 insertions because we haven't added any new lines to any of our files. And we also have 0 deletions because we haven't removed any lines from any files. In almost every project, we should tell Git to ignore certain files and directories. For example, we don't want to include log files or binary files that get generated as a result of compiling our code. Adding these files is just going to increase the size of our repository without providing any values. Every developer can have their own log files, right? So log files are not something we want to share and synchronize with other team members. So for this demo, let's create a directory called logs and then add a log file here. Once again, we can use the echo command to write hello to logs/dev.log. Now let's run git status. So Git is saying that we have an untracked directory called logs, but we don't want to add this to the staging area because we don't want Git to track this. So to prevent this, we have to create a special file called .gitignore. So this file has no name, it only has an extension, and it should be in the root of your project. So let's echo logs/to.gitignore. Now I'm going to open this file using VS Code. So code gitignore. So in this file, we have a single entry, logs/, which indicates a directory. We can list as many files and directories we want here. For example, we can include main.log. We can also use patterns, like all log files and so on. Once we are done, we save the changes back in the terminal. Now, if you run git status one more time, Git no longer says that we have a new directory called logs because it's ignoring it. Instead, it says we have a new file called .gitignore. So let's add this file to the staging area and then commit our code. So add gitignore. So this is how we can ignore files and directories in Git. Just remember, this only works if you haven't already included a file or a directory in your repository. In other words, if you accidentally include a file in your repository and then later add it to gitignore, Git is not going to ignore that. Let me show you. So let's create a new directory called bin. Let's imagine that this directory contains our compiled source code. So using the echo command, I'm going to write hello to bin/app.bin. Now let's run git status. So we have a new directory. Now we want to accidentally commit this to our repository. So we add all the changes and then commit our code. Add bin. Here's the problem. Every time we compile our code, Git is going to say that this file, bin/app.bin, is changed, so we have to stage it and then commit it. It doesn't make sense. Why do we have to commit this file every time we compile our application? So back to gitignore, let's add the bin directory here as well. Now back in the terminal, let's run git status. So we have modified gitignore, beautiful. Let's stage and commit this change. So git add period, and then git commit include bin/ in gitignore. Now in this case, Git is not going to ignore the changes in this directory because it's already tracking this directory. So let's modify our bin file by saying echo hello world to bin/app.bin. Git status. Look, Git is saying that this file is modified. This is not what we want. To solve this problem, we have to remove this file from the staging area, which is what we're proposing for the next commit. So earlier we talked about git ls-files. This command shows the files in our staging area. So as you can see, this bin file or the bin directory is already in the staging area. We should remove it here. How? Well, earlier we talked about the git remove command. I told you that with this command, we can remove a file or a directory from both the working directory as well as the staging area. But in this case, we don't want to remove this file from our working directory because that's how we launch our application. So we want to remove this file only from the staging area. How? Well, let's add -h for a quick help. So we type git rm, then we can add 0 or more options. Now here we have this option called --cached. With this, we can remove stuff only from the index. Index is the old term for the staging area. So when you look at Git documentation, most of the time you see index. So using this option, we can remove the bin directory from the index. So git rm --cached bin /. Now we get an error saying not removing bin recursively without -r. So one more time, let's look at the help for this command. We have another option called -r for recursive removal. So we want to remove the entire bin directory from the staging area. To do that, we type git rm --cached -r bin /. Beautiful. Now this entire directory is removed from the staging area. Let's verify it. So git ls-files. Our bin directory is no longer here. Now let's run git status. Look, we have one change that is ready to be committed. This directory is deleted from our staging area. So let's commit the change. Remove the bin directory that was accidentally committed. Okay, from this point forward, Git is no longer going to track the changes in this directory. So if we echo test to bin/app.bin, you can see our working directory is still clean. We don't have any changes. We can verify it using git status as well. So this is how we can ignore files and directories in Git. Now, if you head over to github.com/github/gitignore, you can see various gitignore templates for different programming languages. For example, let's look at the template for Java. So for Java projects, it's a great idea to exclude all the class files because these files get automatically generated when you compile your code. So there's no need to include them in your repository. So here we have various patterns like all the class files or all the log files. The lines that start with a hash sign, these are comments, so they get ignored by Git. So you have learned how to get the status of the working directory and the staging area using the status command. The output of this command is very comprehensive, but it's also very wordy. So as an alternative, we can supply the short status flag or -s. Let me walk you through a few examples. So for this demo, we're going to modify one of our existing files and then add a new file. So echo sky to file1.js. So we're appending a sky to file1.js. Now let's create a new file. So once again, echo sky to file2.js. Now let's run git status. We have modified file1 and we have a new untracked file. So as you can see, the output of this command is very comprehensive, but also very wordy. Now let's run git status -s. This is much easier to dice. So let me show you how this works. Here we have two columns. The left column represents the staging area and the right column represents the working directory. So we have modified file1, and that's why we have a red M in the right column, which is the working directory. So we have some changes here, but these changes are not in the staging area. That's why we don't have anything in the left column. Now file2 is a new file. That's why we have two question marks in both these columns. Now let's add file1 to the staging area. So git add file1 and then do another short status. Look, for file1, we have a green M in the left column or the staging area column. So all the changes that we had in the working area are now in the staging area. In the right column, we don't have anything. We don't have any extra changes. Now, earlier in this section, I told you that when we stage a file, Git takes a snapshot of that file and puts it in the staging area. So if you modify that file after, we have to restage the changes. Let me show you this one more time. So I'm going to modify file1 one more time. Let's echo ocean to file1.js and then run git status -s. Look what we have here. So in the left column, we have a green L, which means we have some changes in the staging area, but we have some additional changes in the working directory that are not added to the staging area. Okay, so let's add file1 to the staging area one more time, and then run git status -s. Now, all the changes that we had in the working directory are now in the staging area. So we're done with file1. Let's look at file2. So I'm going to add file2 to the staging area as well, and then run git status -s. For file2, we have a green A in the left column, which represents added. So file2 is added and file1 is modified. This is how the short status output works. So we have staged a couple of changes. Now, before committing what we have in the staging area, we need to review our code because we don't want to commit bad code or broken code to our repository. So as a best practice, always review what you have in the staging area before making a commit. Now, the status command only shows the files that have been affected, but how can we see the exact lines of code that we have staged? We use the diff command. So we type git diff -- staged to see what we have in the staging area that is going in the next commit. So let's take a look here. Now, quite frankly, comparing files using the terminal window is not really the best way to do this. Quite often we use visual tools, and I'm going to talk about that in the next video. But I think it's essential for you to understand the output of this command because there are times that you may not have access to a visual tool, or at least you may go to an interview and you may get asked, what is the output of this command? So you need to be able to explain it. So on the top, you can see that the diff utility was called with these arguments. So we're comparing A/file1.js with B/file1.js. So we're comparing two copies of the same file. The first copy is the old copy, which is what we have in the last commit. And the second copy, which is the newer copy, is what we currently have in the staging area. Okay. Now, below that, we have index, whatever. This is just some metadata. It doesn't really matter. After that, we have a legend. So changes in the old copy are indicated by a minus sign, and changes in the new copy are indicated by a plus sign. After that, we have this section. This is a header with some information about what parts of our file is changed. So currently our files are very short. They have only a few lines of text, but in the real world, your file might have hundreds of lines of code. If you change only a couple of lines, Git is not going to show the entire file. It's going to divide that file into chunks, and what we have here is just a single chunk. So every chunk has a header with some information that gives you context. So let's see what we have here. We have two segments. The first segment is prefixed with a minus sign. So this gives us information about the old copy, what we have in the last snapshot. The second segment is prefixed with a plus sign. So this contains information about the new copy, which is what we have in the staging area. So in the old copy, starting from line 1, 3 lines have been extracted and shown here. In the new copy, once again, starting from the first line, 5 lines have been extracted and shown here. So these are all these lines over here. Now you can see that these 2 lines are prefixed with a plus sign. So these are the lines that we have added in the new copy. So we have added these lines in the staging area. They're green, which means they're new lines. So pretty straightforward. Now after that, we have another call to the diff utility. This time we're comparing 2 copies of file 2. Now in this case, look at the legend. We don't have an old copy because this is an entirely new file. So in the last commit, we didn't have a file called file2. That is why in this header, we have 0, 0, which means starting from line 0, 0 lines have been extracted because there is no old copy of this file, okay? Now, what if you want to see the changes in our working directory that are not staged yet? To do that, we run git diff without any arguments. So this compares what we have in the working directory with what we have in the staging area. Take a look. There's no output here because we have staged all the changes in our working directory. We can also verify this using our short status command. So all the changes in our working directory are now in the staging area. So for this demo, I'm going to make a change to file 1. So let's open it with VS Code or our favorite editor. So I'm going to change the first line to hello world. Save. Now, let's run another short status. So for file 1, we have some changes in our working directory that are not in the staging area. Let's look at these changes using the diff command. So git diff without any arguments, take a look. So here we're comparing two copies of file 1. The old copy is what we currently have in the staging area, and the new copy is what we have in the working directory. Now take a look. In the old copy, which is indicated by a minus sign, we have this line, hello, which is removed because it's red. And in the new copy, which is what we have in the working directory, we have this new line, hello world. So to recap, if we run git diff without any arguments, we can see unstaged changes. And if we pass -- staged, we can see the state changes that are going to go in the next commit. In the next lesson, I'm going to show you how to use a visual tool to easily compare files. As I told you in the last lesson, quite often we use visual diff tools for comparing files. There's so many visual diff tools out there. The most popular ones are kdiff and p4merge, which are cross-platform, and winmerge that runs only on Windows. In this lesson, I'm going to show you how to use VS Code for comparing files. If you want to use a different tool or a different editor, you have to look up the instructions yourself. So here in the terminal, first we have to tell Git that we want to use VS Code as our default diff tool. So we have to set two configuration settings. So once again, we type git config -- global. So the global settings apply to all of our repositories, okay? Now the setting we're going to set is diff.tool. We're going to set that to VS Code. So with this command, we're just giving a name, in this case VS Code, to our default diff tool. Next, we need to tell Git how to launch VS Code. So once again, git config -- global. Here we set diff tool dot VS Code dot CMD. We set this to double quotes because we're going to have a space. Now on my machine, I've added code to my path so I can run it from any directories. If this doesn't work on your machine, you have to look up the instructions yourself depending on your operating system. So we're going to launch code with a few arguments. The first one is -- wait. This tells the terminal window to wait until we're done with VS Code. So until we have compared the changes and closed the VS Code instance. The second argument is -- this tells VS Code that we want to use it for diffing or comparing files. Then we have two more arguments, $local in capital and $remote in capital. These are placeholders for the old and new copies of a file, okay? So let's set that. Now let's make sure that you have got this step right. So we're going to run git config -- global -e. As I told you at the beginning of the course, with this command, we can edit our global configuration settings in our default editor, which is VS Code. So take a look. So all these settings are stored in this file .getconfig, which is stored in this directory. So we have the user section, which we set earlier in the course. Now here's the diff section that we just set. In this section, we have set the tool to VS Code. This is just a name. Then we have diff tool, VS Code. And here's the command that should be run for comparing files with VS Code. So we have code with -- wait, then -- Now those two placeholders that I added, for some reason they're lost. So let's add them real quick. $local and $remote. Make sure to get this right, otherwise things are not going to work on your machine. Now we're done. So let's close this window. Back in the terminal, instead of using the diff command, we're going to use diff tool. This will launch our visual diff tool for comparing files. Now, if we don't supply any arguments, we're going to see our unstaged changes. So this will compare what we have in the working directory with what we have in the staging area. If you want to look at our state changes, we supply -- stage, exactly the same way we use the diff command, okay? So let's look at the changes we have in our working directory. We have modified only a single file. That is why we have 1 out of 1, and that is file1.js. So Git is asking if you want to launch VS Code, which is the name that we assigned to our default diff tool. Let's go ahead. Take a look. So here's the old copy, which is what we have in the staging area, and here's a new copy, which is what we have in the working directory. As you can see, we can easily tell that this line has been replaced with this line. It's much easier to see the changes. Now the terminal window is waiting for us to close the VS Code instance. So let's close this window. Back to the terminal. Now let's look at the state changes. So git diff tool -- staged. Two files have been affected in the staging area. The first one is file1.js. let's look at the changes. All right, in this case, the old copy is what we have in the last commit, and the new copy is what we have in the staging area. So these are the changes that are going to go in the next commit. You can easily tell that we have added 2 lines here. Now let's close this tab. Back in the terminal, Git is asking if you want to look at the changes in file2.js. In this case, I'm going to ignore that, so no. Like, quite honestly, we don't use diff tools so much these days. I just covered it because I want my course to be comprehensive. These days, most editors and IDEs allow us to view the staged and unstaged changes as part of our development environment. I will show you how to do this later in this section. We have made a few commits so far, but where are these commits? Let me show you. So we use the log command to look at our history. Take a look. So here are all the commits we have created, sorted from the latest to the earliest. So here's our last commit on top. Each commit has a unique identifier. This is a 40-character hexadecimal string that Git automatically generates for us. You can think of it like a revision number, but unlike a revision number, it doesn't increase. It's just a unique identifier, okay? Now, next to that, we have head pointing to master. What is this? Well, we're going to talk about this a lot in the future, but master is the main branch or the main line of work in Git. In some other version control systems, it's called trunk. In Git, we can have multiple branches, so we can work on multiple features or multiple bug fixes in parallel and then combine our code. We'll talk about that later in the course. Now, head is a reference to the current branch. So this is how Git knows what branch we're currently working on. Again, we're going to talk about this a lot in the future. Now, for each commit, you can see the author, the name of the author, as well as their email, the date and time the commit was created, as well as the 1-line description. Like here, we have multiple commits that are spread across multiple pages. We can press space to go to the next page. And again, now to quit, we can press Q. Now, the log command has a few interesting options. One of them is 1 line. This shows us a short summary of the commits. So here we have the unique identifier that is shortened to 7 characters, and we only have the 1-line description. So we don't have the author as well as the date and time of each commit. We have another option for reversing the sort order. Let me show you. So git log 1 line, and then we add -- reverse. Now you can see the first commit be on top, and here's the last commit. Now the log command is very powerful. So in the future, we're going to talk a lot about it. In fact, we have a complete section on browsing history. I'm going to show you various ways to get reports from the history. For now, let's just stick to the basics. So viewing the list of commits is great, but what if you want to see what exactly we have changed in a given commit? That's when we use the show command. For example, let's say we want to look at the content of this commit over here. We type git show. Now here we need to specify the commit we want to inspect. There are 2 ways to reference a commit. We can reference it using its unique identifier. So we type D601B90. Now we don't have to type all the 7 characters. We can type fewer characters as long as we don't have another commit whose ID starts with these characters. So that's one way to reference a commit. Another way is to use the head pointer. So look, head is currently in front of the last commit. So to view the last commit, we can type head, or to look at previous commits, we can type a tilde and then specify how many steps we want to go back. So if we type 1, we start from head, which is here. We go 1 step back, and this references this commit over here. Let's take a look. So on the top, we can see the author and the date of this commit, as well as its message. Below that, we have a diff of what is changed. So in this commit, we have changed a single file, that is git ignore. Over here, we can see that we removed this line and added these 2 lines. So this is very useful. Now, what if we don't want to see the differences? We want to see the final version, the exact version that is stored in this commit. Well, we bring up the last command, git show head ~1, then we type a colon, and here we specify the full path to a file. For example, we can say .git ignore, or if this file is in a subdirectory, we type, for example, bin/app.bin. Okay. Now let's look at git ignore. So this is the exact version stored in this commit. Now, earlier I told you that each commit contains a complete snapshot of our working directory, not just changes. But when we run the show command, we only see the differences, what is changed. what if you want to see all the files and directories in a commit? Well, for that, we're going to use a different command. That's called ls_tree. Now, why is this called a tree? Well, a tree is a data structure for representing hierarchical information. So in a tree, we can have nodes, and these nodes can have children. Now, a directory on the file system can be represented using a tree. Because each directory can have children, these children can be files and other subdirectories. If you want to learn more about this concept, you should take my data structures course. So ls_tree means list all the files in a tree. Now here we specify the commit we're interested in, head ~1. And now look, these are all the files and directories stored in this commit. So we have gitignore. Right before that, we have a unique identifier that is generated based on the content of this file. So in Git's database, we have an object with this ID. Below that, we have bin. Again, it has a unique identifier that is generated based on the content of this directory. Now look at the type of this object. It's a tree. So files are represented using blobs and directories are represented using trees. All of these are objects that are stored in Git's database. Using the show command, we can easily view an object in Git's database. For example, if we type git show and then specify this unique identifier, or we can type only the few characters, as long as there is no ambiguity. So here's the content of our gitignore file. As another example, let's look at this object, this tree, the bin directory. So git show 64629. Here we have a tree. In this tree, we have this file, app.bin. So using the show command, we can view an object in Git's database. These objects can be commits, blobs, which represent files, and trees, which represent directories, as well as tags. We'll talk about tags in the future. So I told you that you should always review the stuff that you have in the staging area before making a commit. So let's say we review these changes, and we realize that the changes in file 1 shouldn't go in the next commit. Perhaps because these changes are logically part of a different task. So we don't want to have a commit that represents changes for different tasks, right? So in this case, we want to undo the add operation because earlier we used the add command to add file 1 to the staging area. Now we want to undo this operation. How do we do this? Well, in the past, we used the reset command, but a lot of people found this command confusing, especially with options such as hard or soft. That's why we have a new command called restore. Now make sure you're using the latest version of Git. Otherwise, what I'm going to show you is not going to work on your machine. So here I'm using Git version 2.28. And with this, we can easily restore files in different environments, in working directory or in staging area. So git restore, we want to restore file 1 in the staging area. So we type --staged, and then we specify the file name. We can list multiple files here. We can also use patterns. Or if you want to restore everything in the staging area, we simply use a period. So here I'm going to restore file1.js. Now, when we run git status again, we are not going to see a green M here because all the changes that we had in the staging area are now in the working directory. Take a look. So git status -s. Look, we no longer have any changes for file 1 in the staging area. All the changes are in the working directory. Now, it's essential for you to understand how the restore command works. The restore command essentially takes the copy from the next environment. So in case of the staging environment, what is the next environment? The last commit, what we have in the repository. So when we restored file 1 in the staging area, Git took the last copy of this file from the last snapshot and put it in the staging area. That is what happened. Now look at file 2. File 2 is a new file because here we have a green A, which is short for added. So we have this file, we have this new file in the staging area, but this file doesn't exist in the last commit. So what do you think will happen when I restore this file? Well, because we don't have a copy of this file in our repository or in our last commit, Git is going to remove this file from the staging area and take it back to its previous state, which is a new untracked file. Let me show you. So git restore --staged file2.js. Now let's run git status again. So file 2 is a new untracked file because we have 2 question marks. There are times that we have some code in our working directory that we want to throw away. Let's say we made some changes, but we didn't like those changes, so we want to scratch everything and start over. we can discard the local changes using the restore command. So here we have some local changes in file1.js. To undo these changes, we type git restore file1.js. When we execute this command, Git is going to take the version of this file in the next environment, which is our staging environment. It's going to take that version and copy into our working directory. We can also use a period here, and this will undo all the local changes. Now, let me show you something. So the command is executed. Now let's run another short status, but file2 is still here. Why is that? Well, this is a new untracked file, so Git hasn't been tracking this. So when we tell Git to restore this file, Git doesn't know where to get a previous version of this file. It doesn't exist in our staging environment or in our repository. So to remove all these new untracked files, we have to type git clean. Now take a look. By default, we get this fatal error saying require force defaults to true, and neither of these switches were given. So basically, Git is telling us that, hey, this is a dangerous operation. If you accidentally remove these untracked files, there is no way you can recover them. So let's run git clean -h for a quick help. Here we have this option, -f, which forces Git to remove these untracked files. We also have -d for removing whole directories. So quite often we type git clean -fd. Now, let's run short status again. File2 is gone. So this is how we undo local changes. So now you know that once Git tracks a file, it stores every version of that file in its database. And that means if you screw things, we can always restore a file or a directory to a previous version. So in this demo, I'm going to delete a file and then show you how to restore it. It's very easy. So we're going to delete file1.js. Now I told you that if we use the rm command in Linux or Unix-based systems, this will only remove the file from the working directory. So then we'll have to stage the change or the deletion. A better way is to use the git rm command. This will remove the file from both the working directory as well as the staging area. Okay, now let's get a short status. So in the staging area, we have a deleted file. Now let's make a commit, delete file1.js. All right, now let's say, shoot, we shouldn't have deleted this file. So what can we do here? Well, we have a few options. We can undo or revert the last commit. We're going to talk about that later in the course. But in this lesson, I want to talk about restoring a file to a previous version, not undoing a commit. So let's look at our history. All right, so here's our history. We want to restore file1 to the commit before the last commit. That is this commit over here. So we type git restore. Now let's have a quick look at the documentation. The restore command takes 3 types of arguments. We can supply a bunch of options. We can supply a source. We haven't done this so far, so by default, Git will restore that file from the Nix environment or the Nix area. So if the file we want to restore is in the working directory, Git will restore it from the staging area. And if the file is in the staging area, Git will restore it from the last snapshot or the last commit. Now in this case, we want to change the default behavior. We want to restore a file from the commit before the last one. So we type git restore --source, we set it to head ~1, and then we specify the full path to the file. In this case, file1.js. Now, let's get a short status. So we have a new untracked file. So this is how we can restore a file to a previous version. All right, now let's look at the Git tools built into VS Code. So here on the left side, we have the source control panel where we can see all the changes in our project. So what we see here is similar to the output of the status command. We can see all the changed files and the kind of changes introduced in those files. So here we have changes in file1.js. We can click on a file to get a diff of that file. Now here we are dealing with a new untracked file, as you can see up here. That's why we don't have any code on the left side. Now we can stage this file by clicking on the plus icon. If we made a mistake, we can always unstage a file. That's very easy. All we have to do is to click on the minus icon. Now we have local changes in our working directory. So let's go ahead and stage this file one more time. Let's say we have reviewed our changes and we want to proceed to make a commit. Up here, we can type a commit message. So for this demo, we can say add file1.js. Just remember, this is not a good commit message because our commit should be based on logical units of work, not individual files added or removed, okay? So let's go ahead and make a commit. Good. Now, back to the Explorer panel. We have a fairly new feature here. I think they introduced it a couple months ago. If we click on a file and then open the timeline folder, we can see all the commits applied to this file. So here's our latest commit, add file 1. We can click on that commit to see the changes introduced in that commit. Here's the previous commit, delete file1.js. We also had another commit earlier, refactor code. Pretty helpful. Now here by default, we don't have a way to look at our history. We need to install a plugin to do that. I'm going to talk about that in the next section. Now let's look at the Git tools built into GitKraken. So here on the homepage of GitKraken, we go to open a repository. Here we can open an existing repository. We can also clone a repository. I'm going to talk about that in the future, but this is basically useful when we have a repository somewhere else, let's say on GitHub, and you want to take a copy of that repository and put it on our machine. Again, we're going to talk about this in the future. We can also initialize a new repository. For this demo, I'm going to open our Moon repository. So open repository, we go to our folder and then open. Good. So over here, we can see all the commits we have created so far. We can see the author of each commit, the commit message, and the date and time when the commit was created. Now we can click on each commit to see more details. So for this commit, we can see the commit ID. Here's the commit message, the author, date and time, and the summary of changes. So in this commit, we added one new file, which is file1.js. Now here we have multiple views. We have the list view and tree view. If you have changed multiple files in different folders, tree view is very helpful. We can also select view all files to see all the files in our project at this point in time. If we uncheck this, we only see the changed files. And by change, I'm talking about additions, modifications, and deletions. Now we can click on each file to get a diff of that file. So once again, we're dealing with a new file here. That's why we don't have any code on the left side. Now here we have two tabs, diff view and file view. If we switch to file view, we can see the snapshot of this file in this commit at this point in time. Now, let's go back to diff view. We also have different ways of comparing the changes. So currently we're looking at the split view, which gives us the before and after code. We also have inline view, which is exactly like what we get in the terminal. We also have hunk view. If you're dealing with a large file with a bunch of changes in different parts of this file, hunk view is an easy way to see the changes in each section. Now let's make a new commit. So we have to go back to VS Code or our favorite editor to make the changes. Because GitKraken is just a GUI tool, it's not a code editor. So I'm going to go back to VS Code, open file1.js and write a new line of code here. Save the changes. Now, back in GitKraken, let's close this window. Over here, you can see we have one change in our working directory. We can click on this button to view the changes. So file1.js is changed and currently it's unstaged. We can click on this file to see a summary of the changes. So this is the new line that we have introduced. Beautiful. Now we can go over here and stage this file or stage all changes. Now this file is in the staging area. If we made a mistake, we can always unstage this file. Super easy. So let's stage the file and then type a commit message. Let's say refactor code. And now let's make a new commit. As simple as that. So this is how we can use GitKraken to create snapshots of our project. But there is a lot more to GitKraken, and we're going to cover that in the future sections. In this section, we'll look at various ways to browse the history of our project. You will learn how to search for commits by author, date, message, content, and so on. We'll also talk about viewing a commit to see what files have been changed and how. Next, I will show you how to restore your project to an earlier point in time to the snapshot stored in one of your commits. We'll also see how we can compare commits to see what files have been changed and how. You will also learn to view the history of a file to see how it's evolved from day one and who has written each line of code. And finally, I will show you a great tool for quickly finding a bad commit that introduced a bug in your application. So there's a lot we're going to cover. Let's jump in and get started. In this section, we're going to work with a project or a repository called Venus, which you can download right below this video. It's basically a Git course represented as a bunch of plain text files. So here we have audience, objectives, sales page, sections, and table of content.txt. This project or this repository has some history that we can work with throughout this section. So download the zip file below this video, extract the content somewhere on your machine. When you're ready, watch the next lesson. All right, the first thing we're going to look at is the log command that you learned about in the previous section. In this lesson, we're going to study this command in a bit more detail. So here in the Venus directory, let's run git log. So here we can see all the commits in this repository. For each commit, we can see its unique identifier or hash. We can see its author, the author name, and email, the date and time it was created, and the one-liner message or subject. Now, by default, all these commits are listed from the newest to the oldest. So here's our last commit. Now, because we have multiple pages here, we can press space to go to the next page. We can also use the up and down arrows to go up and down, like this. Now, to quit, we press Q. Okay. Now, let's look at some of the interesting options of this command. So git log, one of them that you already know is one line, which gives us a summary of all these commits. We can add additional options here. For example, if you want to see all the files that have been changed in each commit, we can use the stat option. Take a look. So in our last commit, 5 files have been changed. Here you can see the name of these files. We have audience.txt, objectives, and so on. In front of each file, you can see the number of changes. So for audience.txt, we have 4 changes. We have 3 insertions and 1 deletion. So 3 lines were inserted and 1 line was deleted. In total, 5 files have been changed, 7 lines have been inserted, and 4 lines have been deleted. Now, we don't necessarily have to use this option with the one-line option. For example, we can run git log stat. Now we have the full details about each commit, okay? Now, what if you want to see the actual changes in each commit? We can use the patch option. So git log, I'm going to use one line and then patch. So in our last commit, here we can see a diff of audience.txt. So these 2 lines were inserted. This line was removed, and then this line was added. Right after that, we have a diff of another file. So for each file, we can see exactly what lines have been changed. In the next lesson, I'm going to show you how to filter the history. In this repository, we have just over 10 commits. But in a real repository, we often have hundreds or sometimes thousands of commits, depending on the age of the repository. Now, we don't want to look at all of these commits. So let me show you a few different ways to filter the history. We can filter by author, by date, by commit message, by content, and so on. So let's run git log one line. Now, if you want to see the last 3 commits, we simply type -3 here. There you go. Now we can also filter by author. So one line. Here we type --author equals, and here in double quotes, we type the author's name. Let's say Mosh. So here are all the commits that I have submitted to this repository. We can also filter by date. So instead of author, we can use before and or after. So we can say, hey, show me all the commits from 2020, August 17. This will return all the commits created on this date and after. Take a look. We can also specify relative dates. That is pretty useful. For example, we can say, hey, show me all the commits from yesterday. Or we can say, show me all the commits from 1 week ago, or 2 days ago, or 1 month ago. Pretty useful. We can also filter by commit message or subject. For example, we can say, hey, show me all the commits that have the word GUI in their message. Here we type --grep equals, and here in double quotes, we type the search term, GUI. Just remember that this operation is case sensitive. So if we type GUI in lowercase, we're going to have a different result. Take a look. Here we have only a single commit that has the word GUI in its subject. We can also filter the history by content. Let's say we want to find all the commits that have added or removed a function declaration. So we type, instead of --grep, we're going to type -S, And here we're not going to use an equal sign. Instead, we're going to add double quotes. And in between the quotes, we're going to type our function name. Let's say all the commits that have added or removed this line. Now, in this repository, we don't have any code. We just have plain English. So let's find all the commits that have added the word objectives in capital. There you go. Here's the commit. Now, if you want to see the actual changes in this commit, we can use the patch option. You learned about it in the last video. So we bring up the last command, and then at the end, we type --patch. So in this commit, this file was modified, objectives.txt. And over here, you can see that objectives was inserted. Very useful. We can also filter the history by a range of commits. So let me bring up all the commits. Let's say we're only interested in the commits in a particular range here. Let's say from this commit to this commit over here. So we can say git log one line. Here we add the first commit hash. So FB0D184. Then we add double periods, and then we type the target commit ID, like EDB3594. Now, what if you want to find all the commits that touch a particular file or a bunch of files? Well, that is super easy. We simply type git log. We can optionally use one line. It's not compulsory. Now, if you want to find all the commits that have modified our table of content file, we simply add the file name at the end. So these 3 commits have modified this file. Now, sometimes depending on the name of your files, Git might complain and say, hey, this name is ambiguous. In those cases, we have to separate the file name from the options over here. So we bring up the last command, and here we use double hyphens to separate the file name from the options we're using here. You don't have to use this all the time. You have to use this only if Git complains about the file name, saying, hey, this is ambiguous, and I cannot figure out what options you're using. So in this case, we get the same result. Now, if you want to see the actual changes in each of these commits, once again, we can use the patch option. However, the patch option should be listed before the file name. So we cannot add it over here. It's not going to work because now, after we added double hyphens, Git is interpreting this as a file name. And there's no such a file called --patch. So to make this work, we have to use the patch option over here. Now for each commit, we can see the actual changes in our table of content file. So here's the default output of the log command. Now, if this is not what you want and you don't like the one-line option either, you can easily customize the output of the log command. Let me show you how. So we type git log --pretty equals format : double quotes. I know this is a little bit long, but the good thing is you don't have to memorize any of these things. You can always go back to the documentation or look at the cheat sheet that I've provided for you. So here in double quotes, we can specify a format string. This format string can be a combination of plain text and some placeholders that will get replaced by Git to display pieces of information about each commit. For example, if I type hello here, for each commit, we see the word hello. Of course, this is useless. So here we want to display information dynamically. Let's bring up this command one more time. And after the word hello, type %an, which is short for author name. Now take a look. For each commit, we can see the author name right after the word hello. Let's make this more interesting. So I'm going to remove hello and say %an committed. Now here we want to display the commit ID or hash. So we use %H. Now we can see the author name. Right after that, we see committed. And here's the full hash for each commit. This is 2 verbose, so we can use the lowercase h to see the abbreviation. Like this. That is better. Now, if you look at the documentation for the log command, somewhere in the middle of the page, you can see the complete list of these placeholders. So we have capital H for displaying the commit hash, or lowercase h for displaying the abbreviated commit hash. We have quite a few other placeholders. So back to the terminal, let's take this to the next level. So right after the hash, we can say on, and here we can display the date, %cd, that is commit date. There you go. So you can customize the output of the log command any way that suits your needs. Now we can also colorize this output. For example, we can display the author name in green. Let me show you how to do this. So we bring up the last command. Just before the author name, we type %C and then lowercase green. Look, here we have two placeholders. The first placeholder is for changing the color, and the second placeholder is for displaying the author name. Now, everything comes out in green because we didn't change the color after displaying the author name. So let's bring up the last command. Right after the author name, we can type %C and then lowercase reset. That's much better. Similarly, we can use a different color for the commit ID and the date or other pieces of information we have here. Once again, back to the documentation for the log command. Here you can see various placeholders for changing the color. So we have C red, C green, C blue, C reset, and C in parentheses, we can supply a custom color. Now, in reality, you're not going to remember all these details every time you want to look at the history. So in the next lesson, I'm going to show you how to create an alias for this long command. In Git, we can easily set up aliases for the commands that we use frequently, so we don't have to type them in their long form. Let me show you. So we type git config -- global. So this configuration gets applied to all of our repositories. Here in the alias section, we're going to define a new property. So we type a period, and then we type a custom command name. For example, lg, as in short for log. Now, whenever we type git lg, we want Git to execute a particular Git command. So we type that command here, log -- pretty. Now, because we have a space here, we should wrap this value with double quotes. Okay, so pretty equals format : Now here we have to use double quotes again to specify a format string, but because we have already surrounded the value with double quotes, I'm going to replace the inner quotes with single quotes. Okay, so here we can say %an as an author name, committed %h. So here's the end result. Now let's open up our global configuration file in our default editor. So we type git config -- global -e. So here's our git config file. Now down here in the alias section, we have the lg command that is bound to log with this pretty format. So now if we close this and type git lg, we see the output of our custom log command. So aliases are very useful, but in this course, I'm not going to use them because if someone watches the course from the middle, I don't want them to wonder, what is this custom git command that is not documented anywhere, okay? Now, before we finish this lesson, let me give you another useful example of an alias. So let's define another alias called onstage. With this, we can easily unstage the changes. So we're going to bind this to the restore command in Git. Once again, use double quotes. Here we type restore -- staged period. With this, we're going to restore all the files in the staging area. Now we can easily type git onstage. As simple as that. Now let's see how we can view a commit. We talked about this briefly in the previous section, but let's explore it in a bit more detail now. So let's say we want to view this commit over here. There are two ways to reference this commit. We can use the commit ID, or we can use a relative reference using the head pointer. So as you can see, head is in front of the last commit, and this commit we're interested in is 2 commits before the last commit. So we can type git show head ~2. That means go to the head, which is the last commit, and then go 2 steps back. So here we can see all the details about this commit. We can see the commit ID or commit hash, the author of the commit, the date and time, the subject, and a diff of every file that is changed in this commit. In this case, only a single file has been changed, and that is this file over here, stagingchanges.txt. In this file, we have 2 new lines, as you can see over here. Now, what if we don't want to see the changes? We want to see the final version of a file in this commit. Well, we bring up the last command, then we add a colon, and here we type the path to our file. So this file we're interested in is in a directory called sections. Here we have another directory called creating-snapshots, and our file is called staging-changes.txt. So here's the final version of this file stored in this commit. Now, what if we don't want to see the actual changes or the actual lines of code in this commit? We just want to see the files that have been modified in this commit. Well, we type git show head -2, and then we use an option called name-only. So over here, we can see all the files that have been added, modified, or deleted in this commit. With this option, we can only see the name of the files, so we cannot tell which files have been added, modified, or deleted. To get that information, we have to use a different option called name-status. So now we have the letter M here, which means this file has been modified. Now, what if we want to see the changes across two commits? For example, let's say we want to know what has been changed over the last 3 commits. To do that, we're going to use the diff command. In the previous section, you learned how to use the diff command to view the staged and unstaged changes. Now we're going to use the same command to see the differences between 2 commits. So we can start from head -2 and go to head. Now we can see a diff of every file that has been changed across these 2 commits. So here we have a diff of audience.txt. Below that, we can see the changes in objectives.txt and so on. Now, if you want to see the changes to a particular file, you can add the file name at the end. So here we can type audience.txt. Now we only see the changes in this file. Also, similar to the log command, here we have options like name status and name only to view the list of files that have been changed. So we can say name only to see the list of files that have been changed, or we can say name status to see the list of files and the type of change. In this case, we only have modifications, but if you had new or deleted files, they would be listed here as well. So we talked about viewing individual files in a commit. Now, sometimes we will want to see the complete snapshot of our project at a point in time. In these situations, we can check out a given commit, and this will restore our working directory to the snapshot stored in that commit. So our working directory will look exactly like an earlier point in time. Let me show you how to do this. So here in our log, let's say we want to restore our working directory to this commit over here. So I'm going to copy this. Now we run git checkout and paste the commit ID. We get this warning saying you are in detached head state. What is this? Well, this is one of those Git concepts that frightens a lot of people, but it's actually very simple. Let me explain it to you. So let's say here are the commits we have created so far. The first commit is on the left and the last commit is on the right. So as you can see, each commit is pointing to the previous commit. This is how Git can maintain history. Now, all these commits we have created so far are part of what we call the master branch or the main line of work. We'll talk about branches in detail in the next section, but for now, what you need to know is that in Git and many other version control systems, we can have multiple branches to work on different stories in isolation. Every Git repository has a default branch called master, which is the main line of work. In some other version control systems, it's called trunk. Now, the way Git represents branches is using a pointer. So master is pointing to the last commit we have created so far. So as we create new commits, master moves forward to point to the last commit. Now, because we can have multiple branches, Git needs to know what is the branch we're currently working on. To do that, it uses another special pointer called head. So head points to the current branch we're working on, in this case, master. You've seen this before. In our log, you can see head is pointing to master, and this item is in front of the last commit. So as we create new commits, these 2 pointers, head and master, will move forward. Now here's the thing. When we check out a particular commit, the head pointer will move to that commit. This is what we call the detached head. So head is not attached to a branch anymore. It's pointing to a specific commit. In this situation, we should not create new commits. We should only view our code. Here's the reason. If we create a new commit, that commit will be added over here. Now, at some point, we have to attach the head pointer to a branch. Now, there is a problem here. This commit that we just created is not reachable by any other commits or pointers. So it's like a dead commit. Git checks for commits like this periodically and removes them to save space. So we're going to lose that commit and all the changes included in it. So when we are in the detached head state, we should not create new commits. We should only look around and make experimental changes. That is why most of the time, the terminal window changes here Now, in my terminal window, you can see we no longer have master here. We have master tilde 9, which means we're 9 steps before the last commit. Now, if we run git log one line, we don't see all the commits we had earlier. Those commits are kind of invisible. And over here on the top, we only have the head pointer. We don't see the master branch. To see all those extra commits, we have to use an additional option called all. Now look, master pointer is in front of the last commit, but the head pointer is here. It's not pointing to master anymore. Now, to attach the head pointer to the master branch, we type git checkout master. Now, as you can see, we're on the master branch and we can create new commits. In this lesson, we're going to talk about an incredibly powerful tool for finding bugs quickly. It's called Bisect. So let's say we have created all these commits, and at this point in time, which is the last commit over here, we have a bug in our application. We don't know where this bug was introduced. Now, we don't want to check out each of these individual commits. That's going to take a long time. So using the bisect command, we can quickly find the commit that introduced the issue. We just have to tell Git that the current state, the current commit is a bad commit, and we should also give it a good state, a good commit. For this demo, let's say this first commit that I created was a good commit. At this point, we did not have the issue. So to find a bad commit, we run git bisect start. Now, we're in the middle of the bisect operation. What you see in your terminal window might look slightly different from what we have here, because I'm on Mac and I have ZSH with git plugin installed. Now, that aside, we should tell Git that the current commit, which is the last commit, is a bad commit. So we type git bisect bad. We should also give it a good commit. So let's bring up the log one more time. I'm going to copy the ID of the first commit and then run git bisect good. And here's the commit ID. Now Git says we have 5 revisions or 5 commits to test, and this roughly requires 3 steps. Look where we are now. We are not on master anymore. We are on bisect / bad tilde 6. So let's run the log command one more time. What's going on here? The head is detached because it's not pointing to master anymore. So let's bring up all the commits using the all option. So master is on the top, and here we have refs or references / bisect / bad. That means this is a bad commit. Now here we have another reference, refs / bisect / good. So here's a good commit. Now head is in the middle point. So Git checked out this commit. Now our working directory is restored to this point in time. So we can run our application or use our automated tests to see if the issue is still there or not. If the issue is there, that means the bug was introduced somewhere around here in the first half of the history. In that case, there is no need to examine the second half. On the other hand, if this is a good commit, the issue was introduced in this half. So once again, we don't need to examine the first half. So we tell Git that this is a good commit, git bisect good. Now we have 2 revisions or 2 commits to test, and this roughly requires 2 steps. So let's look at the log one more time. So we have a bad commit on the top and a good commit over here. The head is in the middle point. So once again, we run our application or use our automated test to see if the issue is still there or not. For this demo, let's say this is a good commit, so we don't have the issue at this point. That means the bug was introduced somewhere here in one of these 2 commits. So we say git bisect good. We have 0 revisions to test and 1 more step is needed. So let's look at the log one more time. So the head is over here. Now let's say this is a bad commit. So we run git bisect bad. Now let's look at the history one more time. So we have a bad commit, a good commit, and the head is right here. So we run our application and the issue is there. So we tell Git that this is a bad commit. And now Git knows the first bad commit. We have full information about this commit, so we can see the commit ID, the author, the date and time it was created, the message, as well as a summary of the changes. So we can see the list of files that were changed. In this case, we had 2 changes, which involved 2 insertions. So using the bisect tool, we can divide our history in half and check out various commits to find the first bad commit. When we are done, we have to attach the head pointer to the master branch. So we say git bisect reset. Now we're on master. Sometimes we need to find all the people who have contributed to our project. We have a special command for that, git short log. So here you can see my name, the number of commits I have created, and a summary of commit messages. Then here we have various interesting options. So let's run git short log -h. For example, we can use -n or --numbered, whatever you prefer, to sort the output based on the number of commits per author. We can use -s to suppress commit descriptions and -e to show email addresses. For example, we can say git short log -n. Now the list is sorted based on the number of commits per author. In this repository, we have a single author, so the output doesn't really change, but we can add -s to suppress the commit messages. Now we can only see the number of commits per author. Now in addition to this, we can pass -e to see email addresses of each author. So with this, we can easily find the most active contributors. Here we can also filter the list. For example, we can use before and or after options that we talked about earlier to view the contributors for a given date range. Let's see how we can view the history of a file. For example, we have this file here, table of content.txt. Let's find all the commits that have touched this file. So we run git log table of content.txt. If this is too verbose, we can use the one-line option. That's better. Now we can find statistics about each commit in terms of the number of changes using the stat option. We have seen this before. Now we know in this commit, we have one insertion and one deletion. In this other commit, we have more changes. So then we can view that particular commit in detail. Now, if we want to see the actual changes in each commit, we can use the patch option. So instead of stat, we use patch. Now we know in this commit, which is our last commit, this line was removed and replaced by a blank line. In the other commit, before that, we added these few lines and so on. So to view the history of a file, we still use the log command, but we append the file name at the end. We all make mistakes. Sometimes we may accidentally delete a file. So let me show you how to recover a deleted file from the history. For this demo, I'm going to remove the table of content file. So we're going to use the rm command to remove toc.txt. Now we have a change. Let's commit it and say remove table of content.txt. Now this message is purely for this demo. In a real situation, the message is not going to indicate that we're deleting a file because that would happen accidentally. So we may remove this file as part of fixing a bug or implementing a new feature, okay? So our table of content file is gone. Now we need to find all the commits that have touched this file. So we run git log, one line, toc.txt. Now here we get this fatal error saying ambiguous argument table of content.txt. This is one of those situations where I told you Git is not able to properly interpret your file name. So you have to separate it from the options using double hyphens. So we bring up the last command and add double hyphens here. So here are all the commits that have touched this file. Obviously, the last commit is the one that has deleted this file because we don't have any further changes to that file after that commit. So now to restore this file, we have to look at the parent of this commit, which is this commit over here. This is where we had the latest version of this file. Because in this commit over here, our table of content file was deleted. So it doesn't exist in this snapshot. So we look at this parent, we take its ID. Now we're going to check out only the table of content file from this commit. So git checkout, commit, and then we add the path to our file. So our working directory is dirty. Let's run a short status. We have one new file that is also in the staging area. So let's commit it and say restore table of content.txt. This is how we can restore a deleted file. Another useful tool in Git is the blame tool. With this, we can find the author of a particular line. So as part of troubleshooting issues, we may wonder who has written that terrible, smelly, disgusting line of code. That's where we use the blame tool to basically blame them for writing that piece of code. Here's an example. Git blame audience.txt. Now, in front of each line of code in this file, we have some extra pieces of information. We can see the commit where this line was inserted. We can see the author's name and the date and time this line was inserted. Now, if you want to find the author's email, we use the -e option, -e. Now, instead of the name, we have the email. We can also filter by lines. So if you have a large file, we don't want to see all these details. Let's say we're only interested in the first 3 lines. So we type git blame -L, and here we say 1, 3. Now we only see the first 3 lines. Quite often, we need to bookmark certain points in the history of our project, like the commit that represents a given version. We use tags for this purpose. Let me show you how this works. So let's say this commit over here, the last commit, represents the first version of our software. So we can give it a tag or a custom label. So we type git tag version 1.0. Now, if you want to tag an earlier commit, we have to type the commit ID or the commit hash here, like 5E, 7A, 828. Now, let's look at our log again. So look, in front of this commit, we have a tag, a label. We can reference this commit using the tag. So if you want to check out this commit, we can say git checkout version 1.0. Exactly the same way we check out a commit using its ID. But instead of the ID, we use this tag or this custom label. Now, to see all the tags we have created, we type git tag. Currently, we have a single tag. This tag that we have created is what we call a lightweight tag. It's just a reference or a pointer to a particular commit. But in Git, we have another type of tag called annotated tag, which is a complete object with a bunch of properties like tagger name, email, and message. So if you want to create an annotated tag, we type git tag -a for annotated. Then we type the tag name, like version 1.1. Now here we need to supply a message, just like creating a commit. So we can say my version 1.1. Of course, this message is redundant. There's no point having this message. But the idea is that with annotated tags, we can associate a message with a tag. Now, let's look at the list of tags. So git tag. Currently, we have 2 tags. We don't see their messages. To see the message, we type git tag -n. So here's our first tag, which is a lightweight tag. The message associated with this tag is actually the message of the commit that it points to. In contrast, here's our annotated tag, which has a custom message. Now let's look at the second tag we just created, git show version 1.1. So on the top, we have some information about this tag. We can see the tagger's name and email, the date and time the tag was created, as well as the custom message we provided. Below that, we have the full details of the commit. So quite often, we prefer annotated tags to lightweight tags. Now, to delete a tag, we type git tag -d and then type the tag name. The tag is gone, so we have only a single tag in our repository. Let's see how we can use VS Code to view the history of our project. To do that, you have to install an extension called GitLens. So go to the extensions panel and search for GitLens. It's right here. This is a very popular extension. Look at the number of downloads. It's over 6 million times. So once you install this, you're going to see a new icon over here. That is GitLens. Now on the top, let's go to repositories. Here's our Venice repository, and we're currently on the master branch. Let's open the master branch. Here are the commits in this branch. For each commit, we can see the message, we can see the author, we can see the number of files that were added, modified, and deleted. Now, if we expand any of these commits, we can see all the files that were changed in that commit. If we click on any of these files, we can see a diff of the changes. So this line was removed and these 2 lines were added. Pretty helpful. Now, let me close the master branch. So over here, we can see all the branches we have. We'll look at branches in the next section. We can see the contributors. So here are all the people who have contributed to this repository. In this case, I'm listed twice because I've created some of these commits on another machine with a different email. So that is why I'm listed twice here. Now, we also have our tags. Currently, we have a single tag, version 1.0, that is referencing this commit. Now, let's look at some file history. So, this file history panel works when we have a file open in the editor. So, I'm going to open our table of content file. Now, back to GitLens. In the file history panel, we can see all the commits that have touched this file. Once again, if we click on any of these commits, we can see the lines that were added or deleted. Now let's see how we can compare commits. So we click on this. We have to select two commits here. We can type a commit ID or a relative reference using head. I'm going to compare head with head_6. So these are all the files that have been changed across these two commits. If we click on any of these files, we can see the exact lines that were added or deleted. Now, let's look at search commits. So we can search by message, author, commit ID, files, or changes. So let's search by message. So after message, we type our keyword, let's say GUI. This is the only commit that has the word GUI in its message. Now, earlier in the course, I told you that all these GUI tools have some limitations. For example, here we cannot apply a second filter. We can only search by a single filter like message, author, and so on. If I have so many commits with a particular keyword in their message, and then I want to filter the range to a particular date range, I cannot do that here. I have to go back to the terminal. Another limitation we have here is the lack of bisect command. So we cannot use bisect to quickly find a bad commit. For that, again, we have to go back to the terminal. That is the reason why I'm personally not a fan of GUI tools. I prefer to do things mostly on the terminal. GUI tools are great for diffing, seeing exactly how the code is modified from one commit to another. Now, one last thing before we finish this lesson. Let me show you how to create and delete tags. So we have to bring up the command palette. On Mac, the shortcut is Shift, Command, and P. And on Windows, it's probably Shift, Control, and P. If this doesn't work on your machine, go to the View menu on the top and find the command palette. It's the first item. Unfortunately, it's not visible in my recording window right now. So let's bring up the command palette and type git tag. Now we can see all the commands related to tags. So we can create, delete, or push tags. We'll talk about pushing tags in the future. So let's create a tag. We give it a name, let's say version 1.2. We type a message. And now we have a new tag associated with the latest commit. So if you go to repositories and tags, here's our tag. Now, if you want to create a tag for an earlier commit, you have to find that commit first. So let's say we want to add a tag to this commit right here. We right click and select create tag. Let's see how we can browse the history using Gitkraken. So first we go to open a repository. We go to our project directory and open our repository. So here's the history of our project. We can clearly see all the commits we have created so far. On the left side, we can see our pointers. So master branch is just a pointer to the last commit over here. Now next to master, we have +1, which means we have another pointer pointing to the same commit. Take a look. That is our tag version 1.2. We have another tag pointing to this commit. Now we can search for commits right here. Here we can find commits by their ID, author, or message. So if I type GUI, this is the only commit that has the word GUI in its message. Now, as I told you before, all these GUI tools have some limitations. For example, here we cannot find commits created by a given author in a particular date range. So we cannot apply multiple filters. In those situations, we just have to go back to the terminal. Now we can select any of these commits to see its details. So here on the right side, we can see the commit ID, message, author, as well as a summary of modified files. So here we have modified 5 files. We can see all these files listed here. We can sort the list in ascending or descending order. We can see the list in the tree structure or in a flat list. Now we have a very useful option here, view all files. So if this commit has modified only 2 files, but you want to look at the other files in our project at that point in time, we can select this and open any of these files. For example, here, salespage.txt hasn't been modified. That's why we don't have an icon next to it. But we can click on it to see what it looked like at that point in time. Now let's look at our table of content file. So here's the final version of this file stored in this commit. To see the actual changes, we go to the diff view tab. So you can see this line was removed and replaced by blank line. I totally love the diff view in Gitkraken. It makes our job a lot easier. We also have two tabs here, blame and history, which kind of bring us to the same view. Let me show you. So we can go to history. Here on the left, you can see all the commits that have touched this file. Here's the first commit, and here's the last commit. So as we look at this commit, we can see how this file has evolved. So let's change the diff view to file view. In the first commit, our file was empty. In the second commit, we added these lines. And in the last commit, we removed the border under the header. Now, if you click on the blame tab here, unfortunately, it's not visible in my recording window. But if we click on it, we can toggle blame details. So this line was added in this commit over here by this person. So we can clearly see who has written what line of code. Now let's close this window and this window as well. Back to our history. Let's see how we can compare two commits. So I'm going to compare this commit with this commit over here. To select the second commit, we press Command on Mac or Control on Windows. Now on the right side, you can see we have selected two commits. And here are the files that have been changed across these two commits. So this is how we can compare commits. Now, if we right-click on any of these commits, we can check out that commit. All right, now look, the head pointer is pointing to this commit. So it's in the detached state. Now to attach it back to the master branch, we right-click the master branch and go to Checkout Master. Good. Now, one more thing here. We can right-click a commit and create a tag or an annotated tag. We have a bunch of other commands here. We'll talk about them in the future. So this is how we can browse the history in Gitkraken. Now, before we finish this lesson, let me show you another useful feature here. We can bring up the command palette by pressing Command and P on Mac or Control and P on Windows. Here we have various commands. We can select the blame command, and then here we can search for a file in our project. Let's say table of content.txt. So we have auto-completion. This is fantastic. I love it. So let's look at table of content. Now we can see the full history of this file. We can see we accidentally deleted this file in this commit and then added it back over here. And of course, if we toggle the blame details, we can see who has written what line of code. Very handy. Now let's bring up the command palette one more time. We can also search for commits. So we can search by message, like GUI, or by author, or by commit ID, and so on. Using the command palette, we can also create tags. So let's search for tag. Now we can create a tag. This will create the tag for the last commit in our repository. To create a tag for an earlier commit, as I told you, we have to right-click that commit and go to Create Tag. In this section, I'm going to talk about one of the most important and powerful features of Git called branching. You will learn how to use branches to diverge from the main line of development and work on something else in isolation, how to compare branches to see their differences, how to merge them. We'll talk about different merging techniques like three-way merging, fast forwarding, squash merging, and rebasing. We'll also talk about resolving merge conflicts, undoing a faulty merge, and using essential tools like stashing and cherry picking. The skills you're going to learn in this section can totally change the way you develop software. So let's jump in and get started. So what is branching all about? Well, branching allows us to diverge from the main line of work and work on something else in isolation. Conceptually, you can think of a branch like a separate, isolated workspace. So we have our main workspace, which is called master. We can have another workspace for working on a new feature in isolation. While we're developing this new feature, our code may get unstable. So we don't want to release the code in this workspace. We continue working here. When we're done, we test our code, and after we fix all the bugs, then we bring the changes in this workspace into the master. This is called merging. So branching allows us to work on different work items without messing up with the main line of work. We keep the main line as stable as possible so we can release it anytime. Also, anyone joining our team can start off on a stable code base. That's the idea of branching. Now, the way Git manages branches is very different from many other version control systems like Subversion. In Subversion, when we create a new branch, Subversion takes a copy of our entire working directory and stores it somewhere else. What if you have hundreds or thousands of files in our project? All these files have to be copied, and this operation can take a little while. That's why a lot of Subversion users hate branching, because it's slow and can waste a lot of disk space. Git branches are super fast and cheap because a branch in Git is just a pointer to a commit. So the master branch is just a pointer to the last commit in the main line of work. As we make new commits, Git moves this pointer forward automatically. So it knows what is the latest code in the main line of work. That is the snapshot stored in this commit. When we create a new branch, Git creates a new pointer that can be moved around. This pointer is just a tiny file that contains a 40-byte commit ID. That's why creating a branch in Git is blazingly fast. Now, when we switch to this branch and make new commits, Git moves this pointer forward. The master pointer stays where it is, so Git knows the latest code in each branch. When we switch back to master, Git takes the snapshot from the commit that master points to and resets our working directory to that snapshot. So we always have a single working directory. Now, how does Git know which branch we're currently working on? Using a special pointer called head. This pointer is also another tiny file that contains the name of a branch, like master. When we switch to a different branch, Git moves the head pointer around. So it updates the tiny file and writes the name of the target branch. This is how it can track what branch we're currently working on. Throughout this section, you're going to learn everything you need to know to work with branches. In this section, we're going to work with the same repository that I gave you in the previous section. If you missed that section, you can download this repository right below this video. So extract the zip file somewhere on your machine. When you're ready, watch the next lesson. Let's say we just got a bug report. Now to fix this bug, first we should create a new branch called bugfix. So we type git branch bugfix. Now to see the list of branches, we type git branch. So currently we have two branches, bugfix and master. There is an asterisk before master, which means we're currently on the master branch. You can also see that over here. As I told you earlier in the course, this is coming from ZSH or Z shell with Git plugin. So if you're on Mac, to see something like this, you should install ZSH with Git plugin. If you're on Windows, you should install PoshGit. This is really helpful because here we can clearly see what is the current branch. One of the issues that a lot of people face is they accidentally commit their code to the wrong branch. So we're currently on the master branch. There's another way to know the current branch. We can type git status on branch master. Now, to fix this imaginary bug, first we have to change the current branch to bugfix. There are two ways to do this. In the past, we used the checkout command, but this command had multiple applications. A lot of people found it confusing. So these days we have a new command for switching branches. So git switch bugfix. Now we are on the bugfix branch, beautiful. But before going forward, I want to rename this branch. It's not clear what bug we're trying to fix here. And also in the future, it's very likely that we're going to have tens or hundreds of other bugs to fix. So it's better to use a more specific name. To rename this branch, we can type git branch -m. We type the old name and then the new name. We can use a convention like bugfix /signup-form, assuming that this bug is in our signup form. Now, if you don't like a /, you can use a hyphen here. That's a matter of personal preference. Okay, now you can see our branch is renamed, beautiful. So to make some changes, let's open audience.txt in VS Code or your favorite code editor. All right, here I'm going to make a few changes. First, I'm going to rename audience to who this course is for. Then I'm going to add a border. And finally, I'm going to remove this line. So we have three kinds of changes here: addition, modification, and deletion, okay? Obviously, these changes have nothing to do with fixing a bug on a sign-up form. But here we're not working on an application, so don't worry about the differences. I'm just teaching you how to use various tools in Git. The name of our branches, the changes we make, and the commit messages don't matter. Now save the changes. Back in the terminal. Our working directory is dirty, as we can see from the yellow marker. So let's run status. We can clearly see that we have modified this file and this file is not staged. So let's add it to the staging area and then commit it. We can say fix the bug that prevented the users from signing up. Good. Now let's look at our log. So git log, one line. See what's going on here. On the top, we have head pointing to the bug fix branch. That means we're currently on the bug fix branch. And here's the latest commit in the bug fix branch. Now below that, we can see our master branch, which is just a pointer to a commit. So as you can see, our master branch is one commit behind the bug fix branch. At some point in the future, we're going to merge the bug fix branch with the master branch to bring the master branch up. But don't worry about it now. Let's just focus on managing branches. So in audience.txt, we made a few changes, and these changes are only visible in the bug fix branch. So if we switch back to the master branch and open audience.txt, we see the old version of this file. So branches allow us to work on different tasks in isolation. The code we have in these branches are isolated. At some point, we'll merge them to bring them together. Now, while we're on the master branch, if we look at our log, on the top, we can see head is pointing to the master branch, but we don't see the bug fix branch because bug fix is ahead of the master branch. So its commits are not listed here by default. To view the commits across all branches, we use the all option. Now, even though we are on the master branch, we can see the commits in other branches. In this case, the bug fix branch. Now, at some point in the future, when we are done with the bug fix branch, when we merge it into the master branch, we need to delete it. So we type git branch -d bugfix /signup-for. Now here we get an error saying the branch bugfix is not fully merged. We are saying this error because we have some changes in the bugfix branch that are not merged with the master branch. So by default, Git prevents us from accidentally deleting this branch unless we merge it first. But if you're pretty sure that we don't want the changes in this branch, we can force the deletion by using a capital D. So we say git branch -D. Now in this video, I'm not going to delete this branch because later in this section, we're going to merge the changes in this branch with master. As we commit to our branches, we need to know how they're diverging from master. So in this video, I'm going to show you a couple of different ways to compare branches. So currently we are on master. At some point in the future, we're going to merge the bugfix branch into master. But before doing so, we want to know what commits are coming in master. So we type git log master : bugfix /signup-for. So this means show me all the commits that are in bugfix branch and are not in master. Currently, we have only a single commit. If we had more commits, all of them would be listed here. And just like before, we can use the one-line option to make the output more concise. Now, what if you want to see the actual changes and not the list of commits? Well, what tool do we use for seeing the changes? Diff. So git diff, we're going to compare master with the bugfix branch. So we type master : bugfix /signup-for. So now we know that once we merge the bugfix branch into master, in audience.txt, we're going to have these changes. So these two lines are going to get removed and replaced with these two lines. Now there's a shorter way to write this command. Because we're currently on master, we don't have to type master ... here. So we can type git diff bugfix /signup-for. So this shows the differences between this branch and the current branch, which is master. Now, sometimes we don't want to see the changes in terms of the code. We just want to know what files are going to be affected. In those cases, we can use one of the options we talked about in the previous section: name only or name status. So once we merge the bugfix branch into master, audience.txt is going to be modified. So as I told you before, when we switch branches, Git resets our working directory to the snapshot stored in the last commit of the target branch. Now, if you have local changes in our working directory that we haven't committed yet, these changes could get lost. In these situations, Git doesn't allow us to switch branches. Let me show you how this happens and what you should do about it. So in the previous lesson, we made some changes in audience.txt in our bugfix branch. Like currently we're on the master branch. So let's open audience.txt and make some other kind of changes. So here I'm going to add an asterisk just to indicate a change. Save. Back in the terminal. Our working directory is dirty because we have some local changes we haven't committed yet. So let's say we're in the middle of something, and then we have to quickly switch to the bugfix branch. If we type git switch bugfix /signup-for, we get an error saying your local changes to the following files would be overwritten by checkout. Please commit your changes or stash them before you switch branches. Now, in this case, I don't want to commit the changes because I'm not done yet. So in situations like this, we should stash our changes. Stashing something means storing it in a safe place. So we're going to store this somewhere in our Git repository, but this is not going to be part of our history. Let me show you how this works. So we type git stash push -m and give it a message. With this message, we can tell what these changes are all about. Let's say new tax rules. So I was working on the new tax rules, and then I had to quickly switch to the bug fix branch, right? So saved working directory and index state on master, and here's the message. Now, as you can see over here, we have one stash. Just remember, by default, new untracked files are not included in your stash. So as an example, if I create a new file here, let's echo hello to new file.txt. Now let's run a short status. So we have a new file. If I stash the changes, this new untracked file is not going to be included in the stash by default. To include it, we have to use the all option. So we say git stash push -all, or just -a, then -m, or we can combine these two options into a single option. Now we give it a message, my new stash. Of course, the message should be something more meaningful. So now we have two stashes. You can see that over here. To view our stashes, we type git stash list. So we have two stashes. Each stash has a unique identifier, stash at, in curly braces, we have an index. Now, as you can see, our working directory is clean. So we can switch to the bug fix branch, no problem. We can do our work here. When we're done, we get back to the master. At this point, we want to apply the changes from one of our stashes to our working directory. But before doing so, we want to look at those changes to see what lines of code have been modified. So we type git stash show, and here we type the name of the stash, like stash at curly braces 1. Now we can make this shorter by using just the sequence number. Now we know that in stash number 1, one file has been changed, that is audience.txt. Here we have two changes, one insertion and one deletion. So we can go ahead and apply this stash on our working directory. So git stash apply 1. The changes are applied to our working directory, beautiful. Now when we're done with this stash, we want to remove it to clean things up. So we can type git stash drop 1. That stash is removed. Let's look at our stash list one more time. We have one more stash. Let's say we don't need this anymore. So we can type git stash drop 0. Or to remove all stashes, we can type git stash clear. All our stashes are gone. Merging is all about bringing changes from one branch to another. In Git, we have two types of merges, fast-forward merges and three-way merges. Let's study each of these merges using a real example. So here's the master branch with 3 commits. We create a new branch called bugfix. As I told you before, in Git, a branch is just a pointer to a commit. So in this case, both master and bugfix pointers are pointing to the same commit. Now we switch to the bugfix branch and make a couple of commits. We're done here. Now we need to bring the changes back to master. Now, because these branches have not diverged and there is a direct linear path from bugfix to master, all Git has to do to merge the changes is to bring the master pointer forward. This is what we call a fast-forward merge. Now, if you're confused about this, let me give you a simple example. So forget about Git for a second. Imagine we have a directory called master, and the code in this directory is at version 1.0. We take a copy of this directory and call it bugfix. At this point in time, the code in these directories are identical, right? Now we start making some changes to the bugfix directory. So we get to version 1.2. We're done here. We want to bring the changes back to master. How do we do this? Well, one way is to copy all the files from bugfix into master. But this is not the best way to solve this problem. What if you have thousands of files? This copy operation might take a few seconds. There is a better way. Since we don't have any additional changes in master, and essentially what we have in master is the first version of bugfix, we can simply rename bugfix to master. So from this point forward, we can say this is our new master directory. The idea of a fast-forward merge in Git is very similar. So if two branches have not diverged and there is a direct linear path from the target branch to the source branch, Git runs a fast-forward merge. It simply brings the pointer of the source branch forward. Now that we're done with the bug fix branch, we can simply remove it, which removes the pointer. Now let's look at an example of a three-way merge. In this example, our bug fix branch is 2 commits ahead of master. But before we merge it with master, let's go back to master and add an additional commit. Now our branches are diverged. So we have some changes in master that don't exist in the bug fix branch. So if you run a merge, Git cannot move the master pointer forward and have it point to the same commit as bug fix, because otherwise we'll lose the latest commit in the master branch. So when we run a merge, Git creates a new commit that combines the changes from these 2 branches. Now, the reason this is called a three-way merge is because this new commit is based on 3 different commits. The common ancestor of our branches, which includes the before code, and the tips of our branches, which contains the after code. So Git looks at 3 different snapshots, the before snapshot and after snapshots. Based on these, it will figure out how it should combine the changes. So it creates this new commit, which is called a merge commit. So to recap, in Git, we have 2 types of merges. Fast-forward merges, which happen if branches have not diverged, and three-way merges, which happen if branches have diverged. Over the next few videos, we're going to see examples of these merges in action. Let's see a real example of a fast-forward merge. So first, let's look at our log. And by the way, when you're using branches, it's a good idea to always include the graph option. At this point in time, you're not going to see any differences, but as we go forward, you will see that the graph option will give us a better representation of our branches and how they diverge. Of course, I know this command is very long and you're not supposed to write this every single time. That's why we use aliases. But as I told you before, in this course, I'm not going to use aliases because I want anyone to be able to follow this course. So let's look at our log. As you can see, our bug fix branch is 1 commit ahead of master. Also, as you can see here, we have a linear path. So if you start from bug fix, we can get to master. So master has not diverged from bug fix. That means when we run a merge, Git will fast forward master. Let me show you. So to bring the changes from the bug fix branch into master, first we should be on master. Then we run git merge bugfix / signup form. I don't know why my autocomplete is not working on this machine. So let's run. Look, we have a fast forward merge, and this file is the only file that was changed with 5 changes. Now, let's look at our history one more time. So now both these branches are pointing to the same commit, which is the latest commit over here. And we have a linear history. Now, it is possible to disable a fast forward merge, and this has a number of benefits. So let's create a new bug fix branch, make a new commit to it, and then merge it with master using a no fast forward option. So earlier I told you that to create a branch, we type git branch and then type the branch name. But after this, we have to switch to that branch. So there are 2 steps we have to follow. Now, let me show you a shortcut. We can type git switch -c for create. And with this, we can create and switch to a branch in 1 step. So I'm going to call this branch bugfix / login form. Now we are on this new branch. So let's open our table of content file and add an asterisk here. Save. Back to the terminal. Let's commit the changes. For the commit message, I'm going to say update table of content.txt. Okay, now let's look at our history. So git log 19 all graph. Take a look. So our new branch is 1 commit ahead of master. And by the way, we probably don't need this branch anymore, so we can drop it. But that aside, let's merge our new branch into master using a no fast forward option. So first we have to switch to master, git switch master. Now we run git merge. Now here we have to use the no fast forward option. So no fast forward. Then we type the branch name. So bugfix / login form. So with this, we're telling Git, hey, even if fast forward is possible, don't do it. Create a merge commit that combines all the changes in this target branch and bring them into master. Take a look. So our default editor is opened. Here we have to type a commit message because we're going to have a merge commit, a new commit in the master branch. By default, Git suggests this message, merge branch bugfix / login form into master. Most of the time, the default message is totally fine. So we can close this. Now back to the terminal. we no longer have a fast forward merge. So let's look at our history one more time using the graph option. Let's see what's going on here. So here's our new bug fix branch, which originated from this commit over here. So before we merged this into master, master was pointing to this commit, and this is when we created our new bug fix branch. In this branch, we added a new commit, which was for updating our table of content file. Then we merged this branch into master. So see the graph? This is coming from the graph option. If we don't use the graph option, we'll see everything in a linear way. So our master is pointing to this commit, which is our merge commit, and here's the commit message that you just saw. Now, what is the benefit of this approach? Why should we disable fast-forward merges? Well, this is one of those areas that gets a bit controversial. In the Git community, we have two groups of people. Some people hate merge commits, and they argue that these merge commits pollute the history. They make it harder to read and understand what's going on, especially as we have more and more branches. These people prefer a linear history. On the other hand, we have another group of people who argue that these merge commits are a true reflection of history, a true reflection of what actually happened when we merged our branches and how they were merged. In my opinion, both these arguments are valid. It's definitely easier to read a linear history, but you should also remember that a linear history is not your true history. It's a lie. Now, that aside, these merge commits have another benefit. They make it easier for us to undo a feature. Let's talk about it using a real example. So here we have two branches, master and feature, and our branches have not diverged. So there is a direct linear path from feature to master, right? So here we can use a fast forward merge. But let's see what happens if we don't use a fast forward merge. We're going to have a merge commit that combines all the changes in the feature branch. So if you have F1 and F2 in the feature branch, this new merge commit combines all the changes in F1 and F2. Now, let's say we work on this feature, and then next day we are told to remove this feature from the code base. We can easily revert the last commit in the master branch. We'll talk about reverting commits in the future when we talk about rewriting history. But basically, by reverting a commit, we create a new commit that is the opposite of that commit. So essentially, it undoes everything that has happened in another commit. So if we use a merge commit, there is a single commit that we have to revert. In contrast, if we use the fast forward option, our master pointer is going to move over here. And now if you want to take out this feature from the code base, we have more commits that we have to revert, and this can get a bit more complex. So once again, both these arguments are valid. It really depends on your team culture and the kind of project you're working on. So I leave it up to you to decide what approach works best for you. Now, where you work, you might have a policy in your company saying no fast forward merges. In that case, you don't want to type git merge no fast forward every time. What if you forget? So let me show you a better way. We can disable fast forward merges for a particular repository or for all of our repositories. So we type git config fast forward no. This will disable fast forward only in the current repository. But if you want this to apply to all of your repositories, of course, you should use the global option here. Now let's look at an example of a three-way merge. First, let's look at our history. So this is where we are. Our master branch is at this commit, which is a merge commit. Now I'm going to create a new branch for implementing a new feature. So git switch -c for create. We're going to call that branch feature/change password. So now we have this new branch. Let's look at our history one more time. So at this point, both these pointers, our change password pointer and master pointer, are pointing to the same commit. Now, what we want to explore in this lesson is how two branches can diverge. So we are currently on the change password branch. Let's make a commit here. I'm going to echo hello to, let's say, change-password.txt. Now we're going to stage the changes and commit them and say, build the change password form. Now, let's look at our history again. So as you can see, our change password branch is one commit ahead of the master branch, right? But our branches have not diverged yet because there is a direct linear path from the change password branch to master. So to make these branches diverge, I'm going to go back to master and make a new commit. So git switch master. Let's open objectives.txt and make a small change here. It doesn't really matter. Now, back in the terminal, Let's run git add and then commit and say update objectives.txt. So now both the master and change password branches have a new commit. Take a look. So git log. Okay, here's master and here's the change password branch. As you can see, our branches have diverged. This is the commit where we started the change password branch. We added a new commit in this branch and got back to master and added a new commit to master. Now we do not have a direct linear path from change password to master. So if we start from here, we cannot go to master. So when we try to merge the changes, Git is going to run a three-way merge. It's going to look at the tips of these branches, which is this commit and this commit over here. It's going to compare these with their common ancestor, which is in this case, this commit over here. Based on their differences, it's going to figure out how to merge or combine the changes into a new merge commit. So here on the master branch, we type git merge feature/change password. Once again, we have a default message for the merge commit. We can accept it as is or change it if we need to. So let's close this window. Now back in the terminal. As you can see, we don't have a fast forward merge. Now let's look at our history one more time. So here's the result of the merge. Our change password branch is pointing at this commit. Our master was here. Now we combine these two into a new merge commit over here. So typically when we're done working on a branch, we should merge it into master and then delete it. Now, sometimes we may forget to delete a merged branch, so that branch will be sitting there, and after a while, we may forget that we already merged that branch into master. So let me show you how to view the list of merged and unmerged branches. So currently we're on the master branch. To view the list of branches that we have merged into the current branch, which is master, we type git branch -- merged. So all these branches have been merged into master, and we can say that it's safe to delete them if you're done working on these branches. So as a best practice, whenever you're done working on a branch, you should delete it. Otherwise, that branch or that pointer will be sitting there and creating confusion in the future. So here we can say git branch -d bugfix/login for. Here in the branch command, we also have another option called no merged. This returns the list of branches that have not been merged into the current branch. So currently all our branches have been merged, and that's why we don't see anything in the output. So you have seen examples of merging branches. Now, in the real world, quite often when we merge branches, we run into conflicts. Conflicts happen when the same line of code has been changed in different ways in two branches, or if a given file is changed in one branch, but is deleted in another branch. Another scenario is when the same file is added twice in two different branches, but the content of this file is different. In these cases, Git cannot figure out how to merge the changes. So it will stop the merge process, and that's when we need to jump in and tell Git how we want to proceed. Let me show you a real example. So here on the master, let's create a new branch called bugfix/change password. Now let's open change password.txt. Here on the second line, let's say change in the bugfix branch. Save the changes. Back in the terminal, let's add this to the staging area and commit it. We can say update change password.txt. Of course, this is not a good commit message because it's tied to a particular file, but it's fine for this demo, so let's move on. All right, so we changed this file in this branch. Now let's switch to the master branch and update the same file in a different way. So let's open it. Here on the second line, I'm going to say change in the master branch. All right, now back in the terminal, let's add this to the staging area and commit it with the same commit message. So now this file is changed in different ways across these two branches. So when we run git merge bugfix/change password, we get a conflict. We get a merge conflict in change password.txt. So Git stopped the merge process, and now we have to jump in and manually combine the changes. Also, as you can see over here, we are in the middle of a merge process. So let's run git status. Look under unmerged paths. This is where we can find the conflicted files. So both our branches have modified change password.txt. Now, this is a very simplified example. In a real-world scenario, you might have more than 10 files listed here. Basically, the more your branches diverge, the more conflicts you're going to have. We're going to talk about this later in this section. For now, let's just see what you need to do when there is a conflict. So we're going to open changepassword.txt. Look what's going on here. The first time I saw this, I was like, what the hell is going on here? But this is very simple. Here we have markers that represent the changes in the current branch and in the other branch. So over here, we have these markers. In front of that, we have head, which points to the current branch. In this branch, which is the master branch, we have introduced this line. Now, after this, we have this divider. And below the divider, we have the changes in the other branch. So that is this line over here. And after this, we have the marker for the other branch, bugfix/change password. Now, in a real situation, you might have multiple conflicts in the same file. So for different chunks of code, you're going to see these markers. Now, let's see what we can do here. Here in VS Code, we have a few options. We can accept the current change. If we click this, all those markers are gone, and we are left with the change in the master branch. Let's undo this. Alternatively, we can accept the incoming change. So once again, all the markers are gone, and now we have the change in the other branch. Let's undo this. Another option is to accept both changes. Let's undo this again. So here are the options in VS Code. We also have third-party merge tools for handling conflicts. We'll talk about them in the next lesson. But before we get there, let me show you a different way of resolving conflicts. We can manually edit this file by hand and remove these markers. So I'm going to remove the head marker. Okay. I'm also going to remove the divider and the second marker. So here we have changes in both these branches. We can reorder them, so we can put this one first. So this is how we are manually merging the changes. Now just remember that ideally, you should not introduce new code here. So here we should not add a new line of code because this line of code was not introduced in any of these branches. It's a new line that we are adding in a merge commit. If we do this, this merge commit is referred to as an evil commit because it's introducing changes that didn't exist in any of these branches. The whole point of a merge commit is to combine changes across two branches, right? So as much as possible, try not to introduce new changes here. But I know in real world situations, sometimes this is not avoidable. There are cases where you need to manually edit the changes and introduce something new. Now let's delete this line, save the changes. Back in the terminal, we have to add this file to the staging area. Why? Because this is what we're proposing for the next commit, right? So now let's run git status. We no longer have unmerged paths, which means we no longer have conflicts. So we have modified this file, changepassword.txt. Now we run git commit. We can leave out the message option and accept the default message, merge branch bugfix into master. So let's close this. Back in the terminal, we're done with the merge. Quite frankly, VS Code is not the best tool for resolving conflicts, at least not at the time of recording this lesson. So let's look at some other tools for resolving conflicts. There's so many tools out there. The most popular ones are Kdiff and P4Merge, which are cross-platform, and WinMerge, which is for Windows only. Now, if you use Gitkraken or a powerful IDE like IntelliJ, you don't need any of these external merge tools. But I still encourage you to watch this lesson to the end because the skills you're going to learn will transfer to other tools. In this lesson, we're going to use P4Merge for resolving conflicts. So open up your browser and search for P4Merge. Over here on perforce.com, you can download the latest version. Let's go with this. Here you have to select your operating system. I'm going to go with Mac and download the latest version. We don't have to register, so let's skip registration. Good. All right, so we get a DMG file on Mac. If you're on Windows, you'll get a setup wizard. So let's drag and drop P4Merge onto applications. It's saying that I already have this, so I'm going to replace it with the latest version. Good. Now here in the terminal, we have to configure P4Merge as our default merge tool. So we say git config -- global merge.tool. We give it a name, P4Merge. Next, we need to tell Git where to find P4Merge. So once again, git config -- global merge tool dot p4merge, that is the name we assigned over here, dot path. Here in double quotes, we should add the full path to p4merge. If you're on Windows, your path is going to be like /program files /p4merge / whatever, depending on where you have installed this. On Mac, the path is going to be /applications /p4merge.app /contents /macOS /p4merge. Make sure to spell it properly, exactly as what you see here. All the uppercase and lowercase letters are different because macOS is a case-sensitive operating system. Okay, so we have configured our default merge tool. Now we need a merge conflict. To save time, I'm not going to recreate another merge conflict. I'm going to simulate the previous conflict. So we're on master, and we want to merge this with our bug fix branch. So git merge bugfix /change password. All right, we got a merge conflict exactly like before. Now in the previous lesson, we opened change password in VS Code to edit the conflict here. Now this time, we're going to use our external merge tool. So we run git merge tool. All right, here we have 3 copies of our change password file. On the left side, we have change password _remote. This is the version we have in our remote or target branch, which is our bug fix branch. In the middle, we have change password _base. This is the base copy, the base version. So here's the version of this file before our branches diverged. And on the right side, we have change password _local. So this represents the changes we have in the current branch, which is the master branch. Now, the beauty of this tool is that here we can visually see the conflicting changes. So unlike VS Code where we had those ugly git markers, here we can easily see that on the second line, we have a conflicting change. Now down below, we can see how these changes are going to get combined. So by default, p4merge is bringing changes from both branches, but we can easily change this. So on the right side, we have 2 icons, purple and green. Purple represents the changes on the left side. So look at the legend over here. We have a purple icon that represents the left side, the changes in the remote branch. The green icon represents the changes in the local branch, which is master. So if we click on the purple icon, now we only have the changes in the local branch. Now, while green is selected, we can select the other branch by holding down Shift and clicking. So now we have the changes in both these branches. This is the idea of p4merge or visual merge tools. Pretty much all merge tools out there work in a similar fashion. Now, if you have multiple conflicts in the same file, we can browse through them using these buttons on the toolbar. So we resolve the conflicts. When we are done, just like before, we need to save the changes, then go back to the terminal and commit them. So we should close p4merge. Now back in the terminal, let's stage the changes and make a commit. I'm going to accept the default message. So let's close the window. And we successfully merged our branches. So you learned that when doing a merge, we may run into 1 or more conflicts. Now, what if we're not quite ready to handle these conflicts? Perhaps we have several conflicts and we are in the middle of something, so we don't have enough time to spend on resolving these conflicts. In situations like this, we can easily go back to the state before we started the merge. So here we have a merge conflict. To abort the merge, we simply type git merge -- abort. Now we're back to the state before we started the merge. So if we resolve some conflicts and stage the changes, those resolutions are gone. We're back to a clean state before we started the merge. Sometimes we do a merge and then find out that our code doesn't get compiled or our application doesn't work. That happens if we screw the merge, if we don't combine the changes properly. In situations like this, we need to undo the merge and then remerge. So let's have a quick look at our history. On the top, we have a merge commit. Let's say this is a faulty merge, so we want to undo it. Here we have 2 options. One option is to remove this commit as if it was never there. Now you have to be a bit careful with this solution because as part of removing this commit, we are rewriting history. Rewriting history is totally fine if this history is local in our repository. But if we have shared our commits with other team members, if we have pushed our commits to a remote repository, then we should not rewrite our history. We'll talk about this in more detail in the future. In situations like this, instead of removing this commit, we should revert it, which means we're going to create a new commit that will cancel all the changes in this commit. In this lesson, we're going to look at both these solutions. First, let's see how we can remove the last commit. So here's a picture of our history. Both the head and master pointers are pointing to the last commit, which is a merge commit. Now we're going to use the reset command to move both these pointers and have them point to the last commit on the master branch before we started the merge. Now look at our merge commit. We don't have any other commits or any pointers pointing to this commit. So from Git's point of view, this commit is garbage. Once in a while, Git looks for commits like this and automatically removes them from our repository. So here in the terminal, we type git reset --hard. I will explain what this means in a second. We want to reset head to head ~1. That is one commit before the last commit. Now, what is this hard option here? When resetting the head pointer, we have three options: soft, mixed, and hard. What is the difference? Well, here we have our working directory, our staging area, and the last snapshot. When we reset the head using the soft option, Git is going to have the head pointer point to a different snapshot. But our staging area and working directory are not affected. If we use the mixed option, which is the default option, so we don't have to specify it, Git is going to get that new snapshot and put it in the staging area as well. So if you have local changes in our working directory, they are not affected. They're going to stay there. If we use the hard option, Git is going to take that new snapshot and put it in our working directory as well. So all our environments are going to look identical. This is the state that we were in before we started the merge. All our working environments were identical. So back to the terminal, we're going to reset head to the last commit on the master branch before we started the merge. That is this commit over here, update change password. But before doing so, I want to take a copy of the last commit ID, that is our merge commit. Let's copy this and put it somewhere. Now we type git reset --hard head ~1 to go one step back. Good. Now head is pointing to this commit over here, update change password. Let's look at our log. Look, the merge commit is no longer in our history, but it's still in our repository, so we can recover it. Let me show you. So we type git reset --hard. Now we're going to paste the ID of our merge commit that we copied earlier. Okay, let's go with that. Now head is pointing to this commit over here. That is our merge commit. So let's look at our history. So here we have our merge commit. Before that, we have the last commit on the bug fix branch, and here's the last commit on the master branch. So you learn how to undo a merge commit. But as I told you before, you should do this only if you haven't shared your history with others. We'll talk about that in the future. At this stage, all these commits are local in our repository. We haven't shared our history with others. We haven't pushed our commits. So undoing is totally fine. But if you have shared our history, instead of undoing, we have to revert the last commit. So we type git revert head. We want to revert the last commit, which is our merge commit. Take a look. We got this error saying this commit is a merge, but no -m option was given. What's going on here? Here's our merge commit. As you can see, a merge commit has two parents. One parent on the master branch, the other on the feature branch. So to revert this merge commit, we have to tell Git how we want to revert the changes. In this case, we want to revert to this commit over here, the last commit on the master branch before we started the merge. This commit over here is the first parent of our merge commit. Because our merge commit is on the master branch, so the first parent should also be on the master branch. So we type git revert -m1, which means the first parent, and then we specify the target commit. That is the last commit. Okay, Git open our default editor. So here we have a default commit message saying revert, and here's the commit we are reverting. Down below, we have more details. It's saying this reverts this commit over here, revising changes made to this commit over here. We're going to accept the default message, so close. All right, we're done. Let's look at our history. So here's our merge commit. Right after that, we have a new commit, which is reverting our merge commit. Here we have a bug fix branch with two commits, B1 and B2. Let's say we're done here, so we do a merge. Now these commits, B1 and B2, are part of the history of master, right? But what if these commits are not good quality commits? Maybe they're too fine-grained, or they don't represent a single logical change set. Maybe we have mixed different things in each commit, so these commits are not good quality commits. Perhaps we added these commits as checkpoints along the way, so we don't really care about the history of the bug fix branch. So we don't want these commits to pollute the history of our master branch. In situations like this, we have a better solution called squash merging. So let's undo the merge. We're going to create a new commit that combines all the changes in the bug fix branch. So we have a single logical change set that represents all the changes for fixing this bug. Now we can apply this commit on top of master. This is what we call squash merging. Now what you need to pay attention to here is that this new commit is not a merge commit because it doesn't have two parents. It doesn't have a reference to B2. It's just a regular commit that we have added on top of master. Now we're done with the bug fix branch, so we can delete it, and we are left with a simple, clean, and linear history. This is the benefit of squash merging, but it doesn't mean you should use this technique all the time. You should use it with small, short-lived branches with bad history, like bug fixes or features that you can implement in a few hours or in a day. Now let's see squash merging in action. So let's start off by creating a new branch called bugfix/photo upload. In this branch, we're going to make two commits, and in each commit, I'm going to update one file. So let's echo bugfix to audience.txt. Now we're going to commit. Using -a option, we're going to stage and commit all the changes in one step. We talked about this at the beginning of the course, remember? So let's give it a message. Update audience.txt. Now let's make a second commit. So echo bugfix to table of content.txt. Once again, we're going to commit all the changes in one step and say update table of content.txt. So here we have two commits. Let's look at our history. So git log, one line, all graph. So our bug fix branch is two commits ahead of master, the first commit and the second commit. Now in this case, we can do a fast forward merge, but let's say the master branch has evolved and we're not going to do a fast forward merge. So instead of doing a regular merge, which adds a merge commit, we're going to do a squash merge. So first we switch to the master branch, git switch master. Now in the past, we typed git merge bugfix/photo upload. Now here we're going to add an option called --squash. Let's see what happens. Git created a new commit called a squash commit, which combines the changes across these two files. But we don't have a commit yet. All these changes are in our staging area. Let me show you. So git status -s. Look, both these files are modified and they're staged. So now we have to make a commit. So git commit -m. Here we type a meaningful message that represents all the changes in our bug fix branch. So we say fix the bug on the photo upload page. All right, let's go. Let's bring up the history. So here on master, we have a new commit that combines all the changes for fixing this bug. So once we remove the bug fix branch, we're going to end up with a simple, clean, linear history. But before doing this, let me show you something. I'm currently on master. Earlier, I showed you how to view the merged branches. We type git branch --merged. Look, our new branch, bugfix/photo upload, is not in this list because technically we don't have a merge commit that connects these two branches. So when doing a squash merge, it's super important to remove your target branch. Otherwise, that branch will be sitting there and may create confusion in the future. For example, you might run git branch --no merged and think you haven't merged this branch into master. This is confusing. So we type git branch -d to remove bugfix/photo upload. Now we're going to get an error. Can you tell why? Take a look. The branch photo upload is not fully merged because once again, Git does not see this as a real merge. So here we have to enforce the deletion using a capital D. Okay, our branch is gone. Let's look at our history one more time. So we have a simple linear history. We have a single commit that combines all the changes for fixing the bug on the photo upload page. One last thing before we finish this lesson. When applying a squash merge on top of master, we might end up with conflicts. The process for resolving conflicts is exactly like before. So we bring up our merge tool, resolve the conflicts, and then make a commit. Let's talk about another technique for bringing changes from one branch into another. So here we have a feature branch with 2 commits. When we're done, we can do a merge, but we'll end up with non-linear history. Now, our history here is not too bad. It's not really complicated, but as we have more branches and we're working on more complex scenarios, our history might get really hard to read. So here we can use a different technique that will result in linear history. So we go back to the state before we do a merge. Look at the base of our feature branch. This is where we started the feature branch, right? Now, using the rebase command, we can change the base of our feature branch. So we can base it on the latest commit on master. What's the point of this? Well, look at the shape of our history. We have a direct linear path from feature to master. So if you want to merge the feature branch into master, we can do a fast forward merge. And now we have linear history. This is called rebasing. Now, while this sounds like a great idea, you need to be cautious with rebasing because rebasing rewrites history. And that means you should use rebasing only for branches or commits that are local in your repository. If you have shared these commits with other people in your team, if you have pushed your changes, you should not use rebasing. Otherwise, you're going to make a big mess. Let me explain why rebasing rewrites history. So here's the state before rebasing. When we rebase the feature branch, Git is not going to change the base or the parent of F1 because commits in Git are immutable. They cannot be changed. So Git is going to look at these commits. It's going to create new commits that look like F1 and F2 and apply them on top of master. Then it's going to move the feature pointer over here. Now look at F2. We don't have any branches or any other commits pointing to it. So at some point in the future, Git is going to remove this commit. So we are essentially rewriting history. These 2 commits that we have here, they're not the same commit as before. So if you have shared F1 and F2 with others, and other people have created new commits on top of F2, now after rebasing, their history is going to get screwed. So let's create a new feature branch called shopping cart. Git switch-c feature/shopping cart. Now let's make a commit in this branch. So I'm going to echo hello to cart.txt. The change doesn't really matter. Now let's add this to the staging area and then make a commit. Here we say add cart.txt. Now let's look at our history. So our shopping cart branch is 1 commit ahead of master, right? So if we do a merge, Git will do a fast forward merge. Now let's go back to the master branch and make a new commit. With this, our branches are going to diverge. So we should either do a 3-way merge or rebase. So let's go back to master. Here we're going to echo hello to table of content.txt. Now we're going to commit the changes and say update table of content. Good. Let's pull up the history one more time. Look, our branches have diverged. This is the base of these branches. This is where we created the shopping cart branch. Now in our shopping cart branch, we have this commit over here. And in master, we have another commit. So our branches have diverged. Now the number of commits doesn't matter. We could have tens of commits in each of these branches. What we want to do now is rebase the shopping cart branch. So we want to change its base from this commit over here to the last commit on master. So first we have to switch to our target branch. Git switch feature/shopping cart. Now we're going to run git rebase master. We're telling Git to change the base of this branch to the last commit on master. Beautiful. In this case, rebasing was done successfully. That is not the case in the real world. Most of the time, when you rebase, you end up with conflicts. We'll talk about it in a moment. But first, let's pull up our history one more time. So git log. All right, look, our branches have no longer diverged. We have a direct linear path from our feature branch onto master. So now if we decide to do a merge, Git will do a fast forward merge to bring the master pointer upward. So let's switch to master. We run git merge feature/shopping cart. Look, we have a fast forward merge. Now let's pull up the history one more time. So both our branches are pointing to the same commit over here, and we have a simple, clean, linear history. Now, what if there's a conflict? Well, let's have a look. So currently we're on master. Let's echo ocean to table of content.txt. The change doesn't matter. I just want to create a conflicting change. Now, let's commit the change and say update table of content.txt. Good. Now let's switch to our feature branch and make a conflicting change. So we're going to write something else to table of content.txt. So git switch feature / shopping cart. Now we echo, let's say mountain to table of content.txt, and then make a commit. Write mountain to table of content. Now our branches have diverged and we have a conflicting change. Let's verify this. So git log. Look, our branches have diverged one more time. We have this commit in our shopping cart branch and this other commit in master. And here's the base of our feature branch. So when we try to rebase it on top of this commit, we're going to see a conflict. Take a look. So we go to our feature branch and then run git rebase master. Look, we have a conflict in this file, table of content.txt. So here we should resolve the conflict exactly like before. We're going to launch our merge tool. So we say git merge tool. So here we need to decide how we're going to combine the changes. For this demo, it doesn't really matter. I'm going to pick one of these changes. Now we save the changes and close P4 merge. So as you can see in the terminal window, we are in the middle of rebasing our shopping cart branch. So next we type git rebase -- continue to tell Git to apply the next commit on top of master. Now, if the next commit also has a conflict, again, we're going to end up in the same state. So we have to resolve the conflict and then tell Git to continue rebasing. Alternatively, we can use another option, skip. This will skip the current commit and move on to the next commit. So if we look at the conflict and we realize that we don't actually care about this commit, we can skip it. We have another option here, and that is abort. This is useful in situations where we have so many commits to apply on top of master, perhaps our branches have diverged for a long time. In that case, if we don't have enough time for resolving all these conflicts and going through a complete rebase, we can abort the rebase here. So this will take us back to the previous state before we started rebasing. One last thing before we finish this lesson. Look at this question mark over here. That means we have new untracked files. Let's verify it. So git status. Look, we have table of content.txt.origin. What is this? Well, our merge tool, in this case P4 merge, automatically created this file as a backup. So let's look at the content of this file. So this is our table of content file before we resolve the conflict. We don't want this file in our repository. So we can remove it using the rm command or git clean, assuming that we don't have other untracked files that we want to add to our repository. Now our working directory is clean. We don't have any new untracked files, but for the future, to prevent our merge tool from automatically generating these files, we can set git config -- global merge tool dot keep backup to false. Here we have a feature branch with two commits, F1 and F2. Now, let's say one of these commits, like F1, has some interesting changes we want to have in master, but we're not quite ready to merge our feature branch into master. What should we do now? This is where we use cherry picking. So we can cherry pick this particular commit and apply it on top of master. Let me show you how to do this. Here in our history, you can see that our feature branch is one commit ahead of master. Now we're going to bring this particular commit into master without merging. So I'm going to copy this commit ID. Now we're currently on master. We type git cherry -pick and then type the commit ID. Here we have a conflict in table of content.txt. So let's open up our merge tool. Now in this demo, I'm going to take the changes in the remote branch, which is our feature branch. So I'm going to select this purple icon. Good. Save the changes. Close the merge tool. We're back here. As you can see in the terminal window, we're in the middle of a cherry pick. Let's have a quick look at our staging area. So our table of content file has some changes that are in the staging area. We also have this directory here, ds_store. Don't worry about it. This is only for Mac computers. This is one of those standard directories that we need to include in our git ignore file. For now, let's not worry about it. So let's make a commit. I'm not going to specify a message. The default message that we have here is based on the commit that we were trying to cherry pick. So we can accept it or change it if necessary. No, close. Back in the terminal. Let's look at our history one more time. So master has moved forward, and now we have this new commit that we cherry-picked from our feature branch. So you learn how to cherry-pick a particular commit from another branch and apply it to the current branch. But what if you're only interested in a single file, not a whole commit? Let me show you how to bring a given file from another branch into the current branch. So for this demo, I'm going to create another branch called feature/send email. Now in this branch, I'm going to make a change to our table of content file. So echo river to table of content.txt. Now, let's make a commit and say update table of content. Now let's say we want to bring this table of content file to our master branch. So first we switch to master. Now we're going to use the restore command. You learned about this earlier in the course. So we type git restore --source, or we could use -s for short. We set this to our target branch, feature/send email. And then we specify our file name, in this case, table of content.txt. Now, earlier I told you that sometimes Git cannot interpret the file name. So in those situations, we have to add double hyphens here to separate the options from the file or the files here. Now, when I run this command, Git is going to restore our table of content file in our working directory from the latest version of this file stored in this branch. Take a look. So our working directory is dirty. Let's get a short status. So we have some local changes in this file. We can view the content of this file using the cat command. So cat table of content.txt. So this is the change that we applied in our feature branch. Now we can stage the change and commit it in the current branch. Let's see how we can work with branches in VS Code. As I told you in the previous section, VS Code has limited Git features. So to bring additional features, we have to install an extension called GitLens. If you missed that video in the previous section, go to the extensions panel and search for GitLens. This is the extension we're going to use to work with branches. So once you install this, you're going to see this new icon over here. Here's our Venus repository. Over here, we have this folder called branches. We can see all of our branches here. So master is our current branch, as indicated by this tick icon. We also have these folders, bug fix and feature. The reason we have these folders is because I used a / in naming these branches. So bug fix / whatever. That is the benefit of using this convention. Now here we can change the layout. So instead of a tree structure, we can view our branches in a list. So we click on this icon. Now all of our branches are listed here. In front of each branch, we can see the last time this branch was updated. So as a best practice, if you're done with a branch, make sure to delete it. Otherwise, all these branches hanging there is just going to create confusion for you. Now we can expand any of these branches to look at its history. Unfortunately, at the time of recording this lesson, we cannot see all of our branches in a graph. To do that, we're going to use another extension, which I'm going to talk about at the end of this lesson. So master is the current branch. Now I'm going to create a new branch based on the last commit on master. So we right click here, and here we have a few options. We can switch to this branch. We can rename this branch, create a new branch, and create a tag. So let's create a new branch. I'm going to call this feature/reset-password. Now we get this error saying, this is not a valid branch name. I don't know what this is coming up. Don't worry about it. Just press enter. Now here we have a few options. We can create this branch, or we can create this branch and switch to it, or we can cancel. I'm going to go with the second option. Good. So we're currently on our feature branch. We can also see the current branch over here in the status bar. Now let's make a new commit in this branch. So I'm going to open table of content.txt and say beautiful weather. Save the changes. Now we go to the source control panel. Unfortunately, VS Code is not picking up our change, so we have to refresh the view. Good. So here's the change. Let's give this commit a message. We can say write beautiful weather to table of content. Well, we make a commit. Good. So let's go to GitLens. Here in our branches, we can see this new commit over here. Now, after a while, as we make new commits, we want to compare this branch with master to see how these branches have diverged. So with our feature branch selected, Here we can click on compare. And in this drop-down list, we can see all of our branches. So I'm going to select master to see how this branch is different from master. Let's expand this folder. So currently we have one commit, and this commit is in our feature branch. In a real situation, we could have several commits here. Some of these commits are on master, the others are on the feature branch. We can also see the summary of files that are changed. So in this example, our table of content file is changed. We can click on it to see the exact lines of code that have changed. In this case, we have this new line in our feature branch. So after we merge this branch into master, this new line is going to be added to table of content in master. Now I want to go back to master and make a conflicting change. So we can click on this branch on the status bar and go to master. Now let's open table of content and write something else here, like sunny day. Save the changes. Now we go to source control panel. Once again, we have to refresh the view. I don't know what's going on here. Let's say write sunny day to table of content. So we have a new commit here. Now we want to do a merge. So we get to GitLens. We're currently on master. Now we want to merge our feature branch into master. So we right click on our branch and select merge branch into current, which is master. We can also do a rebase. Either way, we're going to end up with a conflict. In this demo, I'm going to go with merge branch. Now here we have a few options. We can just do a default merge. So that is equivalent to executing git merge target branch. We have another option here, fast forward merge. So look at this option, -- only. With this, we're telling Git, hey, do a merge only if fast forward is possible. Otherwise, don't do a merge. We have another option here, no fast forward merge. We talked about this earlier in this section. If we select this, Git is going to create a merge commit even if fast forward is an option. We also have squash merge. Now in this demo, I'm going to go with the default merge. So look in the terminal window. You got a conflict in our table of content file. So on the left, we go to our source control panel. Let's refresh the view one more time. So under merge changes, we can see all conflicted files. So here we have a C, which means conflict. If we open this, we can see the conflict markers. So we can manually edit this file or use one of these options over here. In this case, I'm going to accept both changes. Save. Now, we need to commit the changes. So first, we need to stage them. So we click on this icon. Now this file is in the staging area. And here we have the default commit message. Now, let's make a commit. Good. So back in GitLens, here's our master branch. And here's our merge commit. Now let's say we screwed something up. We have a faulty merge. So we cannot compile our code or our application doesn't work. We want to undo this merge. What should we do here? Well, let's right click this. We can revert this commit. So this is going to create a new commit that will undo the changes in this commit. Unfortunately, at the time of recording this option doesn't work. So if you select this and go ahead with reverting this commit, we get this error in the terminal saying -m option was not given. We talked about this earlier in the section. So because a merge commit has two parents, we have to specify the parent number in order to revert this commit. So for this demo, I'm going to undo our merge commit. So back in GitLens, here's our merge commit. We want to reset the head to the previous commit over here. So we right click on this and select reset to commit. Here we have a few options. We can do a soft reset or a hard reset. A soft reset only updates the head pointer, but a hard reset also updates the staging area and the working directory to match the snapshot pointed to the latest commit. So here we're going to go with hard reset. Good. Now our merge commit is gone. Here in GitLens, we also have our stashes. Currently, we don't have any stashes. So I can go to our table of content file, make some changes. Now over here, we can stash all the local changes. So let's select that. Here we supply a message. Let's say new tags rows. Enter. So we have a new stash. Here we can see a summary of the changes. So we have 0 new files, 1 modified file, and 0 deleted files. Now at some point in the future, we're going to apply this stash to our working directory. So we can click on this icon, apply a stash. And here we have a few options. We can apply the stash, or we can pop this stash. This is going to apply the stash and then drop it, or we can cancel. So I'm going to apply the stash. Okay, our changes are back, and we can still see the stash here. When we're done, we can delete it very easily. So these are some of the features we have in GitLens. Now I told you that GitLens doesn't provide a graph of our branches. To see a graph, we should install an extension called GitGraph. So here in the extensions panel, GitGraph, it's right here. This gives us a beautiful graph of our branches. So once you install this, here in the source control panel, you're going to see a new icon called GitGraph. And now we can clearly see a graph of our branches. For example, here we have this branch, feature reset password, that is not merged into master. So we have this commit that is not included in master. Down below, you can see earlier we created this branch, and then later we merged it into master. Let's see how we can work with branches in GitKraken. So as you can see, here we have a beautiful graph of our branches. We can easily see all the branches we have created and whether these branches have been merged into master or not. For example, this feature branch, reset password, has a single commit and it hasn't been merged into master. In contrast, we have this other branch here, bugfix/change password. Earlier we created this branch from this commit on master. We added one commit to this branch and then merged it into master. So here's our merge commit. Now let's create a new branch from master. So master is the current branch. We can also change the current branch from this drop-down list over here. Now we right-click here and go to create branch here. Let's give it a name like feature/delete user. So now we are on this new branch. We can right-click it and rename or delete it. Now let's go to VS Code, make some changes and add a commit to this branch. So in our table of content file, I'm going to add 2 lines, green T. Save. GitKraken has detected our changes, so let's look at them. Here's the file that we have modified. Let's stage the changes and make a commit. We can say update, table of content. Good. So our branch pointer moved forward. Now we have one extra commit here that is not in master. Next, I'm going to switch back to master and make a conflicting change. So double-click master. Here in table of content, I'm going to say black T. Okay. GitKraken has detected our change. So let's go ahead and make another commit. Good. So look, our branches have diverged. Master is here, our feature branch is over here, and we can see the divergence. Now, before doing a merge, let's compare these branches. So currently the last commit on our feature branch is selected. I'm going to hold down the shift and select the master branch. Now the tips of these branches have been selected, so we can see their diff over here. The only file that has been changed across these 2 branches is our table of content file. So take a look. Obviously, we have a conflicting change on line 3. So when we do a merge, we're going to run into a conflict. Now let's close this and do a merge. So master is the current branch. We right-click on our feature branch, and here we can do a rebase or a merge. Let's go with merge. Our merge failed. On the right side, we can see merge conflicts detected. So here we can see all the conflicted files. Let's select table of content. I love this merge tool built into GitKraken. So on the left side, we have changes on master, and on the right side, we have changes on our feature branch. Now down below, we can see the output. So we can go ahead and select the changes in master, followed by changes in our feature branch. If this is not what we want, we can always deselect one or more of these lines or change their order. Now, if you have more than one conflict, we can browse through them over here. Very simple. When we are done, we click save. Our table of content file is now staged. And here's the default commit message, merge branch, feature/delete user. Now here we can abort the merge or commit it. Let's go ahead with that. So here's our merge commit, beautiful. Now let's say we screwed something up. So we want to undo this merge. We can either revert it or reset the head to the previous commit. So with this commit selected, we can right-click and go to revert commit. GitKraken is saying, do you want to immediately commit the reverted changes? Yes. So here's the revert of our merge commit. Alternatively, we can reset the head to the commit before our merge commit. So here's our merge commit, and here's the last commit on master. We can right-click this commit and go to reset master to this commit. Here we have three options you have seen before: soft, mixed, and hard. We're going to go with hard. Good. So our merge commit is now gone. So this was the essence of working with branches in GitKraken. As you can see, GitKraken makes it incredibly easy to manage branches and resolve conflicts. So you have learned all the essential Git tools to manage your personal projects. In this section, we'll be talking about various tools that you need to master to collaborate with others. We'll start off by talking about the most common collaboration workflows. Then we're going to talk about pushing, fetching, and pulling objects from remote repositories. Next, we'll talk about the essential collaboration tools on GitHub, the most popular Git hosting platform. We'll cover pull requests, issues, and milestones. And finally, we'll talk about contributing to open source projects. The tools we're going to cover in this section are super important. You'll be using them every single day when working with a team. So let's jump in and get started. So at the beginning of the course, I told you that version control systems fall into two groups: centralized and distributed. In centralized systems like Subversion, we have a single repository that is shared by all team members. The problem with these systems is that everyone is dependent on this central repository. If the server that is hosting this repository goes offline, no one can commit or view the project history. In distributed systems like Git, every developer has a repository on their machine. So they're not dependent on a central server. They can work offline with their local repository. But how can we collaborate with this model? Well, we can synchronize our work directly with each other, but this is often too complex and error-prone. Instead, we can use what we call the centralized workflow. So everyone has their local repository, but there's also a central repository they use to synchronize their work. This is the workflow used in most private teams and closed source projects. But you might be asking, hey Mosh, what is the point of this workflow? How is it better than a centralized version control system like Subversion? Well, with this model, we don't have a single point of failure. We can work with our local repository, and if the central repository is unavailable for a period of time, we can synchronize our work directly. Now, where should we put the central repository so it's accessible to all team members? Well, some organizations put this repository on a server in their private network. Others prefer to use Git hosting services like GitHub, GitLab, Bitbucket, and so on. With all these services, we can set up our repository as a private repository, so it's only accessible to our team and no one else. So let's walk through a real scenario. John and Amy want to collaborate on a project. They start off by cloning or taking a copy of this central repository. Now they both have a local repository on their machine. So John starts working and makes a few commits. Amy could be making other commits in the meantime, but let's not worry about that yet. Now, at some point, John needs to share his work with Amy. To do that, he uses the push command to send his commits to the central repository. The central repository is now in sync with John's work. Now, Amy can use the pull command to bring in John's work into her local repository. If John's work conflicts with Amy's work, she has to resolve the conflicts and then push her changes to the central repository. So this is the centralized workflow, which is used in most private teams. Everyone in the team has push access to write to the central repository. We have another workflow for open source projects called Integration Manager Workflow. In an open source project, we have one or more maintainers and many contributors. The problem is that we don't know these contributors, so we cannot trust them enough to give them push or write access to our repository. Only the maintainers of the project have push access to the project repository. So if you want to contribute, first, we should fork the project repository to get a copy of this repository in the cloud. Next, we clone this repository to get a local copy on our machine. We make a few commits, and when we're ready to share our work, we do a push to send our commits to our forked repository. Next, we send a pull request to the maintainer of the project. This is a feature built into platforms like GitHub. I'll show you how to do that later in this section. So the maintainer of the project gets notified. Then they can pull in our changes, review them, and if they're happy, they can merge our work into their local repository and then push the merged changes to the official repository. This is called the Integration Manager Workflow because someone is in charge of integrating changes. we cannot push directly to this official repository. That's why we have to fork it to get a copy in the cloud. Because this repository is in the cloud, it's also visible to the maintainer of the project, and that's how they can pull in our changes. All right, that's it for workflows. Next, we're going to create a GitHub repository to see these workflows in action. In this section, we're going to use GitHub, which is the most popular Git hosting platform. So it's going to host our central repository in the cloud. Now, if you don't use GitHub in your organization, that's perfectly fine. You should still watch the rest of this section to learn how to collaborate with others. So head over to github.com. If you don't have an account, create one. It's free and takes only a few seconds. Just make sure to verify your email before proceeding. So here I'm logged in. Let's create a new repository on the top. All right, first we give our repository a name. I'm going to call this Mars. We can optionally give it a description. Next, we should decide if this repository is going to be public or private. If we mark this as public, anyone on the internet can see this repository. This is useful for open source projects. If we set it as private, we choose who can see and commit to this repository. But to use a private repository, we have to pay. So for this demo, I'm going to go with a public repository. Next, we can initialize this repository with a README file, with a gitignore file, and a license. I'm going to select this README file over here. So GitHub is going to add this file and create the first commit for us. Take a look. So create repository. Here's our repository. Beautiful. Now look at the URL, github.com/your username/your repository. So anyone on GitHub can have multiple repositories. Over here, you can see the current branch, that is master. We have only one branch and 0 tags. In this box, we can see the content of our project. So currently we have only a single file, that is our README file. We can click on this to see its content. Pretty basic. Now let's go back. Here on the top, we can see the latest commit. That is the initial commit that GitHub created. Here's our commit ID, the date time it was submitted, and here we can see the total number of commits. So if we click here, we can see a log of all of our recent commits. So here we can see the commits on the master branch. If we had multiple branches, we could select them here to filter the log. Now to see more details about a commit, we can click on it. So you can see this commit was submitted on the master branch. It was submitted by me about 5 minutes ago. Of course, it actually happened a minute ago, but I had to pause the recording. That is why. Here you can see a summary of the changes in this commit. So we have one changed file with 1 addition and 0 deletions. That means we have added 1 line in this file. Here's the file we're talking about, README. And over here, you can see a diff of this file. All right, now that we have a repository, next I'm going to show you how to add collaborators here. So even though this repository is public, no one but me can push or write to it. Other people can see my code and commit history, but they cannot push new commits. So if you work in a team, you should add your team members here and give them push access. Let me show you how to do this. So over here, we have a tab on the right side called Settings. Here we go to Manage Access. Now look, currently we don't have any collaborators. We can invite our team members by their GitHub username, full name, or email. So I'm going to look myself up. Here's my other GitHub account, but please, please, please don't invite me. I don't want to get 1,000 notifications every time someone watches this course and is following along. So I'm going to add myself. Now I have an invitation that is pending. So I'm going to get an email. In that email, there is a link for me to accept or decline the invitation. Once I accept the invitation, then I will have push access to this repository. So we have a GitHub repository in the cloud. Now every team member should clone this repository. That means they should take a copy of this repository and put it on their machine. Locally, they will work with that repository. When they're ready to share their changes, they will push their commits to this central repository, okay? So to clone this repository, we go to the Code tab. Here we can see the full URL of this repository. Let's copy this. We go to the terminal and type git clone and paste the URL. When we execute this command, Git is going to create a directory by the same name as our repository. If you don't like this name, you can always change it. So here we can say Mars project. Take a look. So Git cloned our entire repository, so all the commits in the central repository also exist here on my machine. Currently, we have only a single commit. Now, let's go to this directory, Mars project, and run git log. So currently, we have a single commit. Now look at these pointers. We have head pointing to master, and we have these two pointers in red, origin/master and origin/head. What are these? Well, when we clone a repository, Git names the source repository, in this case, the one that we have on GitHub. Git names that origin. So origin is a reference to that repository. Origin/master tells us where is the master branch in that repository. Because now we have multiple repositories, the history in each repository can evolve independently. So origin/master tells us where is the master branch in our origin repository. Now, technically, this is called a remote tracking branch. It's a branch, but it's not the kind of branch you are familiar with. So we cannot check it out. We cannot commit to it. So if you type git switch origin/master, we get an error. If we type git branch, we can see we only have a single branch, the master branch. So origin/master is a remote tracking branch. Similarly, origin/head tells us where is the head pointer in our origin repository. Now here we have a useful command you should be familiar with, git remote. This shows the list of remote repositories. A remote repository is a repository that is not on our machine. More accurately, it's not in the current directory. So currently we have only a single remote repository. That is our origin repository. If we type git remote -v for verbose, we can see more details about this remote repository. So origin is referencing this repository over here, github.com/codewithmosh/mars.git. So this is the URL that Git is going to use when we talk to this remote repository. So here's the current situation. On the left side, we have our local repository. And on the right side, we have our remote repository, which is the repository hosted by GitHub in the cloud. Now, one thing you need to understand here is that our local repository is not connected to the remote repository. So if you have a new commit in our remote repository, our local repository will not be aware of that. Here we have to use the fetch command to download this new commit. So Git is going to download this new commit and then move origin/master forward. So as I told you before, origin/master is a remote tracking branch and tells us where is the master branch in origin. In this case, it's pointing to B. Even though we downloaded this new commit, our working directory is not updated because currently master is pointing to A. That is the previous commit, the previous snapshot. So we don't have those changes in our working directory. Now, how can we bring those changes here? Well, we have two branches. Doesn't matter that one of them is a remote tracking branch. To bring those changes into master, we have to merge the other branch into master. So we switch to the master branch and type git merge origin/master. Now, in this case, our branches haven't diverged and we have a direct linear path from origin/master to master. So we're going to have a fast forward merge. In contrast, if our branches had diverged, potentially we could have a conflict. So we would have to resolve the conflict just like before. Let's see this in action. Here on GitHub, we can go to add file, create a new file, or upload files. We can also edit existing files. So in this demo, I'm going to edit our README file and create a new commit directly on this repository. So let's click on README file. Then we click on this pencil icon. Now let's add a new line of code. We can preview our changes. So we are adding this new line that is indicated by green. And over here, we can specify our commit message. So by default, GitHub is suggesting update README. We can leave it as is. Optionally, we can add some description here as well. Now here we have two options. We can commit directly to master, or we can create a new branch and start a pull request. I'll talk about the second option in the future. So let's commit this directly on master. Now, back on the homepage of our repository. So you can see we have two commits. Let's have a quick look. Here's our new commit, update README. Now, back in the terminal, we don't have this new commit in our local repository. Let me show you. So we type git log. Look, we only have this commit over here. That is the initial commit. So to download a new commit, we have to type git fetch. Then we specify the remote, in this case origin. And optionally, we can specify a branch. So if you want to download the commits on a particular branch, we can type the branch name here. If we leave it out, we're going to download all the commits in that remote repository. Now, if we drop origin, Git assumes that we want to fetch the commits from origin. So let's go with that. All right, we fetched the new commit. Let's verify it. So let's look at the log one more time. See, our remote tracking branch has moved forward. So now we have this new commit, but this commit is not on our master branch. So master is behind by one commit. There is another useful command you should be familiar with. That is git branch -vv. It shows how our local and remote tracking branches are diverging. So our master branch is linked to this branch, origin/master, and is behind by one commit. So now we have to do a merge. So we're currently on master. We type git merge origin/master. Because our branches haven't diverged and we have a direct linear path from this target branch into master, we're going to have a fast forward merge. Take a look. There you go, fast forward. Now let's look at the log one more time. So git log. So master and origin/master are pointing to the same commit. We can also verify this using git branch -vv. So we no longer have that message, one commit behind. Now we can look at the content of our README file using the cat command. So cat readme, and here's the new line that I added on GitHub. So this change is now in our working directory. So to bring the changes in a remote repository into our local repository, most of the time we have to do a fetch followed by a merge. So we have a command that combines the two. It's the pull command. Let's see how it works. So let's say our local and remote repositories are in the same state. We have a single commit in both these repositories. Now our repositories are going to evolve in different ways. So in our local repository, we're going to add this new commit, B, and in our remote repository, we're going to add this other commit, C. So when we run git pull, Git is going to download C and put it into our local repository. Note that origin/master is pointing to C. So now our branches have diverged. In this case, Git is going to perform a three-way merge to bring the remote changes into our master branch. Now, some people don't like these merge commits because they pollute the history. So alternatively, we can use rebasing here. So I'm going to undo the merge commit. We're in the same state as before. If we use the rebase option, Git is going to rebase our master branch on top of origin/master. So what is the base of our master branch? It's A. When we use the rebase option, Git is going to change the base of our master from A to C. So essentially, it's replaying our local changes on top of changes made by others. With this, we'll end up with simple, non-linear history. Now, which approach is better? Well, it depends who you ask. This has been a discussion going for years. Some people love rebasing, others prefer merge commits. Now let's see this in action. So once again, let's create another commit on GitHub. I'm going to edit README file and add yet another line of code. Now let's make a commit. Good. So back in the terminal, I'm also going to make a commit in master so our local and remote branches diverge. So we can add a new file, file1, then add it, commit it, add file1. Good. Let's have a quick look at our log. So git log. So our master branch is ahead of origin/master by one commit. But at this point, we are not aware of the commit we made on GitHub. So if we run git pull, Git is going to download the new commit in our GitHub repository and then perform a three-way merge to bring those changes into our master. Take a look. So here's the default message for our merge commit. We're going to accept it. Now back in the terminal, let's look at the log one more time. There you go. Here's our merge commit that combines the changes in origin/master and master. So we ended up with non-linear history. Now here we can use rebasing to create linear history. But before doing so, I'm going to undo this last merge commit so we end up in the previous state. So we type git reset --hard head ~1. Okay, let's look at our log. So we're in the previous state before the merge commit. Our branches have diverged. Now we can run git pull rebase to replay our local changes, in this case, adding this file on top of the changes in origin/master. So we type git pull -- rebase. All right, now let's look at the log one more time. Now we have simple linear history. This commit that we have in master for adding file 1 is added on top of the last commit we made on GitHub. Now look over here. My terminal window is saying that I have one commit to push to origin. I'll show you how to do that next. So in our local repository, our master branch is ahead of origin/master by one commit. So we can use the push command to send this new commit to origin. When we run this command, Git will send our new commit to the remote repository. Then it will move the master pointer forward to point to C. And finally, it would move origin/master to point to C as well. So we type git push. Next, we specified the remote repository, in this case, origin. And finally, we specified the branch we want to push, master. Now, currently we are on the master branch, so we can drop master. Also, if we drop origin, Git will assume origin by default. So we just type git push. Here we have to enter our GitHub credentials. So I'm going to add my email and password. Good. So Git sent our new commit to origin. Let's verify it real quick. So here on GitHub, look, we have 4 commits, and here's the last commit that we just pushed. Add file 1. Now, sometimes your push may get rejected. Let's see why. So once again, our local repository is ahead of origin by one commit. Now, let's say before we do a push, someone else does a push and adds a new commit to origin. Now, if we do a push, our push will get rejected because our histories have evolved differently. So Git prevents us from overwriting someone else's work. Now, I've seen some people using the force option here. This is a terrible thing you can do. With this, you're telling Git to drop other people's work and replace it with your work. This is not what we want. So unless you have a very strong reason for using the force option, you should never, ever, ever, ever use this option. Basically, you should use this only if you have screwed things up. So what can we do here? Well, we have to do a pull to bring other people's work into our local repository. Then we have to do a merge or a rebase. If there are any conflicts, we have to resolve them, and then we can do a push. Now here's a question for you. Look at the history of these 2 repositories. What commits do we have in our local repository that don't exist in origin? C and M, right? Because in both these repositories, we have A, B, and D. So when we do a push, Git will send these 2 commits to origin. Now we have the same state in both these repositories. The final code and the history of changes are identical. In the previous lesson, you saw that when I tried to push my commits, I had to enter my GitHub credentials, my GitHub username and password. Now, we don't want to enter our credentials every time we want to do a push. That is too tedious and time-consuming. The good news is that we can store our credentials in memory or on disk and tell Git where to find it. All we have to do is to set a configuration value. So we type git config -- global. We set credential.helper to. If we set it to cache, Git will store our credentials for 15 minutes in memory. If that's not sufficient for you and you want to store your credentials permanently on disk, on Mac you have to use Keychain, and on Windows you have to use Windows Credential Store. These are both storages for storing sensitive data. So our credentials will get stored in an encrypted way. So if you're on Mac, first you have to find out if Keychain Helper is installed or not. So we type git credential-osx keychain. As you can see, Keychain Helper is installed on my machine. If it's not installed on your machine, you will see the instructions to install it. It's very easy. Once you install Keychain Helper, then you set git config -- global credential.helper to osx keychain. That's all you have to do. Now, if you're a Windows user, you have to install Git Credential Manager for Windows. So head over to github.com/Microsoft/Git Credential Manager for Windows. On this page, you can find an installer. It's right here. So download this and follow the instructions. Unfortunately, I don't have a Windows machine to show the process, but it should be very easy. You shouldn't have any problems. By default, the push command doesn't transfer our tags to a remote repository. We have to explicitly push them. So let's create a new tag called version 1.0. This tag is added to the last commit. Let's verify it real quick. Okay, so here's our tag. Now this tag is only available in this repository on my machine. If I want to send this to GitHub and share it with other team members, I have to type git push origin v1.0. All right, beautiful. Our tag is now on GitHub. Let's verify it real quick. So refresh the page. Here we have one tag. Let's click here. On this page, we can see the list of all the tags in this repository. We can click a tag to see more details. So you can see who has created this tag when. And over here, you can see these assets that GitHub automatically generated for us. So we can download our entire source code at this point in time. This is very useful. Now, if we push this tag by accident, we can remove it using the push command. So we type git push origin, exactly like before, but before the tag name, we type -- delete. This is going to delete this tag from origin. Take a look. All right, our tag is gone. So back on GitHub, we no longer have a tag, but this tag is still in my repository. So if I type git log, look, this tag is still here. If we don't need it here, we can simply type git tag -d for delete v1.0. One of the GitHub features that goes hand in hand with tags is release management. We can create a release to package our software along with source code, binary files, and release notes. Let me show you. So here on the homepage of our repository, we go to tags. Then we go to the releases tab. Currently, we don't have any releases. So let's create a new release. Now over here, we can find an existing tag or create a new tag. Currently, we don't have any tags. So I'm going to type v1.0. When I create this release, GitHub will automatically add this tag to the latest commit. Next to that, we have our target branch, which is master. Here we give our release a title. We can use the same value, version 1.0. Now in this box, we can type our release notes. For example, we can type a # to add a title and say release notes. Then using hyphens, we can add bullet points. For example, we can say fixed bug 1, fixed bug 2, added the form, Now we can preview our changes. So here are our release notes. Beautiful. Now, over here, we can attach binary files. So we can include the compiled version of our application. Now, if this release is not production ready, if it's not stable, we can tick this box. This is a pre-release. And finally, we click on publish release. All right, here's our first release. We can see our release notes along with these assets that GitHub automatically generated for us. Now, if we included binary files, like the compiled version of our application, those binary files would also be listed here, okay? Now, over here, you can see this release is based on this tag, v1.0, which is added to the last commit in our repository. Here we also have a label saying this is the latest release of this repository. Now, if you made a mistake, you can always delete this release. So to the right side of this page, which is not currently in my recording window, we have two buttons, edit release and delete. Now, back to the home page of our repository. Here on the right side, you can see all the releases. So this is all about release management in GitHub. Just remember, this is not a Git feature, it's a GitHub feature. It's a high-level feature built on top of tags. So far, we've been doing all the work on master. Now let's talk about working with branches. So similar to tags, our branches are private or local by default. So if you want to collaborate with other team members using a branch, we have to explicitly push that branch the same way we push tags. So I'm going to create a new branch called feature/change password. Now this is a private branch in my local repository. It doesn't exist on GitHub. So if we run git push, we get this error saying the current branch has no upstream branch. This basically means that this branch is not linked to a branch in origin. So Git is suggesting to run this command to solve the problem. But before doing so, let's run git branch -vv. So look, here we can see our local and remote tracking branches. So master, which is a local branch, is linked to origin/master, but feature/change password is not linked to a remote tracking branch. Now to see all the remote tracking branches, we can type git branch -r. So currently we have only these two pointers, origin/head and origin/master. So to link this private branch to a branch in origin, the first time we want to push it, we have to type git push -u, that is the short form of set upstream. Then we type the remote, in this case origin, followed by the name of the branch, so feature/change password. All right, beautiful, our branch is pushed. We can verify it on GitHub, so let's refresh this page. Now we have 2 branches, and here's our new branch. Then back to the terminal, if we type git branch -vv, you can see that this local branch is now linked with this remote tracking branch, origin/feature/change password. Also, we can look at all the remote tracking branches. So now we have a new remote tracking branch. Perfect. Now we can start working with this branch the same way we worked with master. So we can make new commits here and then push them to origin. At some point when we are done, we want to remove this branch. To do that, we type git push. Then previously we used -u. Now we're going to use -d for delete. Then we type the remote, followed by the branch name, feature/change password. Now this branch is deleted from origin. We can verify it right here. So refresh. We only have a single branch. Now let's type git branch -r. Our remote tracking branch is gone. Beautiful. But what if we type git branch -vv? We still have this local branch that is linked to origin/feature/change password. But right in front of this remote tracking branch, we have gone. So even though we remove this branch from origin, our local branch is still there. So if we type git branch, we can see it's right here, and we're currently on this branch, so we cannot delete it. So we have to switch to master, and then type git branch -d feature/change password. So this is how we can create and delete branches in a remote repository. Next, I'm going to walk you through a real collaboration scenario using branches. Let me walk you through a real collaboration scenario using branches. So let's say Amy and I are going to work on a feature together. So one of us should create a feature branch and push it to GitHub. That is one way, but there is another way. We can create a branch directly on GitHub. So in this drop-down list, we can view all of our branches. We can also create a new branch. So I'm going to call this feature/change password. Enter. All right, now we have a new branch, and this branch is currently selected in this repository. Now look over here. This branch is even with master. So as we push to this branch, we can see how far this branch is ahead of master. This is very useful. Now back in the terminal, I'm going to run git fetch to get this new branch. So we got a new branch called feature/change password. We also got a new tag. That is the tag that we created earlier in this section. Now let me show you something. If we type git branch, we only see master. But what happened to our new branch? Well, let's run git branch -r. Look over here. We have a remote tracking branch. So when we ran fetch, we only got a remote tracking branch. Now we should create a private branch in our local repository that maps to this remote tracking branch. So we type git switch -c. We're going to call this feature/change password. Now we want this branch or this pointer to be at the same location as our remote tracking branch. So origin/feature/change password. All right, beautiful. Git is saying that this new branch is set up to track the remote branch from origin. Perfect. So here on my machine, I can add new commits to this branch and then push them to origin. Now I'm going to switch to another terminal window to simulate Amy's workspace. So here's Amy's workspace. Amy is going to start by cloning this repository. So we go over here, grab the URL of our repository. Good. Now we type git clone. All right, let's go to this repository. So here on Amy's workspace, if we type git branch, once again, we don't have that feature branch. So Amy should also create a private branch that maps to that remote branch. So git switch -c feature/change password. This branch should be based on origin/feature/change password. Great. Now on behalf of Amy, I'm going to make a commit and then push it to GitHub. So something really simple, we can echo password to file1, then make a commit and say update file1. Then we do a push, so git push. Beautiful. Let's verify that we have this new commit on GitHub. So here on the homepage of our repository, we can see this message, feature/change password had recent pushes 1 minute ago. Here we have a button for comparing and creating a pull request. Let's not worry about it yet. We'll talk about it soon. Instead, let's go to the list of our commits. So currently we have 4 commits. These are the commits on master. Let's change this to our feature branch. So here's the new commit that I just pushed. Beautiful. So Amy and I are going to keep pushing to this branch. And in the meantime, we have to pull each other's changes. And if there are conflicts, we have to resolve them and then do another push. Now, at some point, this feature is going to be complete. Let's say I'm the person responsible for closing this branch. So on my machine, first I have to bring in Amy's changes. So we run git pull. All right, we have a fast forward. Beautiful. Let's have a look at our history. So git log, one line all graph. Take a look. Our feature branch is 1 commit ahead of master. So we have to merge this branch into master. That is very easy. We switch to master and then run git merge feature/change password. Good. Once again, we have a fast forward merge because this is a very simplified example. In a real case scenario, most likely you will have conflicts. But I'm not going to repeat that here because we already talked about resolving conflicts. Now, let's look at our log again. Look, now master and feature/change password are pointing to the same commit. However, origin/master is 1 commit behind master. So here we have to do a push to send the final changes to GitHub. So I'm currently on master and I run git push. All right, our changes are now in GitHub. Let's look at our log one more time. So master and origin/master are now at the same location. Beautiful. Now here on GitHub, we have 5 commits. Let's have a quick look here. So here are the commits on master. Obviously, we have the commit that was for implementing the change password feature. So we're done with this feature. Now we should close this branch. So I'm going to type git push -d origin feature/change password. I'm going to remove this branch from origin as well as its remote tracking branch in my local repository. Good. Now let's look at our branches. We still have this local branch. We don't need it anymore. So let's remove it here as well. Git branch -d feature/change password. Beautiful. So on my machine, I only have the master branch. Let's look at our remote tracking branches as well. Git branch -r. Okay, we no longer have that remote tracking branch. Perfect. Now, what about Amy? Well, she's still on the feature branch. So on behalf of Amy, first we should switch to master. Now we should do a pull to bring in the merge changes that Mosh pushed. So git pull. Good. So now both Amy and I have the same history. Now let's look at our branches. We still have the private feature branch. So let's delete it real quick. Good. Now what about our remote tracking branches? So if we type git branch -r, look, we still have this remote tracking branch, even though this branch is removed from origin. To remove the tracking branches that are not on the remote, we type git remote prune origin. Now look, this remote tracking branch, origin/feature/change password, is pruned. So if we run git branch -r, we no longer see that remote tracking branch. So this is how 2 or more people can collaborate on a feature. Quite often, as part of implementing a feature or fixing a bug, we would like other team members' feedback about our code. This is where we use pull requests. With a pull request, we essentially open a discussion in the team before merging a branch into master. Let me walk you through a real scenario. Let's say Amy is going to implement a new feature. So here on Amy's machine, I'm going to start a new branch, add a commit to it, and then push it to GitHub. So git switch -c feature/login. Now let's echo hello to file3.txt, stage the file, make a commit and say, write hello to file3. Now let's push this branch. So git push, the first time we should use -u to set the upstream branch. We're going to push this to origin and call it feature/login. Now I need to enter my credentials because the cache is expired. All right, beautiful. Now here on GitHub, we see this message, feature/login had recent pushes 1 minute ago. We can compare and create a pull request. Alternatively, we can go to the pull request tab and create a new pull request from here. On this page, we have to select two branches. The base branch, which is often master, and the target branch, which is our feature branch. So before merging this branch into master, we want to start a pull request or a discussion in the team. Now, because we're dealing with a simple change, only a single commit and no conflicts, we can see that we can automatically merge the changes. Quite often, that's not the case. We often have conflicts that we have to resolve. We'll talk about that later. Now, over here, we can see the summary of changes. So we have one commit, one file change, 0 comments, and 1 contributor. Here's the commit that we just pushed, write hello to file 3. Over here, we can see the summary of changes. So we wrote this line in file3.txt. Beautiful. Now, let's go ahead and create the pull request. In this case, because we have a single commit, GitHub used our commit message as the title for this pull request. I'm going to change this to something more descriptive. So we're implementing a new feature for social login. We want to allow the user to log in via Facebook. So social login, that's better. Here we can write some details about this pull request. So if there are things that we want other people to review specifically, we can list them here. Now let's go ahead and create this pull request. All right, here's our pull request. Beautiful. It's saying Code with Mosh wants to merge one commit into master from feature/login. Now, let's say I'm Amy. So I'm going to add Mosh as a reviewer. So over here we can see all the collaborators in this project. Earlier in this section, I told you how to add collaborators. So I'm going to add Mosh. Good. Now we have a yellow icon here saying we are awaiting requested review from Mosh Hamadani. So Mosh is going to get an email saying, Amy needs your review. Now I'm going to open another browser window on behalf of Mosh. All right, here's Mosh's screen. On this page, we're going to go to pull requests. We have one open pull request, so let's take a look. Look at this message. Code with Mosh requested your review on this pull request. So I can go ahead and add my review. Now this box pops under this button, review changes. I find this confusing, so I always like to click away to close it and get back to it later. Here we can see the summary of all the changes. So in this case, we have a single file, file3, and we have this new line in this file. We can add comments to individual lines by clicking on this icon. I can say, this line is good, but it's better if you capitalize H. Of course, I can write a rich review using bold and italic stuff, but let's not worry about it. So let's start our review. So I added one comment to this line of code. Of course, I could add many more comments. Now I'm going to finish my review and write a general description saying, please make these changes and do another push. I can mark this as comment. I can approve this pull request, or I can request more changes. I'm going to request more changes and submit my review. Good. Now we are on the conversation tab. We can see the timeline of things that have happened. So initially, Amy started this pull request with these details. Here's the initial commit, write hello to file3. Then Amy, or in this case, Code with Mosh, requested a review. Then Mosh Hamadani requested changes. And here are the details about these changes. So the general comment, as well as comments to individual lines of code. Also over here, we see this red icon saying Mosh Hamadani requested changes. Now back on Amy's machine, let's make a change and do another push. So I'm going to echo hello with a capital H to file3.txt. Then I'm going to stage and commit all the changes, say capitalize hello. Then let's do a push. So Amy did a push. Now back on GitHub, she can come over here and request Mosh to review the code again. So this will send Mosh a new notification, a new email. Now I come back here and see this message one more time. Code with Mosh requested your review on this pull request. So I can add my second review. Once again, I like to click away and see the updated code. So I think this is great. I'm going to take this file as reviewed and then submit my final review. So I'm going to say, everything looks perfect. Let's go ahead with merging. And then I can select approve and submit the review. All right, the changes are approved. Beautiful. Now up here on the conversation tab, next to this reviewer, now we have a tick. So we can go ahead with merging. To do that, we go down below and we have this button, Merge Pull Request. Now here's a question. Who should merge this pull request? Well, there are two opinions. Some teams believe that the person who started a pull request should not be able to close it. The pull request should always be closed by someone else. Otherwise, these pull requests are meaningless. Anyone can start and close them. But there's also a different opinion out there. Some people argue that the person who started a pull request knows about that issue the most. So when it comes to merging, most likely we're going to have conflict. It's really helpful to have that person on board. So they argue that the person who opens a pull request should be the one closing it as well. So there's really no right or wrong. It really depends on your team's culture. Now, here we have a few options. We can create a merge commit. We can squash and merge, or we can rebase and merge. We covered all these options before, so I'm going to go with a simple merge commit. All right, our pull request successfully merged and closed. Now we can delete this branch. Good. If we made a mistake, we can always come back here and restore the branch. Now back on Amy's machine, let's switch to master and then do a pull. Beautiful. Now let's look at the history. All right, so this last commit over here is our merge commit. Merge pull request number 1 from code-with-mosh/feature/login. Both my master and origin/master are pointing to the same commit. We no longer need this feature branch. So we should delete this local branch as well as the remote tracking branch. We already removed this branch from GitHub. So now we need to remove it from this repository. To do that, we type git remote prune origin. As I told you before, this removes the branches that don't exist on the remote, in this case, origin. So now if we type git branch -r, we don't have that remote tracking branch. Beautiful. Finally, we need to remove our local branch. So git branch -d feature/login. Now, what if you have conflicts when merging and closing a pull request? Well, once again, on Amy's machine, I'm going to start a new branch, add a commit, push it, create a pull request, and in the meantime, I'm going to create a conflicting change on master. So when we merge this branch into master, we get a conflict. So let's create a new branch called feature/logout. Now on this branch, I'm going to write hello to file1.txt. Let's commit the changes and say write hello to file1. Now let's push this branch. So push -u origin feature/logout. Now on GitHub, we have this new branch, feature/logout. We can start a pull request, but before doing so, let's add a conflicting change in master. So back to Amy's machine, let's switch to master and write something different to file1. So I'm going to write world to file1.txt. Now let's commit the changes, write world to file1, and then do a push. Of course, this doesn't have to happen on Amy's machine. Someone else might have a pull request that is open. That pull request might get merged into master, so master can move forward without Amy being aware of that, okay? Either way, we have a conflicting change. So let's go ahead. Now let's say Amy has finished her work, so she wants to start a pull request. So over here, we click on compare and pull request. Now look, GitHub is saying that it cannot automatically merge the changes because we have conflicts. But don't worry, we can still create the pull request. So let's give it a title, feature logout. I'm going to leave out the description, doesn't really matter. All right, now we have a pull request. At some point in the future, we want to merge and close this pull request. Now look over here. GitHub is saying this branch has conflicts that must be resolved. So here we have two options. We can use the command line or use the GitHub user interface. If you want to use the command line, the process is exactly like before. So someone who is in charge of merging, it could be Amy or someone else. That person first has to pull in the latest code. Then they have to start the merge process. They're going to get conflicts. They will resolve the conflicts, add a new commit, and then push it to GitHub. Exactly like before, nothing different. So in this lesson, I'm going to show you how to resolve conflicts on GitHub. That is very simple. So we click on Resolve Conflicts. Now on this page, we can see all the conflicting files on the left. In this case, we have a single file. And on the right, we can see our conflict markers. You have seen these before. So in this branch, feature/logout, we have added hello. On this branch, on master, we have added world. So we need to decide what changes we need. In this case, I'm going to bring the changes in both these branches. So let's delete the markers. We're left with hello world. Now, if you have multiple conflicts, we can browse through them using these buttons. Now, let's mark this as resolved. Good. So now we need to commit the changes onto feature/logout. So commit. Good. Now back to our pull request. Down below, we no longer have that message saying there are conflicts. So we can go ahead and merge the pull request. Done. One of the features of GitHub that goes hand in hand with pull requests is issue tracking. So here on the Issues tab, we can track all kinds of issues like bug fixes, new features, enhancements, or any kind of ideas we want to discuss in the team. So let me walk you through a real example. I'm going to create a new issue. We give it a descriptive title like send email when someone signs up. Here we can write more details about this issue. We can also attach files. This is very useful. It's much easier than tossing emails around. So all the details for working on an issue are encapsulated in a single place. Now here we can optionally assign this issue to one or more people if we know ahead of time. If not, people can come in and assign issues to themselves. In this case, I'm going to assign this issue to myself. Okay. Now we can also add labels to this issue. So every Git repository has these labels by default. We have bug, documentation, duplicate, enhancement, and so on. We can also customize these labels. I'll show you how to do that in the next lesson. So let's add enhancement. Now, let's go ahead and submit the new issue. All right, here's our issue. On this page, we can have a conversation about this issue. So anyone in the team can come in and leave comments. This is very useful. Now, one thing that I love here is that we can link this issue with a pull request. With this, when we merge and close a pull request, this issue will be automatically closed. We can also assign this issue to a milestone. I'm going to talk about that later in this section. Now, if this issue is not linked to a pull request, we can always come in here and close this issue manually. Now, let's go back to the list of issues. So we have a single issue here that is an enhancement. You can immediately see that I'm working on this issue. This is very useful in Teams. So anyone can come in here and see who is working on what. And if someone doesn't have any work to do, they can always come in here and pick an issue. So I can come in here and assign this issue to myself if it's not assigned to someone else. Now let's go back. Now here we can filter the list by author, label, projects, milestones, assignees, and we can also sort the result in different ways. I'm not going to go through these. They're really simple. You can figure them out on your own. Next, I'm going to show you how to customize the list of labels. Let's see how we can customize the list of labels in a GitHub repository. So here on the Issues tab, we go to Labels. On this page, we can see all the default labels that exist in every GitHub repository. We can create a new label, let's say refactoring. We can optionally give it a description and a color. Now, if you don't like this color, you can click here. GitHub automatically generates a new color that is reflected over here. Now let's create the label. Good. Now look over here. For the enhancement label, we have one open issue or pull request. So this is also another useful report. We can see all the labels and the number of open issues assigned to them in one place. Now let's talk about milestones. We use milestones to track the progress of various issues. So we can add a bunch of issues to a milestone and then see how much we have progressed in that milestone. So here on the Issues tab, we go to Milestones and create a new milestone. We give it a title. This can be anything that is meaningful to the team. For example, if you're working on version 2 of our software, the title can be 2.0.0. Now, optionally, we can give it a due date. So I'm going to set this to, let's say, 30th of September 2020. We can also give it a description and then create the milestone. So here we have one open milestone that is due by September 30th. Now over here, you can see the progress of this milestone. Now currently, we don't have any issues assigned to this milestone. So let's go to the Issues page and select this issue. And of course, we could select multiple issues and then put them in a particular milestone. Good. Now, look over here. This issue is assigned to our version 2 milestone. Now let's go to the Milestones tab. Now look over here. We have 1 open issue, 0 closed, and we're at 0% complete. If I close this issue, our milestone will be complete. Let me show you real quick. So we go to the issues. I'm going to select this issue and then mark it as closed. Okay, good. Now back to the milestones page. Look, our milestone is complete. This is a very useful report. So we have covered all the essential collaboration tools. Now let's see how we can work on an open source project. For this demo, I'm looking at this repository, Vidly MSE5, in my personal GitHub account. Let's say you want to contribute to this repository. Perhaps you found a bug or want to implement a new feature. So you come to the Issues tab. You can create a new issue and describe the bug or the feature you want to implement, or you can pick one of the existing issues. Currently, there are 79 open issues here. Now here's the problem. You don't have push access to this repository. Only I can push to it. So what you need to do is you go to the top and fork this repository. When you fork this repository, GitHub will take a complete copy of this repository and put it in your account. You have full control over that repository. You can create new branches, new tags, you can push your stuff, you can do anything you want, right? So currently, I'm logged in using my other GitHub account, that is Code with Mosh account. I'm going to fork this repository that is in my personal account. Take a look. It's going to take a few seconds. All right, look, we have a copy of this repository in my Code with Mosh account, which is forked from my personal account. So this is my repository in GitHub. Now I'm going to clone it on my local machine and start working on it. So let's go to Code, grab the URL, and then clone this repository. Good. So now let's go to this directory. I'm going to start a new branch, git switch -c. We can call it bugfix. Now on this branch, I'm going to make a commit. So let's echo hello to our README file and then make a commit and say update README. Good. Now I'm going to push this branch to my GitHub repository. So git push -u, the first time I'm going to push this branch, origin, which represents my forked repository, and then the name of the branch, that is bugfix. Now, back on GitHub, my bugfix branch has recent pushes. So when I'm done with this branch, I can start a pull request. Now look over here. We're trying to compare the bugfix branch in this forked repository in my Code with Mosh account. We're comparing that with master of this base repository that is in my personal account. So starting a pull request is exactly like before. The only difference that we have here is that we have 2 repositories. The base repository, which is the main or the official repository, and my forked repository. Now we should give this pull request a descriptive title. So we can say bugfix in change password form. Of course, we can leave more details and then create the pull request. Now the maintainer of this repository, in this case myself, is going to get notified. So I'm going to come back here and have a conversation with the person who suggested these changes. So just like before, we can have a conversation. The maintainer can request changes and the contributor can push new commits. At some point, when the maintainer is happy, they can come over here and merge this pull request. Now here's the interesting part. Currently, I'm logged in using my Code with Mosh account. So I'm a contributor to this repository. Now look, I cannot merge and close this pull request. Only the maintainer can do this. So on this other browser window, I'm logged in using my personal account. And look, we have 4 pull requests. And here's the last one that I just created using my other account. So I can look at this pull request, go through changes with the contributor. At some point when I'm happy, I can merge and close this pull request. So here's the repository for an open source project. We forked this repository to contribute to it. Now there's a problem. This forked repository is not connected to the original or the base repository. So from time to time, it can get out of sync with the base repository. If other people contribute to the base repository and add new commits to the master branch, we are not going to be aware of those new commits. In this lesson, I'm going to show you how to keep this forked repository up to date. So in this local repository on our machine, we have a reference to our forked repository called origin, right? We can add another reference to the base repository and then use the pull command to bring in the new commits, and then we can push them to our forked repository. As simple as that. Let's see this in action. Earlier, we briefly talked about the remote command. With this command, we can manage the remote repositories. So currently we have a single remote, that is origin. We can run git remote -v, that is short for verbose, to see more details about these remote repositories. So here we have two channels, fetch for getting new objects and push for pushing objects. Both these channels are mapped to this URL. Now to add a new remote, we type git remote add. We give it a name like base, or a lot of people like to call it upstream. You can call it whatever you want. It doesn't really matter. Now we need to grab the URL of the base or the original repository. So here on my personal GitHub account, here's our Viddler repository. I'm going to grab the URL and then paste it over here. Good. Now let's look at our remote repositories. So we have origin and upstream. Once again, we can run remote -v. So you can see origin is pointing to Vidly in my Code with Mosh account, whereas upstream is pointing to Vidly in my personal account, okay? Now let's say we made a mistake and we want to rename this remote repository. We simply type git remote, rename. We want to rename upstream to base. That's better. If you're done with the remote, we can simply remove it. We type git remote rm, and then we type the name. All right, so we're done here. Now I'm going to go to my original or the base repository and make a new commit. So here on my personal account, I'm going to edit this README file. So let's add a new line of code and then make a commit. Good. So we added a new commit to the master branch of the base repository. Now I'm going to switch to my forked repository. Now on my Code with Mosh account, look over here. GitHub is saying that this branch, our master branch, is one commit behind the master of the base repository. So back in the terminal, we need to use the fetch or the pull command to bring in the new commit. So I'm going to use fetch for now. Now, early in the section, we used the fetch command without specifying the name of the remote. And I told you that if we don't supply the name of the remote, by default, origin will be assumed. Now, in this case, we don't want to fetch the commits from origin because that is our forked repository. We want to get the new commits from the base repository. So here we type base. Good. So we got a new branch called base/master. Now let's look at our history. So here's our local master branch, and here's the master branch of the base repository. So our local master is behind the master of the base repository. So we should merge base/master into our local master. So first we switch to master and then run git merge base/master. Now in this case, because the local master is not diverged from the remote master, we're going to have a fast forward merge. Take a look. There you go. Fast forward. Now let's look at the history one more time. Okay, so now our local master and base/master are pointing to the same commit. Beautiful. So our local repository is in sync with the base repository. Now we need to push the changes into our forked repository. So git push. Now, back on my Code with Mosh account on GitHub, when I refresh the page, this notice is going to go away. Take a look. Now GitHub is saying that this branch is even with the master of the base repository. Beautiful. So this is how we can keep a forked repository up to date. Now back to the terminal, it's always a good practice to merge the master branch into your local feature branch because this will reduce the chance for conflicts in the future. If there are changes in the master that will affect your work, you want to make sure that your work is on top of those changes. So we're going to switch to our bug fix branch and then run git merge master. We're going to bring in the changes in master into the current branch. Now look, we have a conflict. So by resolving the conflicts locally at this point in time, we'll reduce the chance for future conflicts when the maintainer of the project wants to merge and close our pull request. Let's see how we can work with remote repositories here in VS Code. Unfortunately, we have limited collaboration tools here compared to GitKraken, but let me walk you through the tools we have here real quick. So we go to GitLens. We talked about this earlier in the course. We can right-click on our repository. Here we have fetch, pull, push, and push force. Now, one thing that I like about GitLens is that it tells us how far we are behind or ahead of a branch in origin. So we're currently on the bug fix branch. I'm going to create a new commit, and then GitLens will tell us that we are one commit ahead of origin/bugfix. Take a look. So I'm going to change our README file and add a new line. Save. Now let's commit it and say update README. Good. Now back in GitLens, take a look. GitLens is saying we're one commit ahead. We can expand this folder and see the commit that we have to push to origin. So we can click on this icon and push this. Here we have three options. We can do a regular push, we can do a force push, or cancel. As I told you before, you should not really use a force push that often unless you have screwed something up. So let's go with a regular push. Good. Now the first time you're going to see this pop up saying the extension GitHub wants to sign in using GitHub. So let's allow that. Now we have authorized Visual Studio Code to access GitHub. Let's go with that. And then confirm. Here we have to enter our password. Okay, perfect. Now back to VS Code. It's saying that GitHub authentication wants to open a URI. That's totally fine. Let's open it. Good. Now we have this prompt here saying, would you like code to periodically run git fetch? I find this pretty useful because it tells us how far we are behind origin. So let's allow that. Good. So we're done with pushing. Now, unfortunately, here we cannot push tags or branches, at least not at the time of recording this video. So to push a branch or a tag, we have to go back to the terminal. Another tool we have here is remotes. So here we can see we have two remotes, base and origin. We can add a new remote or rename or remove an existing one. So these are pretty much all the collaboration tools we have in GitLens. GitKraken is a lot better. We'll look at that next. Now let's look at the collaboration tools in GitKraken. So currently we are on the bug fix branch. We can right-click this branch or any of the branches. Here we have pull, push, and set upstream. With set upstream, we can map a local branch to a branch in a remote repository. Now here, unlike VS Code, we can push our branches and tags. So I'm going to create a new branch off of master. So I'm going to right-click this commit, which is the last commit on master. Then create a new branch called feature. All right. Now let's make a small change and add a new commit to this branch. So I'm going to go to README file and write something here. Save. Now let's make a commit and say update README. Good. So our feature branch has moved forward. Now we can push this branch directly to our GitHub repository. So right-click, push. GitKraken is asking the name of the remote branch. So I'm going to accept the default value here, that is feature, submit. Now the first time we want to push, we have to get an authorization token. Here we have three options: refresh token, retry without OAuth, and cancel. I'm going to refresh my token. Just like before, we have to authorize GitKraken to access GitHub. So let's continue and confirm. Good. Now back to GitKraken. We pushed successfully. Beautiful. Pushing tags is exactly the same. So here on master, I can right-click and create a new tag. Let's call that version 1.0. Now we can right-click this tag and push it to a remote repository. Here we have two remotes, base and origin. We can push to one of these repositories or to all of them. So GitKraken has a lot more features than GitLens. Here we can also manage our remotes. So on the left side, we currently have two remotes, base and origin. We can add a new remote, pretty straightforward. One more thing I love about GitKraken is managing pull requests. So here we have another panel for our pull requests. So here are all the pull requests we have in our base repository. We can easily create a new pull request. So let's say we're done with this feature branch. Now we want to start a pull request and tell the maintainer of this project, bring our changes into the original repository. So we right-click this branch and then start a pull request to base from origin/feature. Take a look. So we are starting a pull request to merge the feature branch of our forked repository into the master of this base repository. Now, just like before, we can give this pull request a title, a description, and then create the pull request. Perfect, we're done. Now here in the original or the base repository, we can see our new pull request. It's right here. One of the great but also dangerous features of Git is that it allows us to rewrite our history. We can drop or modify commits, we can combine or split them, and so on. That's what we're going to talk about in this section. We're going to start off by talking about why and when to rewrite history. Then I'm going to show you how to undo or revert commits. We already covered these before, but we're going to revisit them with a bit more depth. Next, we're going to learn how to use interactive rebasing to rewrite history. With interactive rebasing, we can modify commits, drop them, combine or split them, and so on. We're also going to talk about recovering lost commits. There are a lot of fun things we're going to talk about, so let's jump in and get started. Let's start off by talking about why we need to rewrite history. Well, we have to ask, why do we need the history in the first place? We need it to see what was changed, why, and when. If our commit messages are not meaningful, or if our commits are too large and contain unrelated changes, or if they're too small and scattered all over the history, then we're not going to be able to extract meaningful information from the history. We want a clean, readable history that tells the story of our project, how it's evolved from day one. That's where rewriting the history comes in. If you have small related commits, we can squash them into a single commit that represents a logical change set. On the other hand, if you have a large commit that contains a lot of unrelated changes, we can split that commit into a bunch of smaller commits, each representing a logically separate change set. We can also reward commit messages so they're more meaningful. If we made commits by accident, we can drop them. We can also modify the content of our commits. So if you forgot to include a file in a commit, we can go back and modify that commit. These are the operations we can perform in Git to produce a clean, readable, and meaningful history. But rewriting history can be a dangerous operation, and you need to know what you're doing before touching the history. That's what we're going to talk about next. So I told you about the benefits of rewriting history, but before doing so, you should remember the golden rule of rewriting history. Don't rewrite public history. This basically means if you have pushed your commits to share your work with others, those commits are considered public and you should not modify them. Let me explain why. Let's say our local and remote repositories are in the same state. They have the same history. And now we want to modify B. Here's what you need to understand. Commits in Git are immutable, which means once we create them, they cannot be changed. So if we try to modify B, Git will create a new commit, let's call it B star. So B is going to stay in Git's database in case we screw something up and we want to recover it later. Now let's say we want to do a push to share our change with others. What do you think is going to happen? Git is going to reject our push. Can you tell why? At this level, you should be able to answer this question. If not, pause the video and think about it for a few seconds. Here's the reason. Look at the shape of our history on the left side. Our master branches have diverged. This is exactly the same scenario where we try to push after someone else has pushed to origin. So there are some changes in origin/master that don't exist in our master. In this case, first we have to merge origin/master into our local master, and then we can do a push. Now our local and remote repositories have the same history. But look at what we have done here. We have created this non-linear, noisy history. These two commits, B and M, are completely unnecessary. We wanted to modify B and replace it with something better. So why should we keep it in history and share it with others? So now let's look at an alternative solution. We're back in the previous state before we did a push. So if we do a push, our push is going to reject it. Here we can use the force option and force Git to overwrite what is in origin with what we have locally. So in origin, Git is going to drop B and replace it with B star. And then in our local repository, Git is going to attach origin/master to B star. Now we have a simple linear history. So you might think this is great. We should use the force option all the time. That is not true. Let's forget about our local repository for a second. Imagine here's John's repository before we did a push. So John is not aware of our new commit, B star. In his repository, he only has A and B. So he adds a new commit on top of B, and then he tries to do a push. What do you think is going to happen? You know the answer. John's push is going to get rejected because once again, his master branch is diverged from origin/master. So there are some changes in origin, in this case B star, that John doesn't have in his local repository. So first he has to do a pull to bring in B star and then merge it with his master. Now he can do a push to share his work with others. But look, once again, we have created this noisy, nonlinear history. So remember the golden rule. Don't rewrite public history. Once you push your work, it's public, it's final. So you should not change it unless you have a strong reason for doing so. Rewriting the private history in your local repository is perfectly fine. And in fact, it's actually a good practice. So you should always clean up your work or your private history before sharing it with the rest of the world. So back to our repositories. Currently, both our local and remote repositories are in the same state. Now let's say we add a new commit on top of B. This new commit is private because we haven't shared it with anyone else. We haven't pushed it yet. So we can change the commit message or the content. We can even drop this commit. No one is going to get affected. In this section, we're going to work with a different repository called Mercury. If you want to follow along with me, you can get this repository right below this video. Now, let's look at our history. So here's our initial commit. After that, we have render restaurants, the map. Here we have a wording issue. The word on is missing. So the message should have been render restaurants on the map. So later we'll come back and fix the wording issue. After that, we have fix a typo. This is a common issue that I see quite a lot in people's repositories. Technically, this commit shouldn't be here because we shouldn't have made the typo in the first place. So commits like this are just noise in the history. So later I will show you how to combine these two commits to make our history clean and readable. Now look at the next commit. Change the color of restaurant icons. What's the problem with this? Well, once again, this is part of the same unit of work. So ideally, we should combine all these three commits into a single logical commit. Next, we have add a reference to Google Map SDK. What do you think is the problem with this commit? The problem is the position of this commit in the history. Because here we're rendering the restaurants on Google Map, but then we're adding a reference to Google Map over here. So that means if we check out this commit on its own, our application is not going to work because at this point in time, we don't have a reference to Google Map. So here we have two solutions. We should either move this commit down and put it before rendering restaurants, or we can combine these two commits together. After that, we have a work in progress commit. Again, very common issue. I see it all the time. Commits like this are just noise in history. Later in the future, let's say a week or a month from now, if we look at our history to see what was changed and why, we're not going to extract meaningful information from commits like this. So we should either drop this commit or change its message. Now look at the next commit. Update terms of service and Google Map SDK. Here we have a commit that combines two separate kinds of changes. Updating the terms of service got nothing to do with updating Google Map version. So ideally, we should split this commit into two separate commits. Next, we have another work in progress commit, followed by a commit with a mysterious message. What does period mean here? Nobody knows. So once again, we should either drop this commit or change its message. So throughout this section, I'm going to show you various tools to clean up this history. We're going to start off by undoing the last two commits. We'll do that next. Let's say we decided that this last commit over here is useless and we want to undo it. Here we have two options. If we have pushed this commit to a remote repository, chances are other people have based their work on top of this commit. So we shouldn't remove this commit. Here we should use the revert command, and this will create a new commit that will undo all the changes in this commit. So we type git revert head. We'll talk about this in more detail in the next lesson. But let's say we haven't pushed this commit, so it only exists in our local repository. Here we can use the reset command to remove this commit from the history. Now, I know that we have talked about this before, but let's revisit it one more time because I want to make sure you really understand how it works. So we type git reset -- hard. I'm going to talk about this option in a second. And then we type the target position for our head pointer. So we want to move the head pointer from this commit to the commit before. So we type head ~1. Now, what is the hard option? Well, let's say we have two commits in our repository, A and B is the last commit because head is pointing to it. Now look at our working directory and the staging area. In both these areas, we have the same code that we have in our last snapshot, that is B. Now if we reset the head using the soft option, Git will simply move the head pointer to the target location. But it's not going to touch our staging area and the working directory. Now what is this state? This is the state before we committed B. So we have some changes in our working directory and the staging area, but we haven't committed these changes yet. So this is the effect of the soft option. Now if we use the mixed option, Git will take the latest snapshot, that is A, and put it in our staging area. What is this state? This is the state before we staged our new changes. So we have some new changes in our working directory, but we haven't staged those changes yet. This is the effect of the mixed option. Now if we use the hard option, Git will take the latest snapshot and put it in our working directory as well. Well, more accurately, it will put it in both our working directory as well as the staging area. So our new changes in our working directory are gone. So let me show you a simple way to understand and memorize the difference between these options. If we use the soft option, Git will only remove the commit, but it's not going to touch our staging area and the working directory. So we're going to have some changes in the staging area ready to be committed. If we use the mixed option, we go one step back. So our changes in the staging area will be unstaged. So we'll have some local changes in our working directory. And if we use the hard option, we go even one more step back. So Git will discard our local changes. This is how I've memorized the difference between these options. So let's see this in action. Before resetting the head, let's look at the content of the latest commit. So git show head. In our last snapshot, we simply added the word test in this file, terms.txt. Now let's reset the head using the soft option. So our last commit is going to go, but this change is going to stay in the staging area. So git reset -- soft head ~1. All right, look, we have some changes in our staging area. We can verify it by getting a short status. So we have a green M, which means we have some changes in terms.txt. Now we can compare the staging area with the latest snapshot using the diff command. We talked about this before. So git diff -- cached. So here's the change in our staging area. Beautiful. Now if we use the mixed option, Git will unstage our changes. So before running git reset, let's look at our log one more time. All right, look, head is currently pointing to this commit. So our last commit is gone. Now let's type git reset -- mixed head. Note that I'm using head and not head ~1 because I want to keep head where it is. It's pointing to this commit. So when we use the mixed option, Git will take the snapshot that head points to and put it in the staging area. So this is going to unstage our changes, okay? And by the way, mixed is the default option, so we don't have to type it. Look, Git has unstaged our changes. So let's run a short status. Now we have some changes in our working directory. We can compare our working directory with the staging area using the diff command. So git diff without any arguments. There you go. So here's the change in our working directory. Now, if we use the hard option, we go even one more step back. So this local change will be gone. Git reset -- hard head. Our local change is gone, and we have a clean working directory. Let's say we have pushed all these commits to a remote repository, and now we want to undo one or more of them. As I explained before, resetting the head is not an option here because we don't want to drop the commits that we have shared with others. So we have to use the revert command. Now, let's say we want to revert this commit over here. We type git revert head. We can also revert an earlier commit, like head ~2. This will revert this commit over here. We can also specify a range. Let's say we want to revert all the last 3 commits. First, we look at the parent of this commit. So that is this commit over here. So here we say revert head ~3 to head. Here's the tricky part. When we say head ~3 to head, we're referencing this range, but Git will actually revert the last 3 commits. So it's not going to include this commit over here, okay? Now when we run this command, Git is going to revert each of these commits one by one. Take a look. Let's go. All right, first it's going to revert this commit. I'm going to keep the default message as is. So let's close this window. Now Git is reverting the next commit. Once again, I'm going to keep the default message. So let's move on. And here's one more revert operation. Let's go. All right, reverting is done. Now let's look at our history. Look, we have 3 revert commits, and this is very ugly. It's adding so much noise in our history. Wouldn't that be better if we reverted all these commits using a single commit? Let me show you how to do that. First, I want to reset the head to this position to get rid of these revert commits. So git reset --hard head ~3. Let's look at our history one more time. So we're in the same state as before, and we want to revert the last 3 commits. We type git revert. Now we're going to use an option called no commit. With this option, Git will simply add the required changes in the staging area. So for every commit that we're going to revert, Git will figure out the changes that need to be undone. Then it will apply those changes in the staging area. That's just like before. We're going to specify our range. So head ~3 to head. Now we can simplify this by dropping the second head. So with this, we're essentially reverting the last 3 commits. Take a look. So Git removed this file because we added this file in one of the last 3 commits. Now look, we have some changes in our staging area. So git status -s. Here's the reverse of all the changes across the last 3 commits. Now if you screwed something and we want to get out of this state, we can type git revert abort. Or if we're happy with our changes, we can use the continue option. Now in this case, I don't want to accept the default message because we are reverting multiple commits. So we should write a message that better describes the commits that we're reverting. In this demo, I'm going to say revert bad code. Save, close. All right, reverting is done. Let's look at our history. Now we have a single revert commit. Beautiful. So we can push this to the origin and share it with others. Sometimes we may screw up while resetting the head. Let me give you an example. So here's our history. I'm going to run git reset hard head ~6. Let's say this is an accident. Now let's bring up the history again. What happened to our commits? You may think that we have lost our commits. Well, I've got a good news for you. With Git, we don't really lose anything. All the information about our project history, all the commits that we have created, all of these objects are stored in our repository, even if we don't see them when looking at the history. So Git keeps all these objects for a while, and if they're not used anymore, then it will garbage collect them. So how can we recover the lost commits? Well, we have a great tool here called reflog. This is basically a log of how a reference has moved in our history. If we don't supply any options here, Git will show how the head pointer has moved in our history. Take a look. Now you might think this looks like a scary movie, but trust me, this is easier than you think. So from the top, look at the first entry in this log. Every entry has a unique identifier. Here's the unique identifier of the first entry. Here's the unique identifier of the second entry. Now, in front of the unique identifier, we see a description of what happened. So just a few seconds ago, we used the reset operation to move the head to this new position. Now, after this operation, now head is pointing to this commit over here. We can verify it. So look at our history. Head is here and is pointing to this commit, AF26. We can verify it here. Now look at the second entry in the log. Before the reset operation, we made a commit with this message, revert bad code. After this operation, the head pointer was at this location. So to recover the lost commits, we can reset the head back to this location. So I'm going to copy this. Here we can use the commit ID or the unique identifier of this entry. So we type git reset hard. In this demo, I'm going to use the entry ID. Good. Now head is at this location called revert bad code. Let's look at our history one more time. All our commits are back. Beautiful. Now we can use the ref log to see how other pointers have moved in our history. So let's say we have a branch called feature. We can type git reflog show feature, and this will show the history of the feature pointer. There are a lot of cases where we make a commit, but then we realize that we made a mistake. Perhaps we left a typo, or we accidentally included a file in our commit. In these situations, we don't really need to make another commit. We can amend or modify the last commit. Let me show you. So let's echo cafes to map.txt. Now let's make a commit and say render cafes on the map. Good. Now let's say we made a mistake and we should have echoed blue cafes on map.txt. So let's open map.txt and make the required changes. Blue cafes. Good. Now back in the terminal, first we need to stage the changes. So git add period. Good. Now to amend the last commit, we type git commit -- amend. We can supply a new message, or we can just enter and accept the previous message. I'm happy with the message, so let's close this. Back in the terminal, our last commit is amended. Just remember, we didn't really modify the last commit because, as I told you before, commits in Git are immutable. So even though on the surface we amended the last commit, Git actually created a new commit, okay? Now, let's look at the history. So here's our last commit. Let's look at the content of this commit. So git show head. Take a look. Now we have blue cafes. Now, as another example, let's say we forgot to include a file in the last commit. How can we do that? The exact same way. So I'm going to echo hello to file1.txt. Now let's stage the changes and amend the last commit. We're going to accept the same message. So let's move on. Now, let's look at the history one more time. Here's our last commit. We didn't add an additional commit. Let's look at the content of the last commit. So here we have two changes. We introduced a new file, file1.txt, with this content, and we added this new line to map.txt. Perfect. Now, let's say we accidentally included file1.txt in the last commit. How can we remove it? Well, earlier we talked about resetting the head. I talked about 3 different options: soft, mixed, and hard. I told you that if we use the mixed option, Git is going to unstage our changes, but all of our changes are going to stay in our working directory. So I'm going to reset the head using the mixed option to head ~1. Now our working directory is dirty, so let's run a short status. We have 2 changes. We have some modifications to map.txt and a new untracked file. Let's say we don't need file1, so we can run git clean fd. We talked about this earlier in the course. With this, we can remove untracked files from our working directory. All right, so file1 is gone. We are left with the changes in map.txt. So let's stage the changes and then make a commit. Now here, I'm not going to use the amend option because we've removed the last commit by resetting the head pointer. So here we should create a new commit and say render cafes on the map. So this is how we can amend the last commit. But how can we amend an earlier commit? We'll talk about that next. Let's see how we can amend an earlier commit. So look at this commit over here. Add a reference to Google Map SDK. Before going further, let's look at the content of this commit. So I'm going to copy the commit ID. Now let's run git show. So in this commit, we're adding this line to package.txt. Now let's say we forgot to include the license for Google Map. So we want to go back in history and amend this commit. Now let's pull up the history one more time. So to edit this commit, we're going to use interactive rebasing. As you learned earlier in the course, with rebasing, we can replay a bunch of commits on top of another commit. So here we're going to replay this commit and all the future commits on top of the parent of this commit, which is this commit over here. So I'm going to copy this commit ID. Now let's run git rebase -i for interactive. This basically means that we're going to interact with the rebase operation. So we're going to stop it, make changes, and continue. Now we paste the commit ID. All right, take a look. What we have here is a script. It contains a series of instructions about the rebase operation. So here we have instructions or commands like pick. Down here, you can see a legend of all the supported commands. So we have pick, reward, edit, and so on. As we go through this section, you're going to learn more about these commands. So in the script, we have all the commits that we're going to replay listed from the oldest to the newest. So up here is the commit that we want to edit, and down here is the latest commit. Now, I'm going to change this instruction from pick to edit. We can also edit multiple commits if you want to. In this demo, I'm going to edit only a single commit. So revert, save the changes. Now, at this point, you know that when we edit a commit, Git actually creates a new commit. Now, here's the interesting part. In this demo, even though we're editing only a single commit, all the commits that come after this commit will also be edited, or more accurately, recreated. Let me explain why. Imagine we have 4 commits in our history and we want to amend B. Git creates a new commit, let's call that B star. Now, C should point to B star, right? But this is not possible because commits are immutable, so the parent of C cannot be changed. In this situation, Git creates another commit that looks exactly like C, but it points to B star. By the same token, Git will create another commit that looks like D, but points to C star. So even though we only modified B, all the subsequent commits had to be modified or more accurately recreated. So remember, rebasing is a destructive operation because it rewrites history. So you should use it only for the commits that you haven't shared with others, okay? All right, back to our script. We're going to edit the first commit in this list. Now, when I close this window, the rebase operation will start. Back in the terminal, take a look. You've stopped at this commit. Add a reference to Google Map SDK. So because we told Git that we want to edit this commit, Git stopped here. Now we have a chance to amend this commit. So we're going to make the necessary changes. Then we're going to amend this commit and then continue with the rebase operation. So I'm going to echo license to license.txt, then add this change and amend the current commit. We're going to accept the previous message. That's good. Now, back in the terminal, we made a new commit. Now let's run git log, one line, all graph. Let's see what's going on here. We have 2 branches. In this branch, we have all the commits that we wanted to replay. Down here is the first commit. That is the commit that we wanted to edit. We modified this commit and Git created another commit with the same message up here. The rebasing operation stopped. So once we continue rebasing, all the subsequent commits will be replayed on top of this new commit, and then this branch will be discarded. Take a look. So we type git rebase -- continue, or if we screw up, we can always abort the rebase operation and go back to the previous state before we started the rebase. So let's continue rebasing. Good. Now let's look at the log one more time. We have a simple clean history. Now, if you paid close attention, you probably noticed that the commit IDs are different. So here's the new ID of the commit that we changed. Let's copy this and run git show. So now in this commit, we have 2 changes. We introduced a new file, license.txt, and we added this line to package.txt. Perfect. Now let me show you something interesting. I'm going to pull up the history one more time. So we added license.txt in this commit. Now, what if we check out the commit that was introduced later? Let's say this commit. If we check this out, you will see that our license file is still there, even though it was not in the original work in progress commit. So let's check out this commit. The head pointer is detached. Now let's look at the files in our project. Here's the license file that we just added. So here's what you need to take away. The change that we introduced in one of the earlier commits carried on throughout the rest of the history. All right, we're done here. So let's check out master. Now let's see how we can drop a commit. So let's say we want to drop this commit over here, our first work in progress. But before doing so, let's look at the content of this commit. So I'm going to copy the commit ID. Now let's run git show. All right, in this commit, we introduced a new file called terms.txt. And in this file, we added this line, draft. Now let's look at the next commit. So back to the log. Here's the next commit, update terms of service. So once again, let's look at the content of this commit. Git show. Here we have two changes. We have an update in package.txt. So we're updating Google Map version. We also have a change in terms.txt. So we replaced draft with completed. Okay. So here's the interesting part. Let's pull up the history one more time. What do you think will happen if we try to drop this commit? We're going to end up with a conflict. Here's the reason. By dropping this commit, we're essentially saying we never introduced this change. So we never introduced a file called terms.txt. Now, in contrast, the next commit says, hey, I have an update for terms.txt. So Git will not be able to replay all these commits. It's going to get confused. This is where we need to jump in, resolve the conflict, and then continue the rebase operation. So here's the commit we want to drop. We should start our rebase operation with the parent of this commit. So we type git rebase-i. Here's the commit. Then we type ~1. Or we can also use a caret. That means the parent. So let's go with that. Here's the commit we want to drop. We can change the command from pick to drop, or we can just delete this line. Now, save the changes and back in the terminal. All right, look, we have a conflict, but don't get scared. This is much easier than you think. So let's run a short status. What's going on here? We have some changes in the staging area. We have an update to package.txt, and we have some local changes that are not staged. On the one hand, we're trying to delete this file. On the other hand, we're trying to update it. So these changes that you see here are actually going to go with the next commit. So let's pull up the history one more time. All right, look, the head is currently at this location. So it's in the detached mode. We told Git that we want to drop this commit. So Git is trying to undo the changes introduced in this commit. In this case, adding this new file, terms.txt. Now the changes that we have in the staging area are going to go when replaying the next commit. In this commit, we had two changes. We updated terms of service and Google Map SDK version. So now we need to resolve the conflict. We type git merge tool. We have two types of changes, a deletion and a modification. In this case, we're going to go with the modification because we want to keep that file in our history. So let's go with that. Now, let's get a short status again. So we have two changes in the staging area that are going to go with the next commit. So we're ready to continue the rebase operation. Git rebase -- continue. Also, as I told you before, if you screw something up or if you have a nasty merge conflict, you can always abort and go back to the state before you started the rebase operation. It's very easy. So let's continue rebasing. All right, here's the message for the next commit, update terms of service and Google Map SDK. So let's close that. We're done with rebasing. Beautiful. Let's look at our history one more time. So our first work in progress commit is gone. Now, as another example, I want to drop these two commits as well. So these are the last three commits. We can run git rebase-i head ~3. So we see the last three commits. Now I'm going to delete these two commits, save the changes, back in the terminal. In this case, we didn't have any conflicts. So let's look at our history one last time. All those ugly commits are gone. Next, I'm going to show you how to reword commit messages. Now let's see how we can reword commit messages. So earlier I told you that here we have a wording issue. Render restaurants on the map. So the word on is missing. Once again, we're going to start interactive rebasing. So I'm going to grab this commit ID. Now let's run git rebase-i, this commit, caret to represent its parent. All right, here's the commit we want to reword. Now we're going to replace the pick command with reword. We can also reword multiple commits. For example, let's say here we forgot to include the Google Map SDK version. So I'm going to use the reword command here as well. Good. Now when I close this window, Git will replay each of these commits. For every commit that we want to reword, it's going to stop and give us a chance to change the message. So close. All right, here's the first commit we wanted to reword. So render restaurants on the map. Good. Save. Close. Git replayed the other commits, and then it stopped at this second commit we wanted to reword. So here I'm going to add the version. Save. Close. And rebasing was successful. Beautiful. Now let's pull up the history. Now I want to emphasize this one more time. In this demo, we reworded this commit, which caused this commit to be recreated. And that means all the subsequent commits were also recreated. So we have rewritten history. As I told you before, rewriting history is a destructive operation. You should do this only with the commits in your local repository. Next, I'm going to show you how to reorder commits. Earlier, we talked about the problem with this commit. Add a reference to Google Maps SDK. The problem with this commit is its position in the history, because we're adding a reference to Google Maps after implementing a feature that is dependent on Google Maps. So if we check out this commit and restore our application to this point, our application is not going to work, because at this point in time, in this snapshot, we don't have a reference to Google Maps. So in this demo, we're going to grab this commit and move it down. It's super easy. So once again, we're going to start our rebase operation. So I'm going to grab the ID of this commit so we can see all the commits in our rebase script. Git rebase-i. Good. So we can see all of our commits from the oldest to the newest. Now I'm going to grab this commit, add a reference, and move it up. In VS Code, we can move a line up by pressing Alt and the up arrow. So like this. Now this commit is in the right position. So save the changes, close. Rebasing completed successfully. Now let's look at the log one more time. So first we add a reference to Google Maps, and then we render restaurants on the map. This is much better, but we're not done yet. In the next lesson, I'm going to show you how to squash a few commits together. Now look at these three commits. Render restaurants on the map, fix a typo, and change the color of restaurant icons. All these changes are logically part of the same unit of work. So ideally, we should have encapsulated all these changes inside a single snapshot. But sometimes that's not possible because we work incrementally, and as we learn more about a problem, our solution changes. So we end up with several commits that are logically part of the same unit of work. So let's see how we can combine these commits together. So here's the first commit we want to work on. We're going to start with the parent of this commit, which is this commit over here. So copy this, git rebase-i. All right. So here's our first commit, render restaurants on the map. For the second command, I'm going to replace the pick command with squash. With this, Git will combine this commit with the previous commit. Now for the third commit, once again, we're going to use the squash command to combine this commit with the previous commit, which is the combination of these two commits. Now, if the commits that we want to squash are not directly next to each other, we can reorder them first and then squash them. So let's save the changes, close. Now Git is suggesting this commit message, which is the combination of the messages for all these three commits. So we have render restaurants on the map, fix a typo, and change the color. I'm going to discard these commit messages and keep the original message. Save, close, and we're done with the rebase operation. Let's look at our history. Our history is much cleaner now. We have a reference to Google Maps SDK. After that, we render restaurants on the map. Then we update terms of service and so on. Now we have another command similar to squash called fixup. Let me show you how it works. So first I want to restore our history to the state before we started the squash operation. So we bring up our reflog. Look what we have here. The last entry represents the completion of the rebase operation. Before that, we had rebase pick again, followed by a couple of squashes, and this is where we started our rebase operation. Now we want to go to the previous state in history. So after we finish the previous rebase operation, so I'm going to copy this commit ID. Now, let's reset the head. Good. So to verify, let's look at our history one more time. We can see our original commits, like fix a typo and change the color of restaurants. Now let's start the rebase operation one more time. So I'm going to grab this commit ID and start an interactive rebase. So just like before, we're going to pick the first commit, but for the second commit, instead of squash, I'm going to use fixup. When we use fixup, Git doesn't take the message of this commit. So let's use fixup for the third commit as well. Save. Now when I close this, Git will take the message from the first commit and apply it to the commit that combines all these three commits. So we don't have a chance to craft a new message. Take a look. Close. We successfully completed rebasing. Next, I'm going to show you how to split a commit. Now look at this commit up here. Update terms of service and Google Map SDK version. These are two completely separate changes. Updating the Google Map version has nothing to do with updating terms of service. So we should split this commit into two separate commits. So I'm going to grab this commit ID. Now we start interactive rebasing from the parent of this commit. All right, here we're going to use the edit command that you have seen before. So when we close this window, Git will stop the rebase operation at this commit. Here we have a chance to split this commit into two separate commits. So close, back in the terminal, look, we stopped at this commit, update terms of service and Google Map version. Now let's look at the log one more time. So head is currently pointing to this commit. We can use the reset command to go back to the state before we made this commit. So we can type git reset --soft head ~1 or head caret. With this, we go one step back before we made this commit. So our changes are going to be in the staging area. Here we can unstage some of the changes and make a separate commit. Alternatively, we can go 2 steps back. So we're going to unstage our changes, but our changes are going to be in the working directory. Then we can stage and commit them separately. I'm going to go with this. Also, as I told you before, mixed is the default option. So we can simplify this command to git reset head caret. Okay, now let's get a short status. So we have 2 kinds of changes. We have some updates in package.txt and a new on-track file. So I'm going to stage package.txt and make a commit. Here we can say update Google Map SDK version. We can also say from 1.0 to 2.0. All right, now let's look at the history one more time. We have divergence. So we started our rebase operation at this commit. We wanted to replay these 2 commits. Now git stop before replaying this commit. Here we added a new commit, and that's why we have divergence. Now let's go ahead and make another commit for updating the terms of service. So we have a new on-track file. We can add it in the staging area and then make a commit. Here we can say update or add terms of service. Good. So we made another new commit that was not part of the history. Let's look at our log one more time. So here are the 2 new commits that we have created, and this is the commit that we're trying to edit. Note that in this demo, I didn't use the amend option because I didn't really want to amend or modify this commit. I wanted to replace this commit with 2 separate commits. So now when we continue the rebase operation, Git will replay the next commit. So git rebase -- continue. We're done with rebasing. Let's pull up the history one last time. So we have 2 separate commits, one for updating Google Map, the other for adding terms of service. So this is how we can split a commit. Now let's see how we can rewrite history using Gitkraken. So here's our Mercury repository that we started with at the beginning of this section. So all those bad commits that we talked about exist here. Now we want to start an interactive rebasing from this commit. So we right click here and then go to interactive rebase. So we see a similar interface. Here we can see all the commits listed from the newest to the oldest. So for this commit, we can select rewarding and type the new message here. So render restaurants on the map. Update. We're done with this. We can move commits around. So here's the commit that adds a reference to Google Map. We can select this and drop it before rendering the restaurants. We can also squash commits. So I want to squash this commit into this commit. So here we pick squash And now we can visually see that this commit is going to get combined with the previous commit. Also, I'm going to squash this commit into the previous commit. Super easy. We can also drop a commit. So for this commit, I'm going to set the command to drop. Now, when we start the rebase operation, we're going to see the same conflict as before. Because in this commit, we introduced a new file, terms.txt. If we drop this commit, we're essentially deleting that file. But then after this, we have another commit that tries to update that file. So let's go ahead and start the rebase operation. All right, we have a conflict on the right side. You can see we have a conflict in terms.txt. So let's select this. Here on the top, we have a few options. We can keep the modified version or delete the file. In this case, we're going to keep the modified version. So let's go with that and then continue rebasing. Good. So we're done with rebasing. That was super easy. But here we cannot edit a commit. So we cannot split it into two separate commits or amend it. For those cases, you have to go back to the terminal. So we're done with this course. Thank you for allowing me to be your instructor. I hope you learned a lot, and I'm going to see you again in my other courses. If you want to support me, please tell your friends and coworkers about my course and share your feedback on Twitter. I really appreciate your support. So that's it for now. I wish you all the best.